Now that we did dive into data fetching, we of course also want to practice it again. So it's again project time, and we're going to dive back into that events project we worked on before, and we will move away from dummy data, which is hard-coded into our pages in the end, and instead transition to data which we fetch from some data source, like a file or a database, and which we then also fetch such that sites can be statically pre-generated or server-side rendered. Because we're going to have a look at both again, we're going to practice static site generation and server-side rendering, and I will again discuss the differences and when to use which. That is also something we'll practice in this section, of course. And we are also going to revisit client-side data fetching and see when that could make sense. Now for that, I'm back in the events project as we left it. Attached you find my snapshot, and there we can spin up that development server again with npm run dev. If we then visit localhost 3000, we see our events page, and we can explore the individual events and do all those things we already practiced in the last project section. Now, up to this point, of course, all the data is in the end hard-coded into our pages. Actually not in the page components themselves, but we have this dummy data JavaScript file, which, well, holds all that data and then exposes various helper functions for retrieving that data and working with that data. And that ultimately is not really how we now want to work with that. It would be more realistic that this data, our events, are stored in some database or in some file or coming from another API. And here I want to put those events into Firebase, this dummy backend we already used in the last course section, so that we can fetch the data from there. Just so that we have an easy to use backend which exposes an API which we can query. Now I have my sales data in there from the last course section. I'm using the same Firebase project. You could of course also create a new one. Just make sure that you do use the real-time database. I will continue with this one though, and I will add my events here into that same database. So for that, we can click on the plus here next to that database name and give this a name of events, this node, and then add a new nested document in there, which now has basically the event ID as a name, E1 let's say, and then we nest more data in there and we transfer the title into Firebase. So I'll give this key a name of title, and the value then is the title I had here, like this. And now I'm going to add all the other data as well, like the description. So I'll grab that description string here, give this a name of description, paste in that value, and repeat that for the location and so on. Now I don't want to bore you, so I will fast forward here. You of course can migrate this on your own. Just pause the video and migrate it until you're done. You also don't have to migrate all the data, of course, if you don't want to. I will migrate all the data though, but you can of course also speed this process up a bit and just migrate some data. Important for the images, we want to keep the paths which we used before because it will keep the images local in the public folder. That's not super realistic, and we will re-explore image storage later again, but for the moment let's stick to this setup. So I will just keep the path which points to the locally stored images in the public folder here. So therefore here I now add is featured, set this to false, and now again I will just complete this off screen and I'm back once I migrated all the events. Okay, so I'm done. I copied over all the data here into Firebase, those 3 events, and therefore this is now prepared such that we can query it. That's therefore what we're going to dive in next. Now for this course section, I strongly recommend that you don't continue with me immediately, but that instead you pause and you try implementing data fetching on your own first. Go through those different pages and think about the different data fetching approaches you learned in the last lectures, in the last section. Then add the different approaches which make the most sense to you to the different pages. So look at the pages, evaluate which data fetching approach might make the most sense for the given page, and then add it. Now, once you tried this on your own, definitely go through this module together with me with these modules lectures to see how I solved this and what my reasoning was for fetching data in different ways in those different page components. Now let's start with the starting page. Here on this starting page, we want the featured events. So we need to load those featured events onto this index.js page, so into this index.js component here, this homepage component. The question now is, how do we want to load the data? Now we could do it with client-side data fetching. We could use useEffect with the fetch API, or install and use the useSWR hook here, which we learned about. We could do that, but does this make sense? Is this the best solution here? I would argue that here we actually want to use one of the two forms of pre-rendering instead. So static generation or server-side rendering. Because the starting page, which we're looking at here, this is a page which should be understood by search engine crawlers. It's important that they are able to understand our site and, well, direct traffic to our site. And as a visitor on this page, it would also be nice if we see something instantly. It's also not likely that this data changes multiple times per second or minute even, so there isn't really a reason for loading this on the client side. It's also not some user-specific data, and it's also not data behind a login screen or anything like that. So here I would argue it makes a lot of sense to pre-render this page with some data. That then just leaves one question. Should we use get server-side props for real server-side pre-rendering, where the page is pre-rendered on the server on the fly for every request? Or do we want get static props to pre-render the page during the build process and potentially also on the server if we set revalidate to a certain value so that we have a mostly updated page? I would argue for this kind of page, we don't need server-side rendering. We don't need to pre-render it for every request. Instead, using get static props makes most sense here, I would say. So we can export this async function get static props here in this index.js file, get our context, though here we won't need it, so we can also omit it, and then in here return an object with the props for this homepage component. Now the props should be an object, and in there I want to have my featured events, which now should be fetched from Firebase, not from the dummy data.js file anymore. We're past this world. Now we have the Firebase backend and we want to fetch the data from there. Now, how do we fetch the featured events from Firebase? Actually, when it comes to querying Firebase, you can adjust the HTTP request which is being sent with some query parameters to filter the data you are retrieving. If you search for Firebase real-time database filter, you'll find this retrieving data article. And there you learn how you can adjust the URL to which you send the request with query parameters to, well, filter the data which you're retrieving. And you can filter by specific child keys, look for certain values, and so on. Now you can do that, and feel free to dive into the docs to implement it such that you do filter on Firebase side for retrieving only selected data. I will not do that here because this is not a Firebase course and it's really just a dummy backend. Instead, I will add a new file here, let's say in a helpers folder, a file which I'll name API util.js, so which has utility functions for working with an API. And in there, I will now add a function which gives me the featured events, but I will actually always fetch all events first and then filter them just here in JavaScript. Which is of course not ideal, because it means that we always fetch all the data even if we don't need it. But as I just said, that's just not the focus here. It would be very Firebase specific if we write the Firebase query logic here, and that, well, basically leads nowhere. So therefore, I'll go to dummy.js and copy the getFeaturedEvents function from there and add it here in the API util.js file. But I'll also add another function here, getAllEvents, and in there I will write the logic for fetching all events data from Firebase. So I'll turn this into an async function so that I can use async await here. I'll also convert getFeaturedEvents into an async function. And then here in getAllEvents, I will call fetch, so the built-in fetch API, which is available in the browser and thanks to Next.js also can be used inside of getStaticProps and getServerSideProps. And here we'll then send a request to this Firebase URL, so to this REST API URL, which then triggers Firebase to talk to our database here. There we want to reach out into the events node, so this node which I added here. And then because it's Firebase, we need to add .json at the end here. That's Firebase specific. Now, since we use async here, we can also await this to get our response like this without then. Under the hood, async await still uses then, but we can write it in this more convenient way here. And we can get our data by awaiting response.json. We also might want to implement error handling here, but for the moment I'll skip it. Instead here we then have the data, and as you learned in the last section, Firebase returns your data as an object. So I will transform my events here, I'll add them as an empty array, and then loop through my data, so through all the keys in data, so through all the entries in events, so these are my keys, E1, E2, and E3, and I'll loop through them, and for every key I'll push a new event into this events array, where the ID is equal to key, and where I then want to distribute all the nested data, which is stored under that key, into that events object. And to not manually write all these key value pairs, I'll use the spread operator and just copy everything from data for the given key, so from this nested object here into this object which we push onto events. That should ensure that events is an array full of objects with all these fields here and with an ID field which is E1, E2, or E3. And then I will return events here. Now overall we still return a promise here because of async, but that promise will then resolve to this events array. And in getFeaturedEvents, we can now get all events by awaiting the result of calling getAllEvents. So this function I just worked on, I call it here. Since it returns a promise, I await that promise, which I can because I added async here. Then I have all events and I return all events, filtering for the events that are featured. Again, that means that we always load all events first, but here for this demo, that is okay. Now it's getFeaturedEvents, this getFeaturedEvents, not the one from dummy data, which I want to use in index.js. So here we want to import getFeaturedEvents from, and then I'll dive into the helpers folder into API util. And now here in getStaticProps, we can get the featured events by awaiting the result of getFeaturedEvents. So of calling this function, which we just worked on, which I now imported. We can use await because that is an async function. And then it's these featured events, which I'll set as a value for the featured events prop. Now we can also name this prop just events. It doesn't have to be named featured events. And with that in getStaticProps, we return an object with our featured events in props, and the featured events ultimately are fetched from Firebase. So now in the component function here, which is executed after getStaticProps, we now should accept props, so the props which are set by getStaticProps. And then here we no longer need to call getFeaturedEvents, and we don't want to call it here because we don't want to fetch them on the client. Instead, I just forward props.events, so my events here, to event list. And now let's see if that works. If we save that, if we go back to the starting page and reload, that's looking good. I see my events and I can still click on them. And if I reload and view the page source here, we see that the event data is actually part of that HTML file which was sent back by the server. So pre-rendering this page with the event data worked. And here we are using static generation because we're using getStaticProps. So this applies what we learned with Firebase and with getStaticProps to this home page. Now the starting page is working. What about the event detail page here? This page currently still fetches its data from the dummy data file. It's this event ID, this dynamic page here. And of course here we now also want to get our concrete event, the individual event for which we want to display data, we want to get that from our Firebase backend. Now for this, first of all, we can go to dummy data and copy the getEventById function and add this to the API util.js file. Export it there, but turn it into an async function And instead of dummy events here, we again want to use all events. So just as in get featured events, I'll get access to all events, await this, and then find my single event on the, well, overall events which I got here. Now that's step 1. Step 2 is to use that in the dynamic event ID page. And again, the question is, how do we want to fetch the data? Now we could fetch it on the client side, but that wouldn't make more sense here than it does on the home page. It's still unlikely that it changes a lot, and this page for an individual event is even more important when it comes to search engines than the starting page. After all, it's the single event page that has all the details for an event. So this should absolutely be crawlable. We definitely want to have some data on this page right from the start. So therefore here, I definitely also want to pre-render this page with data. Again, the question is static generation with getStaticProps or server-side rendering with getServerSideProps. And as often, the answer probably is getStaticProps. Because this again is not really a page where we need user-specific data, which changes all the time, or anything like that. So pre-generating it sounds good to me. So in this event ID page here, in this page file, we therefore also want to export the async getStaticProps function again. Here, however, we'll need the context because we'll need to know for which specific event ID we want to load the event data. So we can get the event ID from context, and there the params, and then their event ID, because this here is the identifier I encoded in the file name. This gives us access to the event ID. Once we have the event ID, we want to fetch the single event, and therefore I remove the import of getEventById from dummy data, and instead import getEventById from, going up one level and another level, helpers API util. So from this API util file which sends requests to Firebase. And now we want to use this in getStaticProps to get that single event. For this we await getEventById, because that's an async function returning a promise, and we still pass the event ID to that function. And then here in the end we'll get that event for which we're looking. Now once we got that, we can return our object as we always do with the props key. And then there, my props object will have an event or selected event key, totally up to you, which holds that single event which was identified here. So now inside of my component function, we can now work with that selected event prop. So we should accept props here, and then my event here, which I use throughout this component, is actually props.selectedEvent. Now in this component function, we now no longer need to use the router, the useRouter hook, because we no longer need access to the event ID in there, because data fetching doesn't happen inside of this component function anymore. So the concrete event ID doesn't matter to us here. And if it would, we could get it from this selected event prop, because that holds the entire event which we identified. So we no longer need useRouter here, and we can therefore also get rid of the import, of course. Now with that it wouldn't work though. And do you remember why? Because this is a dynamic page, and there is an infinite amount of possible pages that could be generated. Next.js doesn't know which event IDs it should pre-generate. And as a developer, we typically also don't know that in advance. If we have a dynamic page, maybe with user-generated content, then as a developer, we also can't anticipate which IDs we'll eventually have. That's why we need another function here. We need to also export another async function, the getStaticPaths function. This function will tell Next.js for which parameter values, so for which event IDs it should pre-render this page, and for which IDs it should therefore call getStaticProps and this component function. For this, in getStaticPaths, we have to return an object with a paths key, which holds an array full of objects where we specify our param values. So the first page, which we want to generate, for example, should have a value for the event ID param of E1. That's something we could add here. And now this single page for the event with E1 as an ID would be pre-generated. But as I just said, we typically don't know all IDs in advance. So that's typically not what we want to do. Instead, we want to fetch the event IDs here dynamically as well and derive this paths array dynamically. So for this, what we can do is we can go to API util and use getAllEvents to get all events, then extract their IDs and derive the to-be-generated paths from that. So for this, I'll go back here to event ID, and from the helpers API util file, I will also import getAllEvents. And now here in getStaticPaths, I will have all my events here by awaiting getAllEvents. And then I'll construct my paths array by taking my events and mapping this array of events into an array of objects where every object has a params key, which holds another object, where I then set the event ID to event.id. Event is the single event for which we're going through that events array here. So now paths is exactly the kind of array we need, and hence I'll set paths equal to paths here. With that, if we save this all, if we reload this events page for event E2, we get an error regarding the fallback key. And you might remember that we need to add this fallback key to let Next.js know if there are more possible event ID values, which we did not pre-generate here, so which it should then maybe generate dynamically on the fly, or if we did specify all possible paths here. Now here I did specify all paths, so we can set fallback to false, letting Next.js know that if we try to load this page for an unknown ID, it should show the 404 page. And with that, if we set this and reload again, now it correctly loads the page for E2. And that works for the other event as well. Now if I try E5, which is an invalid ID, I get the 404 page instead, which also makes sense. So with that, we're also handling this dynamic page successfully here. Before we now also dive into the slug page and this index page here for all events, before we do that, let's pause for a second and think about the two pages we worked on. Index.js here on the root level of the pages folder and the dynamic event ID page. Maybe there's something we can optimize, or where we could at least consider optimizations. We implemented static generation on the index.js and the event ID.js pages. Now let's take a closer look. It works, but maybe we can optimize it. For example, on the starting page, so this index.js page, we are pre-generating this page with the pre-fetched data, so to say. But of course, this data will then only update if we build again. So if our page was deployed for a couple of hours or even days, and we have new featured events, we need to redeploy our page to reflect that latest state. That's not ideal. And one possible workaround could be to use get server-side props instead. Then for every incoming request, we would pre-render the page again on the fly. But this would be overkill here. We don't need to pre-generate this for every request. Just a couple of times, maybe after a certain time span. And that's where we can add the revalidate key to this object which we return, side by side to the props key. And we can set this to a value of our choice, to 10 seconds, 100 seconds, 10 minutes, whatever makes sense to you. Now our events and the featured events probably don't change that often. And it's not the end of the world if we did update them and our starting page doesn't immediately reflect this. So maybe every 1800 seconds is a good time span. That means that every half hour we regenerate this page for a new incoming request. And I think that should work quite well here. With that, this page still works, but in production it would be regenerated from time to time, at most once every half hour. Now for event ID, we also could consider revalidating, because there it's similar. If the details about an event changed, we don't reflect this on our page because we never regenerate it. Again, we could use server-side rendering for that, or we add client-side data fetching so that we have some initial data and we then update this with the client-side data. But we could also go for revalidating instead here. And here I will also set revalidate to a certain interval. Now I will not go for half an hour here, because for example, if the date changes, that's more important than the general list of featured events. It's still okay if it's slightly outdated, but I want to be more accurate than on the starting page. So I'll set this, let's say, to 30 seconds, so that if a new request comes in and it's more than 30 seconds since the page was last generated, it will be generated again. I think that's a setting that makes sense here. Of course, you can also go for a different duration if that makes more sense to you though. Or alternatively, you solve this with client-side data fetching in addition to the pre-rendering here. Now I also have an optimization idea regarding getStaticPops. Currently, we're fetching all events here. Now in our case, that's only 3 events. But on a real page, we could of course have hundreds or thousands of events. So fetching all those events to pre-generate all those pages could be a huge waste. That might really be redundant and could lead to performance issues. So in reality, we might want to just pre-render our featured events, because those are more likely to be visited because they're featured on the starting page. So therefore here, in event ID on this event ID page, instead of fetching all events and pre-rendering all the pages, all the detail pages for all events, I will instead just load my featured events and therefore import getFeaturedEvents from the API util helper file, and then just simply execute getFeaturedEvents down there. But now with that, of course, that implies that for some events, the page will not be pre-generated. So if we leave fallback set to false, we'll have an issue. If I click on some event which was not pre-generated, like this event with an ID of E1, I get a 404 error, even though we have data for this event. But we didn't define it in advance, and therefore it wasn't pre-generated. And since we tell Next.js that we did prepare all required pages here, that's what we tell Next.js with fallback false, it shows us a 404 page here. So the correct setting here would be true, telling Next.js that there are more pages than the ones we prepared here. Then it will try to dynamically generate the page if it encounters a page which was not pre-generated before. Now if we do that, it works. Now we see no event found initially until the event was fetched, because we are checking if we don't have an event, and then we show this fallback. And that's good. We should show a fallback content whilst we are waiting for the event to arrive. But here it might be better to show some loading spinner or some loading text instead of an error, because here it's now actually expected for some events which haven't been pre-generated that we don't have them right from the start. So instead of wrapping this into an error alert, I'll wrap this in a regular div instead and give that div a class name of center, which is a globally available class name defined in the globals CSS file. And I'll then say loading instead of no event found. And therefore, now if we reload, we see loading until the event is there. So that's better. Alternatively, of course, we set fallback not to true, but to blocking. In that case, Next.js will not serve anything until we're done generating this page. So if I do that and reload, then loading the page takes a bit longer, but we get the entire finished page right from the start. It's up to you which user experience you want on your page. I'll stick to this blocking approach, but you can go for either of the two. And these were a couple of small optimization steps which I did want to implement. Now with that, let's go back to the 2 remaining pages we have, maybe first to the index.js page in the events folder, and let's make sure we also pre-rendered those correctly with data which is fetched in advance. Try implementing it on your own. We'll do it together in the next lecture. So for the all events page, the question is what we want to do there. And I would say that we probably still want to statically generate this page, so that we want to fetch all the data in advance with getStaticProps. Therefore, just as before on this page, I'll export my async function, getStaticProps, and then in there we want to get all the events and expose them through props to this all events page component. Now we do of course have this getAllEvents function in API util, so we can utilize that and import getAllEvents from not from dummy data, but from helpers API util. And then go down there and get access to all events by awaiting the result of getAllEvents. And then we return an object with a props key where I have my events, which hold my events which I fetched here. Simple like that. And now, since we exposed that through props, we should expect props here, and now use the events from the props. So here I'll set events equal to props.events, or alternatively, we use object destructuring, which is what I will do here. Now we still need the useRouter hook here, because here we're not using it to fetch some ID or dynamic path segment value, but instead we're using it for programmatic navigation, which I still want to enable here. So that stays the way it is. Now we can consider revalidating this page from time to time to make sure that we pick up new events. I think that makes a lot of sense. So we should add revalidate here, and then maybe set this to 60 seconds. So that every minute, if a new request is coming in, we regenerate this page. Now with that, if I reload, this again works just fine. Now it's pre-generated though, which is why in the page source we have all that event data. So that also works. Now last but not least, let's work on the slug, on this slug page, on this catch-all page. That could be a bit more tricky because here we're catching multiple dynamic segments, multiple parameters. So here on this slug page, on this catch-all page, we're currently getting the concrete path values from the router to then get the year and the month and fetch the appropriate events for us here. Now the question is, how do we want to do that in the future with our newly gained knowledge? And we have a couple of options here. We can use getStaticProps to pre-generate this. But of course, for the filtered events, we'll have a lot of different combinations of parameters, 2021 and 1 and 5 and 2 and so on. That's not necessarily an issue though, because we will have to use getStaticPaths anyways. And once we add that, we could only pre-render a couple of those combinations and not all of them, and instead then use fallback set to true or blocking. But how should we decide which paths should be pre-generated? In the end, all possible filters are equally likely to be visited. So I would have a hard time picking a couple of combinations that should be pre-generated. And pre-generating all possible combinations is also not a great option because that could be a lot of pages, especially if we have no year restriction, for example. So getStaticProps might not be ideal here. Maybe here getServer-side-props is better, so that we do indeed fetch the data on the fly for every incoming request, and we then return the page for every incoming request. So let's start with that. In this slug page, I will export an async function called getServer-side-props. And you know that here we get the context. And then here we want to return an object which is similar to the object we return in getStaticProps, with a props key and possibly also with the notFound key and the redirect key if we need it. Now here, from the context, we can get access to the params. So here we can get access to the parameters for which this page was visited. And that's good because now we basically want to repeat what we previously did in our component function. We want to get our year and month and convert that to a number and then validate it and then ultimately get our filtered events. So I will copy all that code, though we're going to edit it a bit, but I'll copy all that code and bring it down there into getServer-side-props. Now here, we're accessing filtered data. That should actually be our params, because up there, filtered data is also just what we read from the router query, which are also our params when accessed through useRouter. So therefore here, I'll rebuild filter data and access params.slug. So we still access .slug because that is our catch-all grouping parameter name, if you want to call it like that. And that will still be an array with multiple values, and we are interested in the first two values, which should be the year and the month, which is why we convert them to numbers and then validate them down there. Now, if validation fails, however, we don't want to return JSX. That's not possible in getServer-side-props. We always have to return an object instead. But if the validation fails, I don't want to return a props object here or a props key. Instead here, I'll then set notFound to true. I want to show the 404 page if an invalid parameter combination is passed in. We could also consider redirecting to some error page if we had one. But here we don't have one. We could add one, but I will not do it here, so I'll comment this out and instead show the 404 error page. Another alternative would be to set some props, like the hasError prop, and then handle this specific prop in our component function to show an error message. And actually, since we do have that error-specific JSX code here, that might actually be the best alternative. So it's still worth knowing the other ones, but I will now not show the 404 page, but instead return my special hasError prop set to true if the validation fails. So that in the component function, in this filtered events page function, we should expect props, and then down there, instead of validating our query parameters, I check if props hasError is true. And if that's the case, I'll show this error message. I think that actually makes the most sense, but you can also go with one of the two alternatives I showed. Now, if we make it past this if check, we do have valid parameter values, and therefore now we want to get our filtered events. For this, I'll go to dummy data and take this getFilteredEvents function and bring that over into API util, maybe down there. Here, we get filtered events by reaching out to dummy events and calling filter on that. Now, just as in the other functions here, I will instead now turn this into an async function, then get access to all events by awaiting getAllEvents, and then using all events here instead of dummy events for filtering. And with that, back in this Slack page, we now want to import getFilteredEvents, not from dummy data, but from the helpers folder and the API util file. And then down there in getServerSideProps, we now get our filtered events by awaiting getFilteredEvents, to which we still pass this object with this data, because I haven't changed the function signature of this function. It still wants the same parameter. But we should await, because this is now an async function returning a promise, therefore. So that gives us our filtered events, and hence here, through props, we can expose our events, our filtered events, through an events prop. And therefore, back in the component function, now in there, we actually don't really need to parse the URL anymore, though I'll keep that code around for now, but I will comment it out like this. Instead, now we are already using props hasError, and I now also, in addition, want to set my filtered events here equal to props.events. So this events prop, which we populate in getServerSideProps. With that, if we save this, if I reload this page for this kind of filter, I still get no events found. Now, if I do pick a combination that exists, though, I get an error. Num year is not defined. That makes sense because down there I am constructing a date with num year and num month, and we're not having that anymore because I am not extracting it from the URL anymore. Now we could do that, but since we do get it in getServerSideProps anyways, we can just expose num year and month through props to the component. So here, besides exposing the events, I'll also expose my date, and here I'll then just expose this as an object where year is set equal to num year and month is set equal to num month. And now that we expose this date prop, we can go to the component function and build a date by accessing props.date.year and then props.date.month. So these props which we just added. For that, if we save this and reload, now this gets loaded correctly. And this is now pre-rendered on the fly on the server for every incoming request, because we are using getServerSideProps here. And of course, again, we can see that if we inspect the page source, there the event data is part of that HTML content. And again, if I use some other filter where we don't find any events, we see that message. And if I enter something invalid here, we see the invalid filter page. And that also is pre-rendered, as you can see here. So that's how we can use getServerSideProps. So now we did add static generation and server-side rendering to this mini application here. What about client-side data fetching though? Do we need that as well? To be honest, in this application, I would argue that we don't really need it. But we could still add it on a page where I think that it would also be okay. And that's this filter page. There we are currently using get server-side props. That works, but I think here client-side data fetching could also be okay. By using that, the page would load a bit quicker because we don't need to pre-render it on the server, but of course therefore the data would initially be missing. So we need to show some loading state until the data is there. But I think this page would be a fine page for client-side data fetching because it might be nice to get to this page quickly. And in addition, it's not that important for search engines. I mean, this filtered list of events, that's not the main thing search engines should be crawling. For them, the featured events, all events, and the event details are more relevant. So therefore, I think we could use client-side data fetching here on that filtered events page. That does not mean that you typically replace get server-side props with client-side data fetching. It just happens to fit in quite well in this exact scenario. Therefore, in this Slack page, I'll comment this code here back in, because now for client-side data fetching, we again need access to the route parameters inside of this component function, because that is where we are going to write that data fetching code. And we definitely, for example, still need some loading state, which should eventually be displayed. Now I want to do the data fetching with this use SWR hook, which I showed you in the last course section. So I'll quit the development server temporarily and install the SWR package, which brings us that hook. And thereafter, we can restart the development server. Now here in the Slack page, we can import use SWR from this SWR package, and then we can start using it. Here, after I got my filter data, so after I got the route parameters, I will call use SWR, and then we want to send a request. And I want to send a request to Firebase for filtered events. Now again, we can add that filtering logic with Firebase, but since it's not the focus here, I'll cheat and I will instead fetch all events and then filter here in this component, which is of course suboptimal, but good enough for this example. So therefore, again, I'll grab this link, which fetches all events, and use that as that key for use SWR. And that then, as you learned, gives us back an object where we get access to the fetched data and also to a possible error we might be getting. Now, we also still need to transform the data though. That doesn't change. This transformation still needs to be applied. So therefore, I'll copy that transformation logic and add it to this Slack page with help of useEffect, which we need to import from React. And whilst we're there, we can also already import useState because we'll need that as well. So now here, after using use SWR, I'll execute useEffect and pass an effect function to it. And as a dependency, I'll add data, because this effect should rerun whenever the data we fetched changes. Then I'll check if we do have data, because if we don't, there's nothing we need to do. And if we do have data, I want to transform it. So I paste in my transformation logic to transform the incoming data into such an events array. However, that array should not be returned here. Instead, it should be set as state. So we can register some state here, which is initially undefined, the events state, with set events as a state updating function. And then in here, I'll call set events and set this equal to my events which I have here. So to this events array, not the events state. In case this is confusing, I can also name this loaded events and set loaded events. And then down there set loaded events equal to the events array we're generating here. Now, of course, it's very possible that we don't have any loaded events, especially when this component is rendered for the first time, so before fetching data has even started. So if we not have loaded events, then I want to show this loading output here. Otherwise, we make it past this if check, and then in this case, we get the filtered year and month, we convert that, and we can then use that data to extract just the events which we want to display here. Again, that is suboptimal. Normally, we would want to fetch just the right events, but since this would be very Firebase specific, we're going to go with this approach here. So therefore here, I then want to use my filtering logic here from inside the getFilteredEvents function in API util, copy that over and add it here so that I have my filtered events here. And instead of all events, that's loaded events, so this state we just added, that will then filter the events appropriately. However, here, I don't want to compare this with year, but with num year, and here with num month. So with these two constants. Now we got the filtered events. Props has error will never be a thing since we're not using server-side rendering anymore, which is where this prop was coming from before. Now we won't use that anymore. I'll soon remove it. So that's no longer something we should check. Instead here, I want to bring back this if check, which we outsourced to get server-side props. Since we're moving back to client-side data fetching, I'll bring it back onto the client side. So this is my if condition now. Like this. And it might make sense to check this before we try to filter. So I'll grab this code here and actually check this here before we derive the filtered events. So if we make it past this check, we can filter for events. We no longer need that line now. And then we check if we do have filtered events, or to be precise, if we don't have filtered events, in which case we show this fallback. And otherwise, we still want to display the filtered events. And down there, we can now again use num year and num month, since I brought back those values here. So with all of that, we should be fetching the data on the client side with the use SWR hook. Now here we might have an error, so that's also something, this error, this HTTP error, which we might be getting, which we should consider. And I'll simply check here, or if we have an error, then I want to show this error output. Of course, you could also handle it separately. And with all that added, we brought client-side data fetching back. And that means, of course, that we should now remove get server-side props. Having both together doesn't make a lot of sense. It can make sense to have get static props with client-side fetching so that you have some pre-rendered page and you then update it with client-side fetching. But get server-side props and client-side fetching makes no sense because get server-side props is re-executed for every request anyways. So you are guaranteed to have the latest data there. So if you use client-side data fetching, as we are doing it here, it makes no sense to use that in conjunction with get server-side props. At least not if your concern is having up-to-date data. It could make sense if you need to look into request headers or anything like that, but we're not doing that here, so we can comment this out. And with all that, if we save all the code again, if I reload this page here for a filter where I have no events, I see that. If I enter something invalid, I see that. And if I do set a valid filter, I see that. If I reload, I see loading and that. And of course, if we now inspect the page source, this page is now missing the event data. Instead, it only contains that loading text. Because when it was pre-rendered, we didn't pre-fetch the data, we didn't prepare the data for the pre-rendering, since I commented out get server-side props. And therefore, all Next.js saw when it pre-rendered this page was in the end this loading state. This here, because we don't have any loaded events the first time this component is rendered by Next.js. Now, as explained, using client-side data fetching is totally optional here. There's nothing wrong with get server-side props, but now we also saw that in action again, and therefore hopefully it's now clear how those different data fetching approaches work and when you might want to consider using which. So now in this module, we again applied what we learned about data fetching to our events project. And we saw get static props in action again, also with the revalidate option to make sure that this is regenerated from time to time after deployment. We also saw it in action on the dynamic page in conjunction with get static paths, which you need then, also with the fallback option, so that we don't need to prepare all possible instances of this page in advance. And we also saw get server-side props in action, which we then, however, replaced with client-side data fetching to practice this again as well. And therefore, you now know all the key data fetching mechanisms you can use in Next.js. You also learned that you can combine some, for example, client-side data fetching and static generation. You saw that in the previous course section. And therefore, you now have all the tools you need for building truly dynamic Next.js applications, where you have pages which are defining your route structure, and where in the pages you can then pre-render those pages with the data those pages might need, if any. Therefore, this was another important practice module, and we're now ready to dig deeper into Next.js. With the knowledge we gained about pages and routing and about data fetching, we already learned a lot about some of the core concepts and features offered by Next.js that make our life as a developer, and therefore also ultimately as a user of the website, better. But there are various optimizations and enhancements we can add to our pages. Certain aspects we didn't take a closer look at yet, and in this module we will. To be precise, we'll have a look at adding metadata and head data, so diving into those head tags and setting a title or setting some meta description for Google and so on. So we want to have a look at that and how we can do that with Next.js. We will then also explore how we can reuse certain components or logic or configuration across our Next.js app, so across our pages to be precise. And we will explore how we can optimize images and how we can ensure that images are served in the best possible way. Therefore, let's dive in. Now for this course section, I will actually use that little events project we worked on. So attached you find the latest snapshot of this. If you download it, you need to run npm install. And then once you did that, bring up the development server with npm run dev. This will give you this application here, and that's what we worked on over the last course sections. Now, the first aspect into which I want to dive here is the metadata, the head data we could add to every page. Because if we inspect our page here, and we have a look not at the body, but at the head section, which carries important metadata and information for the browser and for search engines, then we see that it's pretty empty. We got no description here. We have no title for this page. We got a bunch of imports, which are added automatically by Next.js for all our styles and so on, but we don't have that metadata, that extra data, which we typically want to provide on our page. And of course, that is something which we definitely do want to have on the application we're building, because that enhances the user experience to a certain extent, depending on what we set there. For example, showing a title, which would show up in a tab up there. But it's also crucial for search engines, because search engine crawlers, like the Google crawler, will have a look at the title and the description set in that metadata. And therefore, it is something we want to set. And thankfully, Next.js makes setting such head data easy. If you want to add content between the head tags on your page, you can easily do that in Next.js applications with help of a special component. Let's say on our homepage, so this index.js file in the pages folder. There, let's say we want to add extra information to that head section. We can do that by importing a special component exposed by Next.js, the head component, which we import from next/head, like this. So where we imported link from next link, we now import head from next head. That's a special component which you can add anywhere in your JSX code for a given component. So here we don't have to add it at the top level. We can go into this div here and add the head component here. And please note, it's head written like this with a capital H. It's not head written like this. This would not have the effect we want. We need head written like this. Because now you can add your typical head section HTML elements between those special head tags, and Next.js will inject them into the head section of the page. So if I, for example, add a title here, which is a typical HTML element for the head section, we could set the title to Next.js events here, or whatever you want. And if you do so and save this, if you go back to the starting page, if I reload, you now see in the tab here, it shows our title. And if I inspected this page and I have a look at the head section there, we indeed see the title was added. So Next.js injects the content which we add between those head tags into the real head part of the rendered page. And of course, we're not restricted to the title. We can also add meta tags here, meta elements. These can also be self-closing since they have no content between the tags. And then, for example, add our description tag here with a content of find a lot of great events that allow you to evolve whatever, something like this. Maybe you find a better description. But we can add such a meta tag here. And now if we inspect the rendered page, we see that in the head, this now also is added. And that would be a special tag, this meta tag here with a name of description. That would be a tag which does matter to search engines, because in the end, this here, this description text, which we added to the content attribute, that is the text that would show up in a search result when your page is showing up in Google search, for example. So that matters. And here, between these special head tags, so inside of this special head element, you can really add any HTML elements that would normally go into the head section of your page. And that allows you to fine-tune and configure what should show up in that head section. Now that we learned about this head element, we of course don't just want to set our own title and description for the starting page, but also for the other pages. And feel free to do this on your own, of course, with your titles and descriptions of your choice. I will start here with events index.js, and then here in the fragment, maybe here, add this head component, and of course, therefore also import it. So import head from next head like this. And then here, since this lists all events, I will give it a title of all events, and I'll keep this description text. Of course, you could use a different one, but I'll keep that. Copy this again, go to the event ID page for a single event, and here I then also add this in my fragment and add the import head from next head like this. And with that again, fine-tune this. And here, the title should actually be the title of the selected event. Now the great thing is, since we use that in our regular page component JSX code, we can of course also inject dynamic content here. So instead of hard coding the title, we can use event.title here to use the title of the selected event. This is of course very important, because this ensures that we don't have to hard code all that head data in advance, but that since we add it to the regular component JSX code, that we can of course also use a lot of dynamic values. For the content, so for the description here, we could therefore, for example, also use event.description. So that is very, very useful. And with that, if I go to the slug, here I also want to add this, add it down there, and therefore also import this from next. So import head from next head like this, and also set a title and a description here. So here I'll say filtered events. And then here we could, of course, again use a dynamic value for the description and kind of construct a dynamic text where we say all events for, and then I want to use the actual month and year that was selected. So I'll just output for num month slash num year. And of course, you can fine-tune this text and format this state however you want. But with that, if we save all those different page files, if I go to all events, for example, and I search for events in May, we see that if I inspect the rendered page, in the head section, we have that title and we have that description with that content that contains the month and year. Now, it's also worth noting that we don't just see this head content in the actual rendered page, which we see here when we inspect it, but also in the response from the server. If we go back to the starting page, if we reload this page and we then view the page source, so that we now fetched a brand new page from the server, we also find the title in here and we also find the description in here. So that is really part of the response, which is important because that means that search engines will see it. Now you might notice though that if you filter for events, if we set a filter here and we find our events, here if we reload this page, in the page source we don't see the title and the description. And that's not a bug, but it has a simple reason. In our slug page here, we do add a head, but we only add it here in the main content, which we return if we make it past all these if checks we have in front of it. Now, if we make it into one of those if checks to show the loading text, or to show this error, or to show another error, then we didn't add head here. And of course we can add head here, and we probably would want to add head here to set specific different titles for these cases. But you also might want to set up some general head content, which is part of every page. And of course you can do that by including it in every page, but that involves a lot of copy and pasting. And therefore, let's now have a look at the different ways and tools Next.js gives us for reusing logic or reusing configuration like certain head elements across all pages without having to copy them around. So we learned about head. And typically you want to set up your head content in every page and also in every if branch inside of a page, because you have very specific titles and contents for those different scenarios. Now here in the slug page, for example, we definitely want to set our own title and our own description, but maybe we want to use the same title and description for all the different if cases then. So we want to reuse that and not copy it manually into all those different cases. We could copy it, but that's of course annoying. Now reusing here is simple. We don't need any special Next.js concept. We can use a standard React.js approach. Instead of copy and pasting it, we cut it from down there and we set it up once right at the beginning of this component render function. So here, before I have my first if check, so before we render something the first time, so to say, I create a new constant, page head data, or whatever you want to name it, and that contains my head section. Now, since I rely on num month and num year here, we might want to extract this first. So I'll cut that here and move this in front of this page head data part here. And then we can just include page head data in all our return statements. So for example, here, I then wrap this into a fragment because I now want to add an adjacent JSX element. I want to also include my page head data and output the content of this constant dynamically in this returned JSX code. And the content of this constant, of course, is this JSX code. And we can now do this in all our return statements. So also here, and also in the final return statement here. So that would be a standard React way of reusing some logic. And if we do that, if I reload, I get an error that I cannot read property 0 of undefined. And the problem is that I'm accessing my filtered data here, and the filtered data might be empty, of course, or it actually will be when the page renders the first time, because I explained that useRouter works such that it runs when the page was first rendered, and it doesn't have the path parameter values at this point. It then runs again and has access to them thereafter, but not at the beginning. And therefore, actually, I want to move that filtered data part after the if loaded events part. That was correct. And I want to set up my page head data thereafter, therefore. So below here. But I will remove const here and instead create page head data as a variable here and just assign a different content at the beginning. So here it still holds the head element, but I'll have a different description. So I'll copy the title and my meta content here, but the description here is a list of filtered events, something like this. So now we change the page head data inside of this component function, depending on whether we have data or not. And with that, if we save this and reload, this does load. And now if I inspect the page source here, we see that we do have that title and that we do have that description here. So that's how we can reuse the head data inside of a component if we have different return statements and therefore different pieces of JSX code that might be rendered by that component. But that's not the only way of reusage which we have. Besides reusing our head content inside of a component, we also might have certain head settings that should be the same across all page components. So we don't want to copy and paste it into every single page component. Now we could solve this by outsourcing it into a separate file, into a separate component, and then importing that into all the page components and using it there. But we can also use another approach. Next.js has this _app.js file, and it also has another file which we'll be able to utilize. Now let's understand what the idea behind those files is before we dive into them. The _app.js file is your root app component, which in the end is rendered for every page that is being displayed. This component here, which is received through props, this actually is the actual page component that should be rendered. My app, this component here, is rendered by Next.js, and this component prop will automatically be set by Next.js, so you don't need to do anything for that. But then you can utilize this underscore app.js file such that, as we're currently doing it, you wrap your page content with other components. Like here, I'm wrapping the layout component around the page component to give all pages the same layout, so the same navigation bar, for example. So that actually is a file which we are already utilizing. And of course, therefore, we could also import head here from next head, import it into this app.js file, and then add head here to set some generic setting that applies to all our page components. For example, we could add another meta tag here with a name of viewport, and then a content of, let's say, initial-scale equals 1.0, comma, width equals device width. This would be a meta tag which is often added to pages to ensure that the page is responsive and scales correctly. And we therefore typically want to add this to all our pages, not just to some. So that would be a great example for some head tag, some head element, which you want to add to all pages, but which you of course don't want to copy around manually. Therefore, we can add it once in this app.js file. And if we do so, we see that if I reload this events page, for example, and I inspect my rendered page, then here, this viewport name is part of this page. So that works. Now this is applied to all the pages by setting it up once in this underscore app.js file. Now in the last lecture, we added head to the underscore app.js file. There is an important implication of this. Now we have the head element there in app.js, and we of course still also have it in our page components. In index.js in the events folder, for example, I also have head. And as you see on the rendered page, both is applied. The title and description from the page component, and the viewport from the underscore app.js file. And this is important. Next.js automatically merges multiple head elements. So if you set a head here in underscore app.js, and then also in the page component, the content of those different head sections gets merged. Even if we would have multiple head sections here inside of a single component, the content would be merged by Next.js. But of course, that means that we could also have conflicts. For example, I could have another title set here, for whatever reasons, and now I set a title here and here. Now Next.js automatically merges your head sections, and it also resolves such conflicts. If I add multiple titles here, and I reload this events page, you see only one title shows up here, not multiple titles. It simply takes the latest element if you have the same element multiple times. So if we have the title here and here, the second title wins. The same would be true for meta elements with a name attribute. If you have other head content, which is neither a title nor a meta element with the name attribute, but let's say a meta element with some other attributes, then you can always add a manual key here, like description, to still allow Next.js to find out if two elements are clashing. And then again, the latter one will win. Now, of course, this is redundant code here, this extra head. I just wanted to show this Next.js behavior. And it does have an important implication, because it means that in underscore app.js, we can indeed also go into the head section we set up there and define a general title that applies to all pages unless it's overwritten. This ensures that we always have a title on every page, even if we forget to set a page-specific one, which we of course typically want to do. So here I'll then give all my pages a general title and also a general description. Again, that will be overwritten by the page-specific data, but in case we don't have page-specific data, then this general data would kick in. So here I have my general head set up, but if I reload this all events page, we don't see that there, because we do have page-specific data here, and that then overrides the more general data. Because the page component is rendered after the app component, so the later head section wins, and that will be the head section instead of the page component. Now, the underscore app.js file is not the only special Next.js file which allows us to set application-wide settings. There also is the underscore document.js file, which we can add. Just like underscore app.js, underscore document.js has to be added in the pages folder, directly in the pages folder, not in some subfolder, but in the root level of the pages folder. It's not there by default, but if you add it, Next.js will take it into account and will use it. But what does document.js do? App.js is your application shell. You can imagine app.js as the root component inside of the body section of your HTML document. Document.js allows you to customize the entire HTML document, so all the elements that make up an HTML document. If you need to do that, you can add the _document.js file, and then you need to add a special component in there. A class-based component, as it turns out, which you could name myDocument. And it has to be a class-based component because it must extend some component offered and provided by Next.js. For this, we need to add an import of document from next/document. So we need to extend document here, and therefore we need to use a class-based component. And then in this class-based component, we need to add a render method, like we do in class-based React components. And then here we return some JSX code. That also should be special JSX code with a very specific structure. For this, we need to import more components from next.document, and those components are the HTML component, the head component, the main component, and the next script component. Very important, the head component, which we are importing here, is not the same head component as we import from next head. These are different components. Head from next head is imported to use it anywhere in your JSX code to adjust the head content of the rendered page. Head imported from next document should only be used in this special document component, which we are building here. Now, with those components imported in the rendered JSX content here, we should return a JSX structure where we have the HTML element as a wrapper. Then we have the head element like this. And then we have a body HTML element. So no special component, but the standard body element. And inside of that main and next script like this. That is the default structure which you should add. And that's the default structure which the default document has if you don't override it. So if you override it, you want to recreate that structure. And you should also, of course, export the document as the default. Now, what could be reasons for overriding that default document? Well, if you want to configure the general document. For example, if you want to add the lang attribute on HTML and set this to en. If we don't do this and save everything and we reload, we see that there is no lang attribute on the rendered HTML element. If we do that, if we add lang and set this to en, or to whichever language applies to your page, then if we restart the dev server, which we need to do here once, if we reload the page thereafter, we see the lang attribute. So I needed to restart the server here for this to have an effect, but then we see that this is taken into account. We could also add other elements here to the body, like for example, a div with an ID of overlays, like that. If we do that and save this, and we reload, we see in the body there is this div. Why might we want to do that? Well, this allows us to add HTML content outside of our application component tree. For example, for using those elements with React portals then. We could select this div with a React portal to portal our modals or overlays to this element. So having extra HTML elements which are outside of our application component tree can sometimes be useful. Because your Next.js application is in the end rendered by this main component, which you therefore must include, but adding extra elements can sometimes also be beneficial. And therefore, if you need to edit the overall HTML document, you can do this by adding such an _document.js file. So by now, we optimized our meta tags in the head section. But there's another important aspect of basically any website you're building that also should be optimized. Our images. We are rendering a couple of images here when we render that list of events, and also when we explore a single event. Here we also have an image, and in both cases, those images are not optimized at all. Let me show you what that means. On the All Events page, if I open the Developer Tools and we go to the Network tab here, if we then empty the cache and hard reload by right-clicking on the refresh icon, we make sure that we reload all the data for this page, including the images. And now let's have a look at this coding event JPEG file. If I make this a bit bigger, we see that this image has 2 megabytes. The introvert and extrovert images are even worse. They have 5 and 4 megabytes. The reason for this is that these are huge, unoptimized images which are fetched in full size and quality. And we are also always using the same image type, JPEG, no matter if our browser maybe supports a better type. For example, Chrome would support the WebP image type, which is an optimized image format. Now, for development, that's no problem, but this would not be okay for production. These would be way too big images. And Next.js calls itself the React framework for production. And shipping such big images is certainly not production ready. Therefore, it makes a lot of sense that Next.js also helps us with images. It helps us optimize those images, and it does so in a super simple way. Optimizing images with Next.js is easy. Here I'm in the event item component, which is that component that renders the image in that list of event items. Now, currently we're using the standard image tag, the standard image element, but for optimizing images, we can import a component offered by Next.js, the image component, from next/image. Now, this is a special component which we can use to replace the standard image element. And when we use that special component, Next.js will create multiple versions of our image on the fly when requests are coming in, optimized for the operating systems and device sizes that are making the request. And then those generated images will be cached for future requests from similar devices. So to enable this, we need to use this image component here instead of our own image component, and we can copy over source and alt. That also works on that next image component. But now we also need to add two more attributes, two more props here. And that's the width and the height attributes. We need to set those to basically inform Next.js about the width and height of this image. And with that, I don't mean the original width and height of the image, but the width and height which we need for the image here. For determining the width and height, we should keep in mind that our image is displayed in two possible ways. It either takes the full width of the container on smaller screens, or just a fraction of the width on bigger screen sizes, because then we have the image on the left side and the other content on the right side. Now, in the CSS code, we can see this here basically. I'm using Flexbox on the parent container, and on smaller screens, that is a column Flexbox, so items are rendered on top of each other. But on bigger screens, the items sit next to each other, and then the image has 40% of the width of the overall item. Now, the overall item width is determined by the event list styles, and there we have a max width of 40 rem. So overall, we have around 640 pixels, that is what 40 rem are in pixels, as a width for the overall item. And the image has around 40% of that. Hence here, we could try setting width to around 340 pixels maybe, which are roughly 40% of 640. And set the height to, here we have 10 rem for the image, so that are 160 pixels, so that's the value I will use here. So with that, I'm determining the width and height of the image as it should be loaded on the screen. I'm not setting width and height of the original files. As you see, these files here have much bigger dimensions. I'm not using those. So with that, if we save this and we reload, we see our image showing up here. Now it's a little bit too wide, so I'll actually shrink this to 250 here, and that looks better. And on a smaller screen, that also works. And the nice thing here now is that if we now open the developer tools again, and we again empty the cache and hard reload, we will see that these images are much smaller. We see that here, this image is now only 19 kilobytes instead of the megabytes we had before. So all these images are much smaller. They are also fetched as a different type now, as WebP here, since I'm using Chrome and Chrome supports this optimized image format. And they also have reduced quality to shrink the file size even more without impacting the image. The quality is only reduced such that we don't really see it. Now that's working because Next.js, as I explained, generates optimized images on the fly. Now we can see those generated images in the .next folder. There in the cache folder, we have an images folder, and in there we have a couple of cryptic files, which in the end contain the images as they are generated by Next.js. And these are the optimized images, which are generated when they're needed. So they're not generated in advance, but when a request reaches the page. But then they are stored so that future requests from similar devices immediately get that already generated image. And that's therefore another very nice feature Next.js has built in. Now, besides the size optimizations, which are of course super important, those images also have another nice benefit. Or the image component offered by Next.js has another nice benefit. If we're on a smaller screen here, and I then reload, If I clear my network tab, watch what happens if I increase the screen size. As it increases, you see a new request is made for that bottommost image. That request is being made because by default, images are lazy loaded, which means if they're not visible, Next.js will not download them. And that's another difference to the built-in image component. There, all images were loaded eagerly, which means they were loaded all the time. Now they are only loaded when they're needed, and that further decreases the amount of requests we're making in advance and the bandwidth we're taking up with our page. So that's another nice feature. We don't load what we don't need. So Next Image is a super important component. It allows us to ship production-ready images, and therefore I also want to use it on the event detail page. There in event logistics, I'm also displaying an image, and I now also want to use the Next Image component there. So we import image from Next Image here as well, and replace this image, the default image, with the Next Image. Again, copying source and alt, and then we need to figure out the width and the height. So for this, let's briefly again have a look at the CSS code here. And we see for the image, I'm using a width and height of 10 rem each. So that would be 160 pixels. Hence, that is what I want to load here. 160, 160. And with that said, if we now go back to the page and we visit an individual image, we see that also is being loaded. Now it's looking a bit blurry, so maybe here we should actually use a bigger width and height, maybe 240 instead of 160. And if we do that, it looks sharper. Maybe we ramped it up even more. So finding the right width and height here also will be a bit of trial and error. You still override width and height as you set it here with your CSS styles. So if you give the image a hard-coded width and height, those CSS styles still kick in. The width and height you set here only determine the image size that will be fetched in the end. The final styling is still being done with CSS. And here it's simply looking a bit blurry because I was zoomed in. If I wasn't zoomed in, 160 pixels would have worked out. But I also want it to look good when I do zoom in, so I will pick slightly bigger values here, maybe 400. Again, only because I'm being zoomed in here. Yeah, I think that looks all right. So now with that, we're using the image component on this page as well. And in general, in your Next applications, you want to use the Next image component instead of the standard image component, since that Next image component gives you a lot of optimizations out of the box, and it is super easy to use. Now for our purposes, we are using the Next image component exactly as we want, but I also want to point you at the official Next image documentation. Because besides the way we are using the image, which is a very common way and a great way, there are a lot of props which you can configure to fine-tune how the image is loaded. You can change how it's being resized on smaller or bigger screens, or if it's resized at all, how it's being loaded. You can make it work with cloud image providers and much more. You can also fine-tune the quality decrease which is being used, for example. So definitely have a look at those docs at all to make sure that you are loading images in exactly the way you need to load them for your applications. Now with that, that's it for this module. We optimized images, we ensured that we don't load those super huge images therefore, and we also optimized our metadata, our page metadata. With the head component offered by Next.js, which we can include in our pages to set the title, meta description, or any other head section tags from inside our page components. We also learned about _app and _document.js, which are files that allow us to set up certain settings and elements which are being used across all pages in our application. With that, we can set up general metadata, or for example, inject extra HTML content into the loaded HTML document. And with that, we got a couple of important tools which we will need to build real applications with Next.js. Because of course, on real applications, you want to have metadata in the head section, and you want to have optimized images. And now you know how to do both in your Next apps. In this course section, we are now going to leave our standard Next.js page and especially the standard pages we've worked with thus far. Instead, in this course section, we're going to take a look at another Next.js feature, which is called API routes. And therefore, in this section, we're going to learn what exactly API routes are and why they exist, And we're going to explore how we can add API routes and how we can work with those API routes when we need them. And last but not least, we're going to take a closer look at dealing with requests and responses inside of API routes. And therefore, let's not waste any time and dive right in. Now, what are API routes? It's important to understand and keep in mind that some websites which you're building don't just need HTML pages that are being served back to visitors upon requests. That, of course, is something which most websites need, but it's not the only thing that can be needed by a website. You might, for example, have a feature on your website that allows users to submit feedback or sign up for a newsletter. Now, when a user clicks such a button to, for example, sign up for a newsletter, you don't necessarily want to show a different page. I mean, you could show a confirmation page that it was successful, but you could also just show a little info pop-up or banner on the existing page. But even if we ignore what we show, let's think about what happens behind the scenes when we sign up for a newsletter. Then we need to send data to some server, to some computer, to then store that entered newsletter email address in some database. And that request which is being sent there is not about fetching a site, it is about storing data. So it's kind of the other direction. We don't want to get a HTML page, instead we want to send that user-entered data to some database. And that is what we use APIs for, application programming interfaces. There are different kinds of APIs we could build. REST APIs are the most popular form of APIs, and the idea is always the same, that we have a web server that exposes certain URLs, just as we did it thus far in the course, but those URLs are not about getting requests and sending back HTML data, but they are about accepting some data and then sending back responses with any kind of data, not necessarily HTML. Specifically, JSON, JavaScript Object Notation, would be the most common format for exchanging such data. So API routes are special kind of URLs which you can add to your Next.js application, which are not about getting a standard browser request and sending back a pre-rendered HTML page, but which are instead about getting data, using data, maybe storing data in some database, and sending back data in any form of your choice. So in the end, API routes, this Next.js feature, is a feature that allows us to build an API, a REST API, if you will, as part of our Next.js app. And it would, for example, allow us to support URLs or paths after our domain like this, /API feedback, and then accepting different kinds of HTTP requests. Not just GET requests, as all our page routes did thus far, but also POST or PUT or delete requests, whatever you need. And then, depending on which HTTP method was used for which path, different actions could be triggered. For example, for a POST request sent to /API/feedback, we might expect some data to be sent along with that incoming request, some feedback data entered by a user, and then when that request hits our API, we extract that data from the request and store it in a database. If a GET request reaches that same URL, we instead might want to fetch data from a database and send that back, but not as a HTML page, but instead as raw data in that JSON format. And those API routes, therefore, don't exist to be entered in the URL typically, but instead to be triggered via JavaScript code, via AJAX requests. So we as a developer add certain code to our page that sends these behind-the-scenes requests, you could say, to our API to store or fetch data. And that is actually something we already did in this course. When we worked with Firebase, when we sent requests to Firebase, then there we talked to the Firebase API. We sent requests to certain URLs for storing data and for getting data, and these URLs, these Firebase URLs, we didn't enter them in the browser. Instead, we sent requests through our JavaScript code, no matter if that code then runs on the client or on the server. We talked to that Firebase API. And now this API routes feature is about letting us define our own API endpoints as part of our Next.js application. Now, how do we add our own API routes to a Next.js application though? For this, I got a brand new Next.js project for you. You'll find it attached to this lecture. You can extract it, run npm install, and then once you did that, npm run dev to start it. But this application will now not be about our pages, at least not the standard pages. Indeed, there only is one page in that starting project, and that's a dummy homepage, which just says the homepage. Now, of course, we can visit this page through localhost 3000, but again, this course module will not be about creating pages like this. Instead, it is about this API routes feature, which is a feature built into Next.js. We can add our own API endpoints to Next.js by simply creating a new subfolder inside of pages. So inside of this pages directory, we create a subfolder, and that subfolder has to be called API. Now, up to this point, those file and folder names were mostly up to you. This is now not up to you. This has to be called API, because that's a special folder which will be recognized by Next.js. And any pages, if you want to call them like this, which you set up inside of that API folder will be treated in a special way. So let's add a page inside of the API folder. In there, you can add pages just as you can add them anywhere else in the pages folder. So you can pick names of your choice, index.js to handle requests which are just directed at /API, or to get started here, feedback.js. Let's name it feedback.js. So now I have that feedback.js file in the API folder in the pages folder. Now that will create a special path we can send requests to. It will allow us to send requests to our domain. So during development, that's localhost 3000 /API/feedback. This is what this will enable us to do. And it should make sense because we're in the API folder, in the pages folder, and we have a feedback.js file. Nonetheless, I mentioned that files and folders inside of API, so inside of this API folder, would be treated in a special way. And they will. Inside of any file inside of the API folder, like this feedback.js file, we don't export a React component. So in the other page files, we do create a React component and export that as a default. We don't do that in API routes. Instead here, we create a function which we typically should name handler because it will handle incoming requests, and a function which will get two parameters, a request object, which we could name rec, and a response object, which we could name res. And it's this function which we should export as a default here. Now that will not be a React component. This is a standard JavaScript function. Now because this file is in the API folder, Next.js will kind of take this function here to execute it for incoming requests sent to /API/feedback. And the interesting thing is that now inside of this function, we can not just handle GET requests, and we don't have to send back HTML code. Instead, this allows us to execute any server-side code of our choice. And that's important, server-side code. Any code we write in here will never end up in any client-side code bundle. So any code we write here will never be exposed to visitors of our web page. Just as code written in getStaticProps and getServerSideProps would never be exposed to our visitors. It's the same here for these API routes and the code related to them. So here in Handler, for a basic start, we could start sending back a response. And we do that with help of that response object. Now, if you have some Node.js or Express.js experience, this will look very familiar to you. And indeed here we will write Node.js code enhanced by the Next.js team to look a bit like Express.js. For example, we can send back a response with help of that response object here. And on that object, we can call special methods that allow us to send back that response and to configure that response. For example, the status method allows us to set a status code. And that could be 200 for the start to set a success status code. Then on that method, we can chain another method, so call a method on the result of this first method call. And that could be the JSON method to send back some JSON data as part of the response for incoming requests. And that is quite standard. As I mentioned before, for APIs, you typically exchange data in that JSON format, because it's a highly machine-readable and also human-readable data format, which is the de facto standard for exchanging data with APIs. Now to the JSON method, we pass a JavaScript value, like an object, that will then be transformed into JSON automatically. And here we could have a message property. This is up to you though. This entire object is up to you. You can put any data you want in there. And the message could be "this works," like this. So by adding this line of code in that handler method, which is exported as a default, this will be executed by Next.js when we send a request to /API/feedback. And this code will then send back a response. Clearly not a page, clearly not a HTML response, but instead some JSON data. Because this response is not intended to be consumed by entering this in the browser. We will enter this URL in the browser for now to start working with API routes, but that is not how we will then use them on a real page. It's really just to get started. So if we save this feedback.js file now, and I then send a request to /API/feedback, we see our JSON response here. And if we open up the network tab in the DevTools and we reload to take a closer look at that response, we see the response data there as well. And in the headers, where we see some metadata about that request and response, we also see that in the response headers, the content type was set to application JSON. So this is now a special kind of page because we created that file in the special folder, and that code now allows us to run our own server-side code and to add our own application-focused API to our overall website. And that allows us to add features like newsletter sign up, user feedback submission, maybe comment submission, or anything else you need. And to really be able to add such features, let's now dig a bit deeper and explore how these API routes can be used. Now, to explore working with those API routes, let's go back to our standard index.js file. So to this standard homepage route, which is not an API route. And in there, I will add a basic form, which I'll not style in any way for the moment, where I then want to add an input of type email, let's say, and above that a label where I say your email address with a HTML4 tag of email, and then here an ID of email for accessibility. And then I'll put that into a div just to kind of put this into its own block and force a line break thereafter. And then I'll copy that div and create another input with an ID of message, or let's name it feedback. The type here is text, however, and here we just say your feedback. And actually, let's use a text area. That's more realistic, I guess. So we have a text area with an ID of feedback, and let's say a number of 5 rows. And then we add a button to submit that form, send feedback. If we adjust the homepage like this, and we reload just localhost 3000, we see this form here. Now it is ugly, you could add styling, but this is totally not about the styling. This is just a dummy form which I add so that I can show you how we can interact with API routes. We'll see a more beautiful example in the next course section when we apply what we learn in this section to our first course project. So here we accept the email address and some user feedback. And of course, when that button is clicked, the idea is that this feedback is sent to some database, for example, that it's stored in some database. Now, we shouldn't talk to a database from our front-end application. It would be kind of difficult to implement, and that would be difficult for a reason. Because it's highly insecure if we would try to add JavaScript code to this component to talk to a database. Because we would have to expose our database credentials in this front-end code for this. And that would be highly insecure. Attached you'll find an article and video where I talk about this in greater detail. So that's not what we want to do. Instead, that's the perfect scenario for an API route. We fetch that user input on the front end, and once the user then clicks that button, we send a request to that API route, so to our own API, and then in that API route, we could connect to a database. Because then there we can safely do so because the code written in the API route will not be exposed to the front end. It will not be exposed to our website visitors. So here we could securely talk to a database. And therefore now here in index.js, I now want to get that user input when the button is clicked and send a request. Now for this, I will work with references here to get references to my inputs. So I'll import useRef from React to use this ref feature. And then I'll set up two references here. The first one is for the email input, and then the second one thereafter is for the feedback input. Now, once we got these references created, we can assign them to our elements with the special ref prop. And that's just standard React code, has nothing to do with API routes. And here I'll then just point at the email input ref, and here I'll point at the feedback input ref. Now we need a handler for the form submission, so I'll add a function here, submit form handler, the name is up to you, where we get an event object automatically because I'll bind that to the onSubmit prop on the form. So it will be triggered when that built-in submit event is triggered, when that is fired. And then we get access to that event object. And we need access because here I want to call prevent default to prevent that browser default where the page would basically be reloaded because the browser sends a request automatically. I don't want that browser behavior here. Instead, I want to step in and send the request myself through JavaScript. For this here, we can now extract the entered email text by reaching out to the email input ref, and then there, since it's a ref.current, that's always how refs work, and then .value, because in .current, a pointer at this input object is saved, and this input object, just as the text area object in JavaScript, always has a value property which holds the current value of those inputs. So it holds the value entered by the user. That's the entered email, and then we can also get the entered feedback, of course, by reaching out to the feedback input ref.current.value as well. Now we could add validation and check if the email or feedback is empty. We could do that here to then show an error message to the user, but I'll not do it here because it's not the focus of this section. Instead, now we got these two values, and we might want to send them to our API route here to then there accept them, extract them, and save them in a database. And therefore, in the next step, we will work on that API route. So we got this feedback API route here, and now as part of that function, I want to accept an incoming request with the email and feedback data, and then store that somewhere in a database, in a file, or for development, maybe also just in an array. And therefore, to implement this, we now have to do one important thing. Inside of this handler function, we have to find out which kind of request is triggering this API route. Because when we submit that form here, I soon want to send a HTTP request with JavaScript, and I'll do this with the fetch function here. We could also use a third-party library like Axios. That does not matter. But I'll send a request from inside my JavaScript code. And I will send a post request because I don't want to get data, instead I want to send data. So we would typically use a post or maybe also a put request. Now, since that's the goal, here inside of that handler, we need to find out which kind of request is triggering this function execution. Because by default, all kinds of requests will trigger this function execution. Get requests, post requests, put, delete, everything. Now, I only want to try and extract data from the request and store it in a database or somewhere else if it's a post request though. So therefore here we need an if check, and we need to find out which kind of request was sent. And that's easily done with help of that request object, which we get automatically by Next.js when this function executes. This will give us information about the incoming request. And for example, there we'll have a method property, which allows us to find out which HTTP method was used. And we can simply check if that was a post request here, if it's a post method. And if that's the case, then inside of this if check, we could try to extract data from the incoming request and then store that extracted data in a database. Now let's say we expect our incoming post requests to this API route to have this email and feedback text data field in the request body. That is something we could expect because we're the ones writing the code for this API. Then we can easily extract data from the incoming request with help of more properties that exist on this request object. To be precise, with help of the body property which exists there. This will be the already parsed body of that incoming request. So Next.js will automatically parse the incoming request body for us So it will give us easy access to the data attached to the request through that body property. And then body will just be the value that was sent with the request. So let's say here in our front end, we will soon send a request which carries a body of a JavaScript object with an email field with some data and with a text field with some feedback text data. That could be the structure we want to use in this application. And since we are the developer of this application, of this website, we can of course use any structure we want. So now we would send this object with a request to that API route. So on that API route, we could now expect that on this body, we get our email with request body.email because we have an object as a body which has an email property. And it also has a text property, so we can extract that as well. We can also get our feedback text by accessing request.body.text then. So that's how we can extract the data from the incoming request if it's a post request, and then here we could store that in a database. So here we could create a new feedback object where we add this email and text, and then maybe also add a unique ID to have, a unique identifier for every new feedback. And here, during development, I'll just create a new date object and convert that to a string. It's not a perfect unique ID because theoretically 2 requests could be sent and handled at exactly the same time, but during development that's good enough. It's a dummy ID we can use here. So now we would create this feedback object and we could now store that in a database or in a file or anything like that. Now here during development, I will store it in a file and I'll create a new data folder. The folder name is up to you though, in my root project folder. So not inside of Pages API. You should not create it there, but just in my root project folder. And in there, I'll add a feedback.json file. The file name is up to you though. And my goal is to open that file and store my data in there when we, get that feedback. For this, I will import fs from fs, so import the file system Node.js module. And we can use Node.js code here because this will run on the server, and this will only run on the server, never somewhere else. And it will be executed with Node.js, so we can use all the Node.js features here. And I'll also import the path Node.js module here. And then here we can store that in a file by constructing a path with the join method to that data folder and there the feedback.json file by getting access to the current working directory with process current working directory, which will refer to the overall project directory, then diving into data and then into feedback.json. And this will create an absolute path to that folder for us. So that's my file path then. And then we can use the fs module to write to a file. And here I want to write to that file path. And then the data which I want to write is actually this data. However, to be precise, I actually want to read the file first, fetch the data which is in the file, and then override it with the updated data. And therefore, to do that, I'll first of all read the file. And I'll do this with read file sync to do it in a synchronous blocking way. So I'll read that file here, and that gives me my file data, so the data which is currently stored in that file. And that will be some JSON data, so I'll now convert it to a JavaScript object to work with it by executing JSON parse file data. Then that data should be an array, let's say, and therefore I'll add an empty array inside of this feedback JSON file as a start. So this is an empty array for now. And then we interact with that array. We know that it will be an array because we own that file. And I push my new feedback into that array. And then I want to write it back to the disk. So then I use write file, and I'll use write file sync to again do this in a blocking way here. And I'll write my file here by again targeting that file in that file path. And now the data which I write back is again the data converted back to JSON with the JSON stringify method. I pass in my updated data here, and that then writes the data to the disk. That's the goal. That's how this should behave. And then once we're done with all of that, we want to send back a response. So then here I'll set a response of, or with the status code of 201, which signals success. We added data successfully. And then any data of our choice, for example, an object sent back as JSON, where I say success in my message property, and where I maybe also send back the new feedback object that was created. So that will send back a response after we successfully updated our file, and it sends back an object in JSON format with a message and a feedback property. This line of code would also execute though after we go through this if check, because function execution does not stop just because we set some response data. Hence, to not send two responses, which would cause problems, we should move this code into an else block, so that this does not execute if we just make it here into this if check. Okay, so now we spent a lot of time on that, but now we got some server-side code added to this API route using API route specific features like looking into the request, extracting request body data, and running server-side code and sending a response. And with all that added, we can now connect our front-end code to that backend by sending that request to that API route to then see whether that works. So let's now connect everything, and for this in the front-end index.js file, I now really want to send a HTTP request when the form is submitted. So for this here, I will use that fetch function, and now we need the URL to which the request should be sent. Now, since we will target this API route, the URL will be our current domain, and then just /API/feedback. We don't need to encode our current domain here, because if we start with a slash here, this will automatically be appended as an absolute path right after our domain. So it will be sent to the same domain automatically. And then there to the path /API/feedback, targeting that feedback file here. Now we want to configure this request though, and set the method to post. This is very important so that we send a post HTTP request, because of course we're looking for these kinds of requests here in our API route code. Then we also need to add our body, so the data that should be appended to the request. And we do this with the body property. Now that data should be an object containing the entered email and feedback, and it should be an object with an email and a text property, because that's what we're trying to access inside of our API route. So here I'll then just create my request body object, let's say, with the email property of entered email and a text property of entered feedback. And then that's the body I want to set here, but not as a standard JavaScript object, but instead converted to JSON with help of that JSON stringify method. Now we should also make it super clear that we're sending JSON data by adding some special header with help of the headers property, which takes an object, where we add the content type header, so a key of content type added to this header object, which is set to application JSON. And my key name is wrapped between single quotes here because I have a special character in this property name, which wouldn't be allowed otherwise. So now we add this object to add metadata to this request which we're sending, informing the backend, informing the API route in the end, that this request will carry JSON data. That is required for the API routes feature for Next.js, therefore, to correctly parse the incoming request body and convert JSON to JavaScript for us so that we can conveniently access it as we're doing it here. So that's how we send this request now. And then here we can also listen to the response and extract the JSON data from that, and then work with that data and maybe just console log the data for the moment. So we're just sending the request, and then for the response, we're just extracting the data and then logging the data. Using the then methods here because fetch returns a promise. With all that done, if you save everything, you should be able to go back to your page and then enter any data of your choice here and click Send Feedback. And now to find out whether this worked, we can go to the feedback JSON file, and in there you should now have an array which does contain one object with the ID property, which is set to some automatically created ID, email and text with values being equal to the values you just entered here. So that was now updated automatically because of our API route code here. And if I send another feedback like does this work again from test2@test.com, if I click send feedback and we have a look at feedback JSON again, we see now that this was stored in there as well. And it's this array which is being updated over time here, which gets longer and longer with more and more elements. And this is all JSON data in there, which is why the property names are wrapped by double quotes. It looks like JavaScript, like a JavaScript object, and that's the entire idea behind JSON. It's this JavaScript object notation, but it isn't a JavaScript object. It indeed just looks like it. It is JSON formatted data, because that's what we're doing in a feedback API route. And now with that, we achieved something important. Now in our next application, we are also able to work with submitted data. We're not limited to just returning pages for GET requests. And that allows us to add features like newsletter signup, feedback submission, comments, or any other kind of data that should be submitted maybe. And you don't have to build a separate API as a separate project. Instead, you can easily add API routes your website might need as part of your Next.js project. That's why API routes are a great and very useful feature. Okay, so now we know what API routes are, that we can write server-side code there, Node.js code to be specific, that we can handle different kinds of requests, that we can extract data and then run any kind of Node.js code we want. We can then also send back a response or different responses depending on the kind of request sent. So for example, if I still enter a request and send it to /API/feedback through the browser URL bar, that will automatically be a GET request. Therefore, it will not trigger this if block, or it'll not make it into this if block because the method is not post, but GET. And therefore, this line of code will execute, which is why we see this response. And now that we got this response, of course, let me also make it crystal clear that you can also handle incoming GET requests in whichever way you want. So for example, here, let's say for incoming GET requests, we want to get access to all our feedback objects that were stored and return those as JSON. So that in our front-end application, we could also send a behind-the-scenes request to fetch all feedback entries and display them on the screen. So to achieve this in our API feedback route, I will basically repeat the code from up there to get access to my file. And hence we can copy that code, or to avoid code duplication, create helper functions like build feedback path, let's say, where I simply return this file path, which I create here. So where I return this, so that down there we can just execute build feedback path, and then do this again here in the else block. And also to then get our file data, we can create another function. Extract feedback could be the function name. And in extract feedback, I, in the end, want to execute that code. So we can copy that code, move that in there, expect the file path as a parameter, and then simply return the parsed data as a response. And then below here in that code, we can now get our data by calling extract feedback and passing our file path as an argument. With that refactoring, we can repeat that down here in the else block. And then we got that extracted and parsed feedback data in that data constant. And hence, instead of sending back this dummy "this works" message, we could send back our feedback, our data, which we're extracting from the feedback file. And if we do that and save this, if I now reload /API/feedback, we see that this also works. But of course, we typically don't add an API route so that users have to enter them in their URL bar. That's not the user experience we typically want to offer. Instead, maybe on localhost /3000, we want to have a button that loads all the stored feedback items from that API route, or with help of that API route, when it's clicked. So on index.js, below the form, I'll add a horizontal line and then a button where I say load feedback. And when that button is clicked, I want to send a GET request to my feedback API route to trigger this else block and get that feedback data. For this, in the front end, in index.js, in my homepage component, I add another function which should be triggered when this new button is clicked. And that could be the load feedback handler function. Name is up to you. And in there, I also want to send a fetch request to /API feedback. So I will actually copy that code from up there and paste it in here, but I'll not set this configuration object because here I do want to send a GET request. I have no extra data that should be added to the request, and I therefore also don't need to set any headers. So just sending a GET request by just passing in the URL is enough. Now let's connect this load feedback handler to this button here through the onClick prop, load feedback handler. And then we can, of course, do more useful things with our data here as well. Currently, we're just logging it to the console. We could also set some state that renders the feedback items. So let's maybe do that. Let's import use state from React, and let's register some state here by calling use state. And let's say initially we have an empty array for our feedback items state, and then a set feedback items updating function. So that could be state, which we now use in the homepage component. And now I want to set my state whenever I did fetch my feedback data. So then here in the load feedback handler, instead of logging the feedback to the console, I'll call set feedback items to update that feedback state. And I want to update it with that data that was fetched. Now keep in mind that the data we're sending back will be an object with a feedback property which holds the actual data parsed from the feedback JSON file, and therefore it's this feedback property which will give us access to that feedback array stored in that file. Hence, when we work with our response data on the front end, we want to set data.feedback as our feedback items, because that is then accessing that feedback property which is being set on the response and which therefore does hold those feedback items in that array. And now we're setting that state, and we can now use that state in our homepage component below the button to simply output an unordered list of feedback items which we map to list items, where I then, for example, simply output item.text, because my feedback items, as stored in feedback JSON, do have a text property, and these are the items we're working with here. So we can output the text here, and since we're mapping, also set a key to item.id as a unique identifier per item. With all that implemented, if we save everything again, if I click load feedback, you see that data shows up here. And if I reload the page and open the network tab, you see that if I click load feedback, a request is sent to feedback. It's a GET request to my domain /API/feedback. And there on the response, you see we got that feedback data as JSON. So that is how we can then also send a GET request to an API route. And the special thing here is that we do this behind the scenes with JavaScript on the already loaded page. Now let's make this a bit more complex. What if I don't just want to have my load feedback button here, but I also want to have a, let's say, /feedback route here. So not /API/feedback, but just /feedback, which should load a new HTML page. So a page rendered in the browser, which also lists my feedback. So now I want to add a new normal page, not an API route, but I want to add a new normal page. That is still possible. We can still add a feedback.js file here as well, in the pages folder, but outside of API, or as you learned, alternatively, add a feedback folder with an index.js file in there. That's the equivalent to having a file named feedback.js on the level above, and that's therefore what I'll go with here. And then in this index.js file, inside of that feedback folder, we can again create our regular component, the feedback page component, which we export. And then here we can, of course, also render our list of feedbacks. And we can now, of course, also just fetch our feedback data whenever that component is rendered, for example, with help of useEffect to implement client-side data fetching, as you learned it in the data fetching section. But maybe we also want to pre-render this page and pre-fetch the data for pre-rendering. And that is something which we would do by exporting an async function called getStaticProps. That's what you also learned before in this course. We can still use these features even if we also use API routes in the project. Of course, I would say, because using API routes is an extra feature. It doesn't change the way Next.js works. So we can still add regular pages with features like getStaticProps to also have some server-side or Node.js code that is executed there when this page is pre-rendered. Now, the interesting thing is, though, what if we now here want to fetch our feedback data for pre-rendering this page? So here through props in this component, I expect to get my feedback items, let's say, and I want to map them into list items, where I then still output item.text and where I then still have my key set to item.id. But now feedback items should be received through props with help of getStaticProps. How can we now make that work? Well, we did see similar examples in the data fetching sections. There we, for example, also talked to Firebase, and we then used the fetch API here, the fetch function here inside of getStaticProps to still send a request to an API and get data from there. And that works as you saw there. But whilst this is absolutely fine for external APIs, like the Firebase API, you should not use fetch inside of getStaticProps or getServerSideProps to talk to your own API. Instead, since this is all part of one project and therefore ultimately all served by one server, what you should do instead is write any Node.js logic that should execute here directly inside of getStaticProps. So if we have some logic in our API route, which also might need to be executed here inside of a regular page, then we should just make it available through an export so that we can run the code defined in the API route directly here inside of getStaticProps or getServerSideProps. So that means that here in this case, this code for building the feedback path and extracting the feedback should be executed directly here in getStaticProps. We just don't want to set some response status code and return a response because that's not what getStaticProps is about. This is just about producing the data for our page component. But since I already have extract feedback and build feedback path in separate functions, we can just export these functions to make them available outside of this API feedback.js file, export both functions, and then in index.js we can import these functions. We can import from going up one level, diving into API, diving into feedback, and import from there. Or we put those functions into a separate other folder and file right from the start. We could add a helpers folder on the root project level and store our functions in some file in there. That would also be fine. But here I'm importing from that API feedback file, and I'll import the build feedback path function and the extract feedback function. Now the cool thing is that Next.js will detect that what we're importing here is in the end code that we'll only use inside of getStaticProps, and therefore that code will still not be included in the client-side bundle. I talked about this in earlier sections already. Code used in getStaticProps and dependencies used in there, so imports used in there, will not end up in the client-side code bundle if we're not using that code anywhere in our client-side code. So therefore here we can now call build feedback path to construct our file path here. And then we can get access to our data by calling extract feedback and passing in the file path. And then we just return our standard object with the props key, as we always do it in getStaticProps. And we expose our feedback items, because that's what I'm looking for on my props here, which is my data. Because the data I'm extracting is that extracted array from feedback.json. So now we have that code here inside of our regular page instead of using fetch and sending a request to our own API route. Because when working with your own API routes and when requiring them in your regular pages, you should not send the HTTP request to them, but instead leverage the fact that it's all running on the same computer, on the same server. And therefore, just import it and directly run that code instead of sending that unnecessary HTTP request. And with that, if we save all of this and I visit my domain/feedback, you see that is also showing up there. And if we view the page source, we see that it was pre-rendered because of getStaticProps. So that is how you should interact with your API routes when you're using that data for pre-rendering a page, no matter if you're using getStaticProps or getServerSideProps. Okay, so now we also know how to work with our API routes inside of getStaticProps. We don't send a request there, we just execute the code directly in getStaticProps or getServerSideProps. Now let's talk about dynamic API routes. What's that? Well, let's say you don't just want to have /API/feedback, which handles post and get requests, but you also want to support /API/feedback/some_feedback_ID to just fetch the single piece of data for that specific feedback item. Because maybe you need that somewhere on your page. For example, on the feedback page, You could say that for every list item you're rendering here, you also have like a show details button. And when that button is clicked, you want to show the details for that feedback item. And hence you want to fetch the data, the full data for that feedback item. Now we are, of course, actually fetching the full feedback data here, and we could just use client-side JavaScript to use that already loaded data for that. But let's assume that we're not fetching the full data here, but that instead we are only getting the ID and the text and not the email address. And therefore, when this button is clicked, we want to fetch the full data again, but not for all feedback items, but for this single feedback item. And that's what you could use a dynamic API route for. Because we already know dynamic pages, where you create a page with that square bracket notation like this. This would then allow for a request sent to /feedback/SomeID, and SomeID would be interpreted as a value for this ID placeholder. And you could then use it inside of that page component and so on. That's what we already learned before. Now that's for regular pages. We can use a similar feature for API routes, because it's also not unrealistic that we want to send a request to /API/feedback and then the ID of a specific feedback to then load the data for that specific feedback. And for this, we need a new file, because here in feedback.js, we only handle requests to /API/feedback/nothing. Hence, in the API folder, we can add a dynamic API route. And we do that in exactly the same way as we do it for our regular pages. We use square brackets and then any placeholder name of our choice, like for example ID or feedback ID or whatever you want. And I'll go with feedback ID. So now we have a dynamic API route file. In there, we still define our handler function and we still export that. So just as in the other file, because it works in exactly the same way. This API route works in exactly the same way, it's just dynamic, so for dynamic path segments. So therefore in here, we might now want to fetch the data for a specific piece of feedback, and for that of course we need to know which concrete value was encoded in the URL as a value for this placeholder. And we can get access to that again through this request object, which we should accept together with that response object. And there we learned that we have body for accessing the submitted data, method for finding out which kind of request it was, and we also have query for getting access to query parameters and regular parameters. So we can get access and get our feedback ID by accessing rec.query.feedbackID. .feedbackID because I encoded feedback ID between the square brackets here in my file name. So that gives us access to the concrete feedback ID that was part of the URL when that request hit that handler. And now we can use that feedback ID to retrieve a specific feedback item from the feedback.json file. For this, I still want to get access to that file, so I will still import my two functions from that other file here. So from the feedback.js file, the build feedback path and the extract feedback functions. Again, we could outsource them in some global helpers file if we wanted to. And then I'll construct my file path by calling build feedback path and get my feedback data by calling extract feedback and passing file path as an argument. Now feedback data is then an array of all items, and now here I just want to get all the data for one specific item. So since this is an array, we can of course just call feedback data.find to find one single item, which then executes a function on every item to find out whether that is the item we're looking for or not. And the item we're looking for is the item where feedback.id is equal to feedback ID. So that is then the selected feedback, and that's the kind of data we now want to send back with that for incoming requests. And for this, we use the response object, set a status of 200, and set our JSON response body data, which could carry an items key, which is an object here where I set the feedback key, let's say, to selected feedback. And now that would return a feedback for a selected ID. Now, just to make that crystal clear, your dynamic API routes cannot just handle GET requests. Here, I'm not checking the request method at all, which means that for all incoming requests, I'm just sending back this JSON data. But we could also check the request method here and do something different for post requests if we needed to. For example, you could check for delete requests, and if a delete request is sent for a specific feedback ID, you could execute some code that deletes that feedback from our stored feedback items. It's not a functionality I need here, but it is something you could also build. So dynamic routes work for all request methods, put, post, delete, get, and so on. And you can, of course, differentiate what you do inside of your handler function with if checks. Here, I just want to return my selected feedback no matter which method was used, though, and therefore that's the code we can use. Now we added this API route. Now we can use it in our feedback page. Here, when this button is clicked, I want to send a request to this dynamic API route to fetch the details for a single feedback. And for this, in the feedback page component, we can add a function, load feedback handler, or whatever you want to call it. And then in here, send a request. So now let's connect load feedback handler to this button with onClick. And in load feedback handler, we now need to know for which ID to load the feedback. So we expect ID as a parameter. And to make sure that this ID is passed in, when we bind our load feedback handler to the onClick prop, when we pass it into onClick, I'll call bind on that function, which is a built-in JavaScript method to pre-configure this function for future execution. If it's not clear how bind works, attached you find an additional resource on that which clarifies it. Bind in the end allows us to pre-configure this function, so it does not execute the function yet, but it pre-configures it for future execution. And it, for example, allows us to pre-configure parameter values that will be received here. Now, the first value, the first argument we pass to bind is a value for the this keyword inside of this function. We don't care about that here, so we can set this to null. And then the second value we pass to bind will be the value for the first argument, the first parameter received by that function. And here that should be item.id, so that this button, when it's clicked, for this function execution uses the ID of the item we're currently rendering. So that's then the value which we receive here. And then we can use the fetch function to again send a request. Send a request to /API/ and then the feedback ID. So we add ID to that path. Or we build that with the template literal notation with backticks and send this to /API/ and inject ID like this. Either way, this produces a URL like /API/ some feedback ID, and that will then trigger this dynamic route. Now we're still working with promises here, so we'll then still add a then block to get our response eventually and parse that data. We could also add error handling here, but I'll not do it here to keep this shorter. And then we got this data, which we can use in this second then block. Now here we might want to render the details. So again, we can use state for this to update our component and what's rendered once we got the data. So from React, I'll import use state here and then set up some state for this component, the feedback data, let's say, with the set feedback data state updating function, where we call use state. And initially that's undefined. We have no starting value. But in this then block, once we have the data fetched from our API, we can call set feedback data to set data.feedback like this as our new state. Now data.feedback, because in this dynamic API route, I'm setting a feedback property in that response object. So that is the property holding the selected feedback data. So that full feedback object fetched from feedback.json. And therefore it's this property named feedback, which I want to access here in my frontend code as well as my feedback data. That is then that object fetched from feedback.json, which I set as my feedback data here. Now, when that's called, the component will be re-evaluated because the state changed. And we can utilize this to output the email address for this feedback. So when that button was clicked, we now want to show the email address. And since I always just have feedback data for one specific feedback loaded, the way my component is designed here, I'll do this above the unordered list, use fragment, import it from React, because adjacent JSX code isn't allowed otherwise. Move that in here, and then here, render something conditionally. If feedback data is set, then I want to output, let's say, a paragraph where I just output feedback data.email. The .email, because feedback data will be a single piece of data from feedback.json, so such an object. And in those objects, we do have an email property. So we can access that here. And then we'll show up the data for the loaded feedback for a single piece of feedback above the list of feedbacks. Now that is, of course, all just some very basic unstyled dummy code to show you how you can interact with those API routes. Hence, if we now save everything and reload /feedback, we do have the show details button. And if we click it, we see eventually the email address of that feedback shows up at the top. Now, as mentioned before, this is kind of redundant because with getStaticProps, we already fetch the full feedback data. So we have all that data exposed through props in that component already. So sending another request for a single piece of data here is redundant. But of course, it's not redundant for you to know about this dynamic API route feature, which is why I used this example for showing this to you. Because this is how you can send requests to dynamic API routes and how you can set up dynamic API routes to execute server-side code for dynamic pieces of data encoded in the path. Now we know about API routes, including dynamic API routes. Now it is worth a note that there are some alternatives to how we name and structure our files inside of the API folder. And those alternatives are equivalent to the different approaches we can use for regular pages. For example, you can also have catch-all dynamic API routes by adding 3 dots in front of any placeholder name of your choice. This will then not just handle requests to /API/some-value, but also to more segments you might have, equivalent to what you learned about regular pages and catch-all pages. Now, we don't need a catch-all dynamic API route here, but it is worth knowing about it. It's also important to understand how Next.js prioritizes these different files. If we send a request to /API/feedback, it's the code in the feedback.js file that will be executed. Now, that is not necessarily obvious because we have this dynamic API route. So it could also be possible that requests to /API/feedback are consumed by this file because feedback is simply treated as a concrete value for this feedback ID placeholder. But Next.js is smart, just as it is for regular pages. And if there is a more specific page for a given path value, so since we have a feedback.js file in this case, it will use that more specific file, which makes more sense for this kind of path than the more generic dynamic file. /API/some-value, on the other hand, would trigger the code in the dynamic API route. So that's just worth knowing. It automatically works correctly here, but it is important to be aware of the fact that Next.js will do this prioritization for you. Now, another important thing to know is that you have some flexibility regarding how you structure your files. You can add a feedback.js file in the API folder to support requests to /API/feedback. Alternatively, just as with regular pages, you could also add a feedback subfolder in the API folder and then move the file in there and rename it to index.js. And here VS Code is asking me whether it should automatically update all imports that pointed at this file. And I will say yes. If you don't get that prompt or you chose no, you should manually update those import paths. So that is the alternative. A file named index.js in the feedback folder in the API folder is the equivalent to having a feedback.js file inside of the API folder, just as it works for regular pages. We can also move our feedback ID.js file in there. But if we do that, that of course also changes the way our API works. Previously, since feedback ID, this dynamic API route, was directly in the API folder, previously /API/some-value triggered the code in this feedback ID file. Now, since we're in the feedback subfolder, it's actually /API/feedback/some-value that triggers the code in here. Now, that is actually a path that makes more sense to me. It's more descriptive. It's clearer that some request sent to /API/feedback/some-value should fetch more details for a single feedback than if we have just /API/f1. That doesn't tell us that it's about fetching feedback data if we just look at this kind of path. And hence I will keep this structure of having the square bracket feedback ID file inside of the feedback folder, inside of the API folder. However, that means that in the index.js file in the feedback folder in the regular pages, so in the feedback page component, we also need to update this URL and send our request to /API/feedback/some-ID, because I changed that structure in the APIs folder. And now it looks like I broke some imports as well. Yes, here we should import from the index file. And now that works again. So if I now reload, that all works, that works, looking good. So that is how you can also structure your files and folders in the API folder in the pages folder. It essentially works just as it does for regular pages. And that's it for API routes. Another very useful feature Next.js offers to you, a feature which you won't need in every project you're building. Not every Next website needs API routes, but if you have some backend functionality that should be triggered through client-side code, like we're doing it here for loading feedback or for storing feedback, then API routes can be super useful because they allow you to add extra functionality to your website, which might rely on an API, like users sign up for a newsletter, without having to build an extra API backend, without having to build a totally different project. Instead, you can easily inject API routes as we're doing it here by using this special API folder in the Pages folder, and you can write server-side code here, which is then triggered for requests to these API routes. And here you learned that you can find out which kind of request was sent, that you can extract request body data, and that you can send back responses with different status codes and also with different kind of data. You learn about static API routes and dynamic API routes and how you can structure your files and folders here. And with that, you got another important tool in your toolbox, which allows you to really build any kind of project and any kind of website you want, because Next.js has all the features you need for that. Again, it's time to apply what we learned. We're going to apply our newly gained knowledge about API routes to this events project we've been working on throughout this course. In detail, in this course section, we are going to add a newsletter registration flow, a component that allows a visitor to enter an email address and then stores that email address somewhere with help of API routes. And we're going to add a comments feature where you can comment on an event. So we'll also add a form there. And when the form is submitted, that entered comment data should be stored on the backend with help of API routes. And when we load a single event, we also want to be able to load the comments when the user wants to view the comments section. Now we're going to add and build the front end together. So we're going to add a couple of components together, but thereafter, after the next lecture, I challenge you to try adding those API routes on your own before we do that together and before we then also see how we could talk to a real database. So lots of features to add, lots of topics to cover. Let's dive in. Now for this course section, I updated our project code a little bit. You find this updated snapshot attached. What did I do? I added a new input folder in the components folder. So in the components folder, there is this new input folder, which contains a bunch of components which we're going to need in this module. These are all regular React components, no page components, which we are going to use for fetching user input and for then talking to the API routes. Now I have not added any API routes. The only other changes I made, besides adding these components, is that I'm using these components. In the events folder, in the pages folder, in this event ID component, I added the comments component here at the bottom of this JSX code. And in the index.js file, so in the homepage component, there I added the newsletter registration. So if you install all dependencies and you run this updated snapshot, then on the starting page, you will see that email, this newsletter sign up part here. And if you explore a single event, there, if you scroll to the bottom, you'll see this show comments button, which you can click to view the comments form and some dummy comments, which we're going to replace with actual comments throughout this section. Now that is the starting state. And now I got a challenge for you. I want you to add a couple of API routes that handle the newsletter sign up, so that in the end handle an incoming email address, and then for the moment maybe just log it to the console, so you don't need to add any code that writes to a file or talks to a database, though you can also do that as an extra exercise. But for this task here, just make sure that you accept some request from which you retrieve the email, and make sure that such a request is then sent from the front end, from this newsletter registration component here in the registration handler. Make sure you send the request to that API route which you should add. You can also add validation for the user input to check whether the entered email was valid, but that is up to you and not something you have to add. Now that is the first challenge, the first task. It's not the only one though. We also got this comments section, and there I want you to do a similar thing. Add another API route that allows users to submit comments, and make sure that this API route is kind of dynamic, that the ID of the event to which the submitted comment belongs is part of the URL of the API route. So you'll need to create a dynamic API route here. Then again, handle incoming requests and make sure you extract that submitted data, and also handle the case that a request is sent to fetch the data. So you will need to handle two different HTTP methods. For the newsletter API route, it was only one method. You should handle post requests there. But for the comments API route, you should handle two different HTTP methods. Incoming post requests, which add a new comment, and incoming GET requests, which fetch comments. Again, for the moment, it is enough if you just log the data, if you just log something in your API route. You don't need to write any other logic. Just return some dummy data in the GET request case, and make sure you do send data and fetch data. We have this add comment handler in comments.js where you should send that comment data to your API route, and then also find a way of fetching comments when the list of comments here is shown. So when that comment list is shown, make sure you then fetch comments from the API route. And again, for the moment, it's okay if you just return some dummy data there. Just make sure you implement the base logic and you add those API routes. Now, definitely try it on your own first. In the next course lectures, we're going to add those features together step by step, and therefore, of course, also have a look at those lectures once you tried it on your own to see how I solved it and to compare your solution to mine and maybe improve or fix your solution if you got stuck somewhere. And with that, let's dive in. Okay, let's now solve this together. We want to add a couple of API routes here so that we can have our own server-side logic which is detached from rendering pages. And you'll learn how that works. In the pages folder, you add that special API folder which has to be called API. And in there, you can now again create any file and folder structure of your choice to define the different API routes and the paths leading to those routes you want to use. For example, we could add a newsletter.js file for the newsletter-related logic. Then you learned that an API route in the end just is a function inside of that API route file, which you should export like this. And this function receives a request and a response object, automatically passed in by Next.js when it executes this function for incoming requests. Here we can then check the request method, for example, to only proceed for post requests. And we can do this here for the email registration, because whilst this is the only kind of method I want to support here, I want to make sure that no other method triggers any logic here. So I explicitly check if the incoming request is a post request, and I only want to proceed in that case, because in that case I, for example, also know that I can extract data from the request body, because, for example, GET requests would not carry any data. So with that, we can extract data from the request body, and we can do this with the request body field, as you learned. Here, we could then expect that we have an email field, and that's up to you. You are the developer of this site, so it's up to you how you transmit your data. And I will therefore expect an email field. So the user email is then extracted from the incoming request. Now here we could then also validate this and check if it's maybe not valid, or if email, user email, I mean, does maybe not include an @ symbol, which is a very basic email validation. You might want to implement a more thorough one, but it's a start. And such server-side validation is optional, but strongly recommended. Because even if you add validation and checks in your front-end code, those validation steps can always be circumvented. After all your front-end code is exposed to your users, so they could also manipulate it. So you shouldn't rely on front-end validation. Front-end validation is always just a convenience feature for your users. Instead, to really make sure that you get valid data and that you work with valid data, you should validate in your API route, because this code can't be viewed or changed by your users. Now, for this task here, it's optional. I did not tell you to add such validation. So if you did not do that, that's totally fine. I just want to bring it up here because it is important to be aware of the role server-side validation plays. Now here we could then return to cancel the further function execution if we make it in here. So if we have invalid data, and we could return a response with a status code of 422, which is a status code signaling that the user input was bad, and then maybe set a message of invalid email address, something like this. And we would send this response back to the user if the input is invalid. And thereafter I return to cancel the function execution because I will add more code after this if check, and I don't want to execute that code if we have invalid input, hence the return statement. Now, if we do make it past this if block though, we know that we do have a valid user input, and then we could store it in a database or anything like that. For the moment, we'll not do this. For the moment, I'll just console log that user email. And that is now a first API route as we could write it. An API route for extracting an incoming email address. Now we want to send a request to this API route. And we want to do that from inside the components input folder, from inside the newsletter registration file. Here we have the registration handler, which is triggered when the form is submitted. And here I am preventing the browser default then to avoid that the page is reloaded. Now we could also validate the user input here and show an error message if it is invalid. Again, validation here is then just a convenience feature to show some feedback to the user quickly. It's not something you should rely on. And it's not something I will add here because it has nothing to do with API routes, but of course feel free to add it in your solution. Now, in my case here, I will not add it. I instead want to send the HTTP request to the API route we just added. And again, we can, for example, do this with the fetch function, which is built into the browser. Now, for the URL, you learned that the API route is hosted by the same server as our pages are sent back from, so it's the same domain. And hence, we can just construct an absolute path to the API route with /API/newsletter in this case. /newsletter because I named my API route file newsletter. If you named it differently, you have to use a different identifier here in your URL. Now we want to send a post request because we need to add some data to the outgoing request. And hence here I'll add this configuration object to fetch, where we can set method to post and then add a body. Now speaking of that body, we need to get access to the input value here. And there are two main ways of doing that. We can add state and update the state with every keystroke, or we use a ref, and I'll do the latter since I only need access to the input once when the form is submitted. So for this, I'll use ref, which we need to import from React. We can create our email input ref here, like this, and then connect it to the input element by adding the special ref prop and pointing at email input ref, like that. Now this is connected, and now here we can extract our entered email inside of this registration handler. We can get the entered email by reaching out to the email input ref.current, because that's how refs work, .value, to get the currently entered value. And that's then what I want to send to the backend. Now we need to send our data as JSON data here. So I'll call JSON stringify, and I'll pass in an object where I set an email property to entered email. And this should be an email property because in the API route, I'm extracting an email property on my body. So I'm looking for an email property in my body. So if you chose a different identifier here for extracting the data, you also need to choose a different property when you send the data. I'm using email, so I'm using it in both places. And then last but not least, I'll add headers and set a special content type header like this, and set this to application JSON to make the API routes aware of the type of data my request body will carry. And that will be JSON data because I convert my data to JSON with JSON stringify. So this sends a request to the API route. And now we can, of course, handle the response and then the response data if we want to. So here I'll just get access to the response data by calling the JSON method. And then here we can console log the data to just console log the response. And speaking of the response, there's one thing missing in the API route. I do send a response here if we have an invalid email address, but we should absolutely also send a response if we have a valid one. So in this scenario, after console logging the entered email, I'll send a response with a status code of 201, which means success, a resource was added, so the email was stored. And then we can, well, send back any kind of data, like for example, a JSON object, so a JavaScript object converted to JSON with help of that JSON method, where we add a message property where we could say signed up, anything like this. If we do that and save this, we can check if this works. If we reload our application and open our developer tools, if I enter something invalid here, I get a warning from my browser actually, because this is of type email. So we have to add something valid here as well, though that could be disabled in the browser, so we should not rely on it. But if I do enter a valid email address here and I click register, that's looking good because I'm printing that response data here, which says signed up. And in the network tab, we also see that this request was sent successfully and that we got this 201 status code back. And if we have a look at our server-side terminal here, so this terminal where we started npm run dev, where all our server-side logs will be printed, we see that test@test.com is output here, and that makes sense because we are console logging the arriving email address here in our API route. So this is now working, and you can certainly enhance this and improve error handling or do anything like that, but this is the core functionality which you should add here as your first task. Now we worked on the newsletter registration, let's now work on the comments area for our individual events. Here the goal is to again add an API route which accepts incoming data, this entered data, and then for the moment just logs it to the console, but which in addition also returns data for GET requests. And the API route should be dynamic because the ID of the event to which the comment belongs should be encoded in the URL. That was part of the instructions. Hence, I'll add another API route in the Pages API folder, and I'll use square brackets in the file name here, since it will be a dynamic API route. And I'll name my dynamic path segment identifier here event ID, because that is what should be encoded in the URL. Now we could leave it here, but I will actually create that file in a comments folder so that the full API route to reach that file and to execute the code in that file will later be /comments/some event ID. Because I think that is easier to read and makes more sense than just /some event ID. There it's not clear that this refers to comments. If the full path is /comments/some event ID, that makes more sense. And of course there's /API in front of all of that. So therefore here we can again define our handler function, which gets a request and a response, and export that inside of this event ID file, like this. And now in there, we need to handle two different cases. The case that it's a post request, which we get, and the case that it's a GET request. Hence again, we can check the request method here, and check if it's post, and then do something, and then also check else if, or in another if statement thereafter, if request method is GET. And if it's something totally else, we do nothing, and therefore we don't return a valid response, but that's fine because for this application we don't intend any other usage. So now here we support post and GET requests, and we can now implement the different logic. Now in both cases we need to know for which event we should add a comment or return the comments. That's why we made this dynamic. And hence, before we dive into any if block, we can already retrieve the event ID from request query. That's what you learned in the last section. This is how you can get access to the concrete value entered in the path as a value for this placeholder. So here it's request query.event ID because I chose event ID written like this between my square brackets. If you chose a different identifier here, you have to choose a different property here. Now with that I get my event ID though. Now what we want to do differs on which request method we have though. If it's a post request, we get data for a new comment. So then we want to add server-side validation here, because I mentioned that you can't trust client-side validation. Therefore here, I will add server-side validation and check if the entered data is correct. For this, we first of all need to extract the entered data, so the data which is part of the incoming request, from the request body. And here I expect to get 3 pieces of data, which I'll pull out of the request body with object destructuring. I expect to get the email address of the user who left a comment, the name of the user, and then the comment text. And therefore, of course, when we later send a request from the client, so from the front-end code, we need to make sure that we include exactly these three properties into our request data. That's our responsibility later. With that, we'll then be able to extract it like this from the incoming request body. And then we can add validation logic. We can check if not the email address includes an @ symbol, or if we don't have a valid name, or if name, if we trim it, is equal to an empty string, which would also be invalid, or if we don't have a text, or if the text, if we trim it, is equal to an empty string. If any of those conditions here is met, the input is invalid, and then I want to return. I don't want to continue with the function execution, and I then also want to send back a response with a status code of 422, which stands for invalid input, and some message of our choice. For example, we could say invalid input. Of course, you could add a more elaborate validation, but that's good enough for now. So with that, we validate the user input. As a next step, after this if check, but still in the post method if check, we wanna do something. And for the moment, again, I'll just console log the data which we received. So I will console log email, name, and text here. We will soon do something more useful, but for the moment, that's it. Thereafter, I want to send back a response with a status code of 201, because we will have created a new comment. We don't actually do it here, but we will soon do so, and send back some data in JSON format, where we could send back a message of added comment. And actually, we can create a new comment object here, a new JavaScript object with some random ID. For the moment, I'll just use the current date timestamp to create a dummy ID. We will also soon have a better ID, but for the moment, that's good enough. And then add email, name, and text here as fields in that object. And therefore then, as part of the response, not just send back the message, but also the comment that was created, that new comment. So that we create it here and we send it back. And actually then we can also log that new comment here instead of the individual inputs. So that is then my actual logic for this case, for the post case. Now, if we get a GET request, we want to send back a list of comments. At the moment, we have no such list because we have no data source, no database yet. And therefore, at the moment, I will just create a dummy list of comments, which is an array where I add a couple of dummy comments with an ID, a name for the user, and an email address like this, and then also the comment data. Actually, we don't even need to add an email address because we will not use that on the front end anyways when displaying the comments. So here, let's maybe also name this text. And then let's add a text like a first comment here. And then add a second comment with C2 by manual, where I say a second comment. And of course, it shouldn't be a fist, but a first comment. Okay, so that's my dummy list of comments, which we will later replace with an actual list coming from a database. But for the moment, it's this. And then we send back a response with a status code of 200 with some JSON encoded data, where we have our comments, which is just this list of dummy comments for the moment. And that's the API route for the comments feature. Now let's send the appropriate requests from the front end. So from the front end, we want to send requests to our newly added comments API route. And it's the new comments component where I want to start with this. Here we have the send comment handler. And in there, we get all the user input, and we then have some client-side validation, which we shouldn't trust, but which is still there. And we then call onAddComment on props, which should be a function, where we pass an object with email, name, and text. And onAddComment then in the end is a function here in the comments.js file, this addComment handler, which is passed as a function through the onAddComment prop on the new comment component. And here we then receive that comment data, which should be sent as a request. Now, I actually do need to connect my send comment handler to the form. So here with onSubmit, I point at send comment handler to connect that. And then in comments.js, we want to send a request. So here again, we can use the fetch function for this. And the route now is /API/, and then it's comments because of that comments folder, slash, and then this file, but of course with a concrete value for the event ID. Now that event ID is something which we get through props here in the comments component. It's in the end passed in by this page, by this event ID page, so this real page, not the API route, but this real page. There into comments, I pass in this event prop, which points at the ID of the event we're loading here. Hence, in the comments.js file, we get this event ID prop, and that is what we should add as a concrete value to the route here, to the path. Then it should be a post request. Hence, we add this second argument to configure the request and set the method to post and the body then to our data. And here I'll use JSON stringify to send my comment data, which is this data package we get from the new comment component, which contains email, name, and text. And here I'm using these property names, email, name, and text, and hence it's these property names which you should be looking for in your API route, email, name, and text, so that the data can be retrieved correctly, because I'm just forwarding that data with my HTTP request to the API route. Then I'll add these extra headers to clarify the content type I'm sending here, application JSON, and we should be good. Now we can again wait for a response and parse that, and then as a next step, thereafter, get back some data, which we, for example, console log, like this. With all that implemented, if we save everything and go back, if I try to submit this empty form, I get an error here, because I have some built-in client-side validation. If I disable this client-side validation, if I go to the new comments.js file and I comment out this code here, and I submit this, it is submitted, but now in the network tab, if we open that and submit this, we see that the request actually fails, it's red, and it has this 422 status code, which we do send back from the API route if our server-side validation fails. And that server-side validation, unlike the client-side application, can't be tricked. So it is good to add logic like this. Nonetheless, I'll bring back that client-side validation because, of course, for the user experience, it's better if we already validate the data and show an error before we even send a request. So with that back, let's now enter some valid data here. Let's enter an email address and a name and some text. This is my comment, and click submit. And now this succeeds. We have the 201 status code, and in the response we see the message and this comment object with the dummy ID, which was created on the backend. We're also logging it in the console here. So this works, and if we have a look at the server-side log, so the terminal where we run npm run dev, we also see that object here. So that works, and we do send that data. Now, last but not least, before we then add some real logic talking to a database to our API route, let's also fetch comments in the comments.js file when we do show our comments. Now, for showing the comments, we have the toggle comments handler, and that is executed whenever this button here is clicked. And whenever we do show comments, I want to load the comments by sending a GET request to this comments API route. So I want to trigger this part of this handler function then. And to achieve this, we got various different ways. We could go into this toggle comments handler function, for example, and here we change the state, but this will not be processed instantly by React. It will be scheduled, and in the next line thereafter, the state will not be updated yet. So here we could check if show comments is true, which means the current state is show comments, then the button was clicked and this function executes again. So the goal is to hide them now. And therefore we could check if not show comments, which means the current state is that the comments are not shown, then this function executes, and the new state is that they will be shown. So now we should fetch data, and that's something we could do. Or alternatively, we use good old useEffect here, and also import that from React. And in here, simply add show comments as a dependency. And in the effect function, we then check if show comments is true, which means that comments are shown. And if that is true, we want to fetch the comments. So then here we can send our request to /API/comments/event ID. So this concrete event ID. We don't need to configure it because it will be a GET request, not a POST request. So the default is fine. And then we also get our data and parse that so that we have the real data here eventually with which we can work. Now, once we got that data, we want to use the data to set the actual comments, which should be rendered here with help of comment list. So for that, we can manage another piece of state with use state, a list of comments where I have my comments and set comments to update them like this. And I want to set comments once I got them. So here in this then block, once we got a response, I'll set my comments. And in the API route, we send back an object with a comments key, which then contains this array of comments. So when we work with that data, I want to set comments equal to data.comments to access that array of comments, which is set in that response data package, which has this comments key, as we just saw. That then sets that comments state to those fetched comments. And that means that we can then use them to render them. So this comments state could then be passed to comment list, let's say through an items prop, like this. And now in comment list, we need to work with this items prop. And of course, you can name that prop differently. In there, I'm not expecting any props right now, but we should change this, add the props parameter, and extract items from props. And then we can use items to render these list items dynamically. So we just go through items and map every item into a list item with content like this. So cut this and add it here and get rid of these dummy list items down there. And then here add a key on every list item, which should be item.id. Here as a text, we want to output item.text. And for the address here, we want to output item.name, so the name of the user who wrote the comment. With that, we have our list items, which should be rendered, and we can now check whether that works. Let's reload this page for a single event and click on Show Comments. And we see the comments showing up there. And in the Network tab, we can also see the request there. If I hide the comments and I click Show again, they are fetched again, and hence we see the request here, and we see that it carries the comments in the response. I guess that's kind of obvious because we also render them successfully here, so it clearly works. And these are the core tasks which I gave you solved. We added the newsletter registration and now also this comments feature for storing comments, or for at least submitting the comments, I guess, and for fetching the dummy comments. Now, it's not very realistic yet, though, because we are only working with dummy data and we're not storing the submitted comment anywhere. Therefore, in the next step, let me show you an example of how we could talk to a real database to store our data there and to get our data from there. So now that we added our API routes for the newsletter and for the comments, and that we wired up those front-end components for the newsletter and for the comments, now that all of that was done, it's time to work on the logic inside of the API routes. Because at the moment, we don't do anything in there. In the newsletter API route, we're just logging the entered email. And in the comments API route, for the post case, we also, in the end, just log our comment here. And that, of course, is not too helpful. That's not the goal. Instead, we want to store that data more permanently. And we could, of course, use a file for that. We could re-add a data folder in our project with some JSON or text file and write that data to that file. But I would argue it's more realistic to use a database, and therefore that's what we'll do. I'll use a real database here. I'll use MongoDB. MongoDB, of course, is just one option. It's not a must-use option, but I will use it because using MongoDB with Node.js is particularly easy, and it's also a production-ready, scalable database, which is a great choice for pretty much all projects, for a lot of projects. Let's put it like this. And that's why we'll use MongoDB. Even better than that, we can get started for free. If you visit mongodb.com and you go to pricing, you'll see that they have various offerings, and we will use the cloud service here, MongoDB Atlas. That is their fully managed cloud database service, which we can use without setting up anything on our local system, which is great. And we can get started for free here, which is awesome. So we can click on Start Free here, actually. Or in the top right corner, click on Try Free, click on Cloud then, and then get started for free here by signing up. Just fill out these basic details and sign up. I already do have an account, so I will log in with that. And once you did sign up and log in, you should be greeted with some screen that looks something like this. You should be able to build a cluster and then there use a shared cluster. So create a cluster here where you can get started for free. Now, a cluster is basically a server, you could say, which will then later host your databases, you could say. Now here we need to choose a cloud provider, which will be used under the hood. And we can stick to AWS here and basically keep the defaults. For cluster tier, let's stick to the M0 sandbox, since that's available for free. And for the additional settings, we also can stick to the defaults, and we can also keep that default cluster name and create that cluster. Now this will set up this database cluster, which will then enable us to connect to this cluster and store data in the databases there. And using it will be super simple. Now, whilst this is getting set up, we can go back to our project already and quit the dev server and install an extra package with npm install. Because in order to communicate with MongoDB and to send queries to MongoDB, we need to install a new third-party package. If you search for Node.js MongoDB, you also find it on npm. It's this MongoDB package, which is the official driver for MongoDB. So that makes connecting and talking to the MongoDB database super easy then. So we should install MongoDB, this MongoDB package here like this with npm install MongoDB. And this will install this third-party package, which we'll then use in our server-side code to talk to MongoDB, to our cluster, and to store data, and to fetch data as well, of course. And the important thing here really is that we'll use it in our server-side code. So in these API routes. We will not use this MongoDB package in any client-side code. A, because it's not optimized for that. It might not even work there because there is a high chance that it uses Node.js APIs internally. And B, even if it does work in the browser, it would be a security issue. Because for talking to the database, we will need to plug our credentials into the code, and we don't want to do that in any code our users can see, because they could then abuse those credentials to hack into our database. That's why we want to run such database code only on the server side, so only in our API routes. Now, connecting to the cluster is done here now, and when we clicked on Connect, we can choose Connect Your Application, and we see code which we can use to connect to our MongoDB cluster with the Node.js driver here. And that's what we're going to do in the next lectures. So let's now connect to our MongoDB cluster, and let's, well, run some code against it. And let's maybe start with the newsletter API route. I will bring back my development server with npm run dev. And now here in the newsletter API route, I want to store that email address in a table, or as it's called in MongoDB, a collection of email addresses, so that we have a collection of email addresses stored in the database. And that then could be used by us to send out newsletters and emails of any kind to those registered users. Now, to do that, we'll need to do two things. We need to connect to the database. And once we are connected, we need to run an insert command to insert the email address into some collection. Now we can learn more about that on the official docs and also on the npm docs of the MongoDB driver already. If we scroll down to Quick Start, there we see that we have some code here for connecting, and that when we are connected, we can insert documents, as they are called, so entries into the collection with insert many, or also with another command, which we'll see. So let's connect to MongoDB, and for that we can use this code, though we can also adjust it here in newsletter.js. We can use ES module imports, and we can import something from MongoDB, like this, and the something I want to import is Mongo client, between curly braces. With that imported, we can use it down here to set up a connection. So here we can then use Mongo client, and as we see here in the docs, call the connect method to connect to a database. So here I'll then call connect, and now we need to pass in our connection URL. Now for that, we can go back to the cluster, because here we got this URL. So we can copy this URL here, and I got there by clicking on connect and then connect your application. So I'll copy that URL and paste it in here as a string. Now here we need to fill in a username, a password, and a database name. Now for a username and password, you should go to database access here and add a new database user with password with any username and password of your choice. So fill in any values here, and then with read and write access to any database. Now I already did create such a user, so I'll just edit my existing user and assign a new password, which I'll also change once this recording is done, so you can't use that user and that password. So I will use that user and password, and hence here in my case, I'll use Maximilian as a username. Make sure to also get rid of those angle brackets here in those placeholders and plug in my password as well. Now for the database name, you can choose any database name you want, because that database of that name will then be created automatically once you start sending queries. And here I'll name it newsletter. Now there's one other setting we need to adjust. In MongoDB Atlas under network access, you want to add an IP address and make sure that you add your current IP address to that whitelist here. You should do that to ensure that your local machine is able to send requests to that MongoDB Atlas cluster. Once you deploy your application, you want to make sure that the server you deployed your site to is whitelisted here. Otherwise, incoming requests will be blocked. So that's something we need to do. And with that, we got this connect string configured. Now, the connect method takes a second argument, which is a callback, which gives us access to the connected client, so to the cluster in the end, once the connection was established. Alternatively, we don't add a second argument and instead add a then block to use a promise returned by connect, which also gives us access to the client once the connection was established. That would also allow us to use async await here if we wanted to. Now we can only talk to the database once the connection was established, so only inside of this then block here in this case. So only in this function where we do have access to the client. That's also what we see in this quick start guide here. There they are using the callback function, but we can use the promise as well. Now in here, we want to get access to the concrete database to which we connected, and we do this by executing client.db. We could enter the database name here, but since we already encoded that in the connection string, we don't need to do that. We can just leave that blank, and we'll use that database to which we connected with the connection string. And once we get hold of the database with the db method, we can use the database to get access to a collection, which is like a table in that database into which we want to store data. And that could be the emails collection in the newsletter database, which will then hold the individual email addresses. Now it's that collection against which we can now run our queries. For example, the insert one query to insert one new entry into that collection. And entries in collections are called documents in MongoDB world. And a document should be a JavaScript object here. And then it can have any key value pairs of your choice. And here I'll have an email field, let's say, which just contains that user email value, which I extracted and validated here. So now I'll insert such a document into this collection. Now this also returns a promise, which will let us know once it's done. And therefore, since we're already in a then chain, we can just return this promise here to add another then block thereafter and continue. However, I'll switch to async await now, since that is a bit easier. And we can do that by adding async in front of our handler function, because these API route handler functions are allowed to be async. They can be async. So I'll add async here. And then I'll switch this all to async await by awaiting the connect method here and getting my client like this. And then removing this here and this here. And then instead of returning here, I will await this insert operation like that. So now we're using async await for connecting, for getting access to the database, and for inserting one document. And then once we're done with all of that, I will send back that status code. We should just do one other thing. We should also use the client again and call close to disconnect from that client. Now with all of that, we should be inserting a new email address into that emails collection in our newsletter database. If we save all that code now, and we go back to our application, to our site on localhost 3000, let's test this. Let me enter a new email address and click register. And we don't get any feedback here. We could, of course, add some, but let's see whether it worked by going to our cluster, and there we can click on collections to see the collections that are part of this cluster. And there you should see a newsletter database with the emails collection. And then inside of that emails collection here on the right, you see that document which we inserted with that email address. It also has an automatically assigned unique ID. And that shows us that everything works. We also got no error here in the terminal, just some warnings which we can ignore here. And therefore, that is how we can now talk to a real database to store our emails. As mentioned, we could now again work on the front end a little bit and provide a better feedback to the user here, but I will not dive into that here since I want to focus on these API routes, since it is these API routes which are the core feature we're looking at here. So now that we're storing a newsletter successfully, let's also store and fetch our comments. For this, I'll go back to the comments API route. And now here we also want to connect with MongoDB and then simply insert a new comment or fetch all comments. So either way, no matter what happens, we want to connect to MongoDB. So before we dive into any if block here, I want to set up my connection. Hence, we need to import Mongo client from MongoDB here, and then repeat the code from before. And of course, we therefore could also look into creating some helper functions, but I will just quickly repeat that. Mongo client connect, and then grab my connection string from the newsletter.js file, paste that in here. And again, I'll use async await. So add async in front of the handler function and await this connection to get access to the client. Now already, after all these if checks, I will go down there and already call client close to make sure that we don't forget this, that we close the connection once we're done with our logic, no matter what our logic was. So now that's that. Now inside of request method post, we want to store our comment here in our database. And for this, I'll create my new comment, but then thereafter, I will use the client and the DB method to get access to the database to which we connected. And for that, actually, I want to adjust the connection string here and not connect to a newsletter database, but instead to my comments database. Or overall, we connect to our events database for the events application, and then we have our emails collection and we have our comments collection. And I think that makes more sense. So I'll connect to the events database in the newsletter.js file as well, and connect to the same database here in the comments API route, events. So then it's this database with which will work. And on that database, I then use the emails collection in the newsletter.js file, or maybe let's now name the collection newsletter, but that's of course up to you. And in the comments event ID file here, I'll connect or I'll work with a collection named comments. And here I now want to insert one new comment. Now it is this comment, but I want to tweak that comment object. I don't want to create my dummy ID anymore because MongoDB will create a unique ID for me. So I don't need to assign my own ID. But instead I want to do something which I haven't done up to this point. I want to use this event ID which we're getting, which is encoded in the URL. And I want to make it clear to which event my comment is related. Because in reality, we would probably manage our events with MongoDB as well. We're not doing that here, but in reality, we would probably manage them in a database as well. So then storing the ID of the related document in some other collection in this document here would make a lot of sense. And that's therefore what I'll do. I'll store event ID as an extra property in the new comment to have this reference to the event to which this comment belongs. And then it's this new comment which I want to insert. So here I'll insert one and I'll insert this new comment. And of course, await this operation. Now we do get back some response here, by the way, some result of that insert one operation. And I will console log that result for now. And therefore, that's now my code here in the post case, so that we add a new comment. Before we work on the get case here, let's save that code and let's see whether it works and makes sense. For this, I'll dive into an individual event, show my comments, and add a new comment with some dummy data. This is a test with MongoDB. Click submit. We still get no feedback here. We could add it, but we haven't done anything in that direction. But if I go to the backend, that looks good. I got an output here. That's this result which I'm logging. Whoops. This result which I'm logging. That's what we see here. And we see that it's quite a long result, quite a detailed output, because result in case of insert one is actually containing full details about the operation that was performed, but then also the connection in general and much, much more. Now what we can see if we go to the cluster is that here, if we reload this page to refresh the data, we got this events database now with a comments collection, and in there we indeed see that comment which I just added. So it was stored successfully in the database. Now what's also interesting on the result is that on the result we also get back that unique ID which was generated automatically. That's interesting because that means that on the new comment object which we stored in the database, we can now add a ID field and set this equal to result.insertedID. So that the new comment which we sent back to the front end also contains this unique ID that was generated. I guess that's convenient to have in case we would work with that inserted comment on the front end right away. So that's now the post case. Let's now work on the get method, where we get our comments. Here we currently return that dummy list of comments, and that's of course not the goal. Let's remove that. Instead, we want to work with our client. So this client, which we got from connecting up here, we want to work with that. And in the get case here, we also want to get access to the database to which we connected, like this. And then on that database, reach out to the comments collection. So of course, the same collection we are working on here. Now, instead of calling insert1, we want to get all the documents in there. And we can do this with help of the find method. The find method finds us data in a collection. And we can restrict the results. We can narrow down the results and we can filter results. But if we call find like this, we will fetch all the comments. And that's the goal here. And in case you want to learn more about MongoDB, I strongly recommend my MongoDB course, which is a full course on MongoDB only. So that might be worth a look then. Here we'll keep it basic and just find all documents. So here we get the documents by awaiting that operation. And to be precise here, we want to call toArray to get all the documents as an array. Because by default, we would not be getting such an array. We would be getting a cursor with which we have to navigate through documents manually. And calling toArray simplifies that and simply gives us all the entries in the comments collection as an array. Actually, before doing that, I want to call sort on find. So on the result of find, I will call sort, because sort allows us to, well, sort the results. And we do sort by passing an object to sort, where we then specify one of our keys in our documents, or for example, _ID for the automatically added ID, and then minus or +1 to define if we want to sort in descending or ascending order. And I want to sort the IDs in descending order, which we can do by adding _ID and setting it to a value of -1. This will sort the comments which we're fetching in descending order so that the latest comment is the first comment in this array which we're fetching. So that's now our documents which we get as an array. And hence, let's now return our documents here and see what we get. If we save this and we go back to our front end, if we open the console there, the developer tools, and I hide the comments and show them again, we're fetching data again, and now I'm getting a warning regarding my key, but we see the comment, so that works. We're only getting that comment here, that warning I mean, because if we have a look at the network tab, we see that the comments we're fetching have that _ID field. Of course, because that was auto-generated by MongoDB. But in my front-end code here, for the comments, in components, input, comment list, I'm referring to .id without an underscore. So the simple fix is to add an underscore here so that we use the correct field as a key for the list items. And if we do that and save this and reload, you will see that we'll not get any warning anymore. Instead, our comments do show up correctly here. Now we could, of course, improve the front end. We could show a loading spinner whilst we're fetching. We could show some feedback after we submitted our form. But again, I want to focus on Next.js and the API routes here, which is why I only provided this basic frontend for the moment. But what we can see with all of that is that working with our API routes works, and that we are able to work with MongoDB in there, so that we are able to connect our API routes and the code running in there to a real MongoDB database. Now that we implemented our MongoDB logic, let's wrap up this course section by adding some error handling to the API routes. because that is also something you should know how to do. When you run server-side code, things don't always go right. And at the moment, we assume that everything works. Like here, when we store a newsletter. When we do that, we check the request method, check that it's a post method, and if it is, we basically just validate the input. That's one case where we send back an error status code if it's not valid. But for working with the database, we just assume that everything works. And that's unrealistic. Things won't always work. Connecting to the database could fail, or even if we are connected, inserting data could fail for whatever reason, because the database servers went down temporarily just when we tried to insert data. Things can fail, no matter how unlikely that might be. So how do we deal with that then? Well, since I'm using async await here, we can use try catch to try certain operations, catch errors, and then send back a response if things go wrong. And here I actually want to work with two different try catch blocks. I want to try connecting, and if that fails, I want to send back an error. But if it succeeds, I want to try this code. So inserting, I want to try that. And if that fails, I want to send back an error, a different error, and I then also still want to close the open connection. And to do this in an elegant way, I'll work with some helper functions. For that, I'll add a new function, which I'll name connect database. The name is up to you, of course. And this function here will just hold this code for establishing a connection. So I'll put that in here and then just return the client. And I'll add another function, which I'll name insert document, where I expect to get access to the client and where I get the document that should be inserted as parameters. And inside of insert document, I then want to run this code here. So I'll copy that into insert document. And of course, in order to use await, this should be an async function, and this here should be an async function as well. Connect database. Now with that done, down here in our main handler function, I get the client by calling connect database, and then I will call insert document, pass my client as a first argument, and that document here as a second argument. Now I want to await connect database because it is a async function, so it returns a promise, and we need to wait for this connection to be established. And for the same reason, we also want to await insert document because that's also an async operation. Now with that outsourced, to make this code a bit more readable, I will wrap connecting with try and catch potential errors here. And I'll then do the same for inserting here. I'll also wrap this with try and catch errors here. Now I want to call client close if we did connect successfully, but we failed to insert. So I want to call client close inside of this try block here as well. And to make sure that client is available here, I'll set it as a variable here and set it to a value in the first try block. And if we make it past this block, client will be the connected database. So calling close will work then. And then here we got the different errors. If we fail to connect, I want to send back a response where I set the status code to 500, which indicates that something went wrong on this server, which clearly is the case here. And I'll send back an object as JSON, which has a message where I say connecting to the database failed. And if that failed, I don't want to continue with the other code. I don't want to continue with this try catch block, and I certainly don't want to send back this response eventually. Hence here I'll return then to prevent further function execution. I'll do something similar here if we fail to insert. I'll copy that code, but I'll set the message to inserting data failed. And that's how we can handle errors here. If we make it past both try catch blocks, so if we don't go into any of these catch blocks to be precise, we will still send back that success response. Now to check whether that works, we can temporarily break this connect database function by using incorrect credentials, like a username that doesn't exist. I save that and I go back to the newsletter part here. If I try to sign up with some dummy newsletter, we see that we get back an error here. In the network tab, we also see it. We see that we get back a response with a status code of 500, where the message we get is connecting to the database failed. Now, as mentioned before, we don't have any feedback on the user interface, and you might of course want to add such feedback also for the loading state and so on. I just didn't focus on this at the moment because I want to thoroughly dive into API routes. And there we can see that our error handling works. If I go back to a correct username and we try that same request again, I still get an error. Inserting data failed is what I get now. That's unintended, but good to know. Let's see what went wrong there. And the problem here is a simple error I made in this extra insert document function. I'm accepting client and document. Well, I should be using that document for inserting data instead of having my hard-coded document there as I had before, where I referenced user email, which is just not available. I should be using the document we get as a parameter. So still nice to see that this error handling also worked, but with that fixed, if we now try this again, now that's looking better. We get a success response here, and it works. So that's how we can add error handling here. Now let's also add it to the other API route. There we can do something similar. We can create separate functions for connecting and inserting, and since we would be reusing the same logic, we might want to go for some helper functions instead. We got that helpers folder anyways with some API utilities, and there we can add a dbutil.js file to set up our database utility functions. And I'll then go to the newsletter.js file and grab the connect database and insert document functions, cut them from newsletter.js, and instead add them in dbutil, and just change the insert document function such that it also takes the collection as a parameter, so that we don't always talk to the newsletter collection here, but to any collection we get as a parameter. Now we want to export both functions so that we can import them into our files. And then we can use them here in newsletter.js. There we can now import from our dbutil file by going up to the helpers, dbutil, and here I'll import connect database and insert document. And for insert document, we now just also need to pass in that collection name as a second argument, so that the email is inserted into the correct collection. And with that, we can go to the event ID file here and also import these two functions here. So from the helpers folder, we want to import from the dbutil file. And here we also want to import connect database and insert document, and then use that. Here, for example, we connect to the database. So here we want to await connect database like this to get access to the client. Now this could be failing, so just as before, I will wrap it in a try catch block, catch any error we might be getting, like that, and create client as a variable, which we then set in here. And then in here, we want to send back a response with a status code of 500 and some message in the JSON body that could be connecting to the database failed, like this, and then still return to avoid that the rest of this function executes. If we do connect successfully down here for inserting the comment, we don't want to run this code here. Instead, we want to execute insert document, pass the client to insert document, use the comments collection, and pass the new comment as a document that should be inserted, and await to get access to the result. And for that, we want to make sure that in dbutil, we actually do return that result, so that here we also grab that result and return it, like that. With that, we can insert the document and still use the result to then update the ID. Here we, by the way, also might want to use _ID to be in line with the automatically generated field, because there the field name is also _ID, as you saw in the last lectures. Now the main goal was to add error handling though, and hence I'll wrap this into a try catch block as well, catch any potential errors, return to not execute any other code if that did fail, and then send back a status code of 500 and some response data where we again could add a message of inserting comment failed. And now I just want to create result as a variable, which I actually set here to get scoping right. Now the only remaining part is where we get our data. We can also create a helper function for that, even though we only use it here, but still to have a uniform approach when it comes to working with the database. I will go to the db-util file and export another async function, get all documents, sounds like a fitting name. And here I also need the client and the collection from which I want to get all documents. And then we can take this code where we get access to the database and then fetch all entries in comments and paste that into get all documents. Now, actually, we might want to accept sort, this sort object, as an argument as well to make this function more flexible and let the caller of the function specify how documents should be sorted. Then we want to use collection here and use the sort parameter here, and ultimately, of course, return our documents like this. Now in the event ID file, we can import this newly added getAllDocuments function from the db-util file and use it down there. Here in the get case, I want to call getAllDocuments, pass in my client, pass in my collection name, which is comments, and pass in my sort object, which defines that I want to sort by ID in descending order. Then we can remove this and await getAllDocuments to get all our documents here like this and return our response. But again, we want to add error handling so we can try this and catch any errors if something goes wrong here, in which case we stop function execution with return and then return a different response where the status code is set to 500 and we pass on some message. For example, here we could say getting comments failed. Now you will be able to refactor more. For example, sending back that error response is always pretty much the same. You could also create a separate function for that, just as a side note. Now with that, we get our documents here, and I want to send back a response here if that all works. Otherwise, we send back that error response. And we then close the client. And actually, now that I moved this success response into the try block, we can remove this return statement to make sure that we do close the client if we make it past try catch here. So to make sure that we do always get rid of that connection once we're done with our operations. And actually, I want to do something similar here for inserting a comment, move this success code into the try block, and then don't return here so that we still do reach this part at the bottom eventually where we do close the connection. That's why I like this way of handling it better. I also want to close the connection here if we have invalid input, so I'll copy client close and add it in there. Because here I then want to return, I don't want to continue with code execution, hence here I want to close the client, so close the connection. And here we don't want to close the connection because here establishing the connection failed already. So here we definitely want to return. And with all of that, we can again test this, again by breaking our credentials, then go to a single event and show the comments, and fetching them fails now. And this breaks the front-end application, actually, because now we're trying to map through all comments, even though we got no comments. So we might want to add better error handling on the front end as well. For the moment, I'll just fix it by bringing back my credentials and reloading. Now this still fails. So it seems like something is wrong. Now let's see what's wrong by reloading with the network tab open. And then if I click on show comments, this request still fails. Connecting to the database failed here. Even though I fixed my credentials again. Even though I did that, it looks like calling connect database failed in my handler function here. And actually, I know what went wrong. I moved my function here, my helper functions here into the db-util file, but there I'm referring to Mongo client. We need to add that import. So we should grab that Mongo client import and remove it from the newsletter file. We don't need it there anymore. Same is true for the event ID file in the comments folder. We can get rid of it there, but we should add this import in the db-util.js file because we are using Mongo client there. That's why connecting failed. I was referring to Mongo client without having it available. So now with that, if we now reload, loading the comments works. And if I now break my credentials here and save this, if I now try to submit a new comment, this should fail, and it does. So that works. Again, no feedback on the front end. We could add it, we don't have it here. If I bring back my correct credentials and I try the same data again, this now worked. If I now hide the comments and show them again, we see that both comments are loaded as well. So that is all working here, and we now did also add error handling therefore. Now that is it for this course section. As mentioned multiple times throughout the section, you can absolutely work on the front end. You can improve the feedback, the user interface there. You can show a loading and an error state and give the user better feedback about what's happening. That's all standard React, not Next specific and definitely not API route specific. This module was about practicing API routes though, and here you learned a lot about them. You again saw that you can create static and dynamic API routes, where data is encoded in the URL, and you learned how you add your own API routes, that you can run any server-side logic you want in there, and that you can, for example, use them to connect to a real database, in this case to MongoDB. You then learned that you can send back different responses, both error and success responses, and how you can manage your code flow and the function execution with your different return statements, with the different responses, and with different if checks, for example, by checking for the request method. Being able to use API routes is very important because for a lot of websites and web applications you'll be building, you don't just want to have pages that can be pre-rendered, but you often do want certain server-side logic that should be executed on demand. For example, when a user signs up for a newsletter or leaves a comment, just as we added it here. So in the last course section, we worked on our events application, and we made sure that when we register for the newsletter, or that when we work with our comments down there, we do actually use API routes to then talk to a real database. Because in these API routes in which we worked, we now also do connect to MongoDB to store data there and to fetch data from there. Now in this course section, I want to enhance the user experience a little bit. I want to make sure that we do provide some feedback to the user regarding the current status of an ongoing HTTP request, and we'll combine this with another topic in this course section. Because in this course section, we are going to explore application-wide state management. We're going to explore how we can use React context in Next.js applications. And we are going to use React context, once we know how to do that, in order to give the user better feedback regarding the ongoing HTTP requests, simply by showing a nice little notification at the bottom of the screen controlled with React context when the request started, failed, or succeeded. Now for this course section, you should of course know what React context is. That's a prerequisite, and therefore I strongly recommend that you go through dedicated React resources, diving into React context, before you continue with this section. And with that out of the way, attached you'll find a notification component file, a zip file containing this notification.js and this notification.module.css file. These two files are attached in this zip file, and you should add them to your project into the UI folder in the components folder. That's a simple presentational component which will just output a title and a message as a notification shown at the bottom of the screen once we do show it. At the moment, we have no code for showing it, but that's about to change throughout this course section. Now, one important note first. You don't have to use React context for this course section. For giving the user some feedback about the current status of the ongoing HTTP request, you could also just use local state and provide any feedback of your choice. My goal just is to show an overlay, a little notification at the bottom of the screen, and I want to control that globally with the context API so that we can trigger this notification and control this notification from anywhere in our application. That's my only goal here. Now, therefore, before we add React context, let's see how the end result should look like. Let's go to the _app.js file in the pages folder. And there we have our layout, we have the head section with the general head data, and we got this component prop which renders the actual page content. Now in here, I also want to output the notification component. And for this, we need to import notification from the components folder there from UI and the notification.js file we just added. I'm just adding it here so that you see what we will add throughout this section. This notification component takes 3 props, a title, a message, and a status. And therefore, I'll set these three props here now. I'll set the title to test, the message to this is a test, like this, and the status to pending for a start. If we now save this, we have this notification element at the bottom. And the goal is to show this once we did click the register button, and then once the request succeeded or failed, we want to replace it with a proper error or success variant. Let me show you these variants here. If we change this to success, if we change the status to success, this switches to this success notification with a green background. And if, on the other hand, we change it to error, this switches to this red notification. So that's the notification. But of course, it shouldn't be hard-coded here. It shouldn't always show up. Instead, it should only be shown when we want it to show up, when we have an ongoing request or when we have a response from a request. And I want to control it with the context API because I want to render the notification component here in _app.js, but I want to trigger it from inside other components. For example, from inside the newsletter registration component, where we also send this HTTP request. And because that's the case, because this component should be triggered from totally different components than the component it's being rendered in, I want to use app-wide state management. I want to use the context API to avoid pointless prop drilling and long prop chains across multiple components. And therefore, let's now start using the context API. To use the context API, I'll create a new folder, which you don't have to do, but I want to store my context-related files, my application-wide state-related files in a separate folder, and I'll name the folder store, since this contains my state store for the entire application. And in store, I'll add a new file, which I'll name notification context.js. This file is also up to you, though, the file name. Now in here, we want to import from React, and we want to import the create context function, because the goal here is to create a new context for managing our notifications. Now we can provide an initialization object here, which defines the structure of this context. And the context, so this object, which will also be exposed to the different components in our application later, this context should actually have a notification property, let's say, which is null initially, but which eventually will be an object with a title, a message, and a status property, so a nested object. And besides that notification property, I also want to have a method for showing a notification, the show notification method, so a property which holds a function, which initially may be empty, so which isn't doing anything here, because we'll replace it with a different function in a different place anyways. I'm just setting up my base context here to get better autocompletion, so the data here is really just dummy data in the end. Still, I want to have a show notification function, and then let's say also a hide notification function, like this. That could be our context, and with that I'll store it in a constant, the notification context, and I'll then export this notification context here to make it available outside of this file as well, so that we can tap into this context and use this context with the use context React hook in our React components. Now, you know that the context which we create here actually allows us to create a component, a provider component which we can wrap around the components and their child components that should be able to tap into this context. And therefore, I'll actually change this to an uppercase character here, the N, to make it clear that we can get a component out of this thing here. Now, the goal will be to wrap this overall content here with our context later. So to wrap all these components with our context. However, I don't just want to provide my context like this. Instead, I want to create a separate component which also manages all the context-related state. So back in this notification context file in the store folder, I'll not just create the context here and export it. Instead, I'll also create a component in here, the notification context provider component. And this component will return notification context.provider, so this component which we can get out of this context, wrapped around props children. So here I'll wrap it around props children. And I'm doing that so that we can use the notification context provider component to wrap it around other components, which will then automatically have access to all our context. Hence, I'll also export this function. And now it's this notification context provider function, which I want to wrap around my components, which should have access to this context. And in this case, that's in the _app.js file. I want to wrap basically all that content here with my context. So here we can wrap everything with notification context provider and make sure that you import notification context provider from this notification context file in the store folder. And then wrap that around all this content, which means that all these components, which are wrapped by the provider, will be able to utilize our context later. And I'm creating this separate wrapper because this notification context provider function here will not just wrap props children. We wouldn't need it for that if that would be all it's doing. But this function should also manage all the context-related state. So here we will work with use state and so on to manage the notification state and to create the show and hide notification functions inside of this component. And that's what we'll do as a next step. So in this notification context provider component, I want to manage the state, which is then distributed through context to the various stakeholders, the various components that are interested in that state. And hence, I'll start by creating a new state. And that is the state that stores the notification that should be shown, if any. So here we can have the active notification and a set active notification function. And initially that's undefined because initially I have no active notification. But then I'll add two functions, the show notification handler function and the hide notification handler function. These are the two functions I'll add here. In the show notification handler, I want to set my active notification, and I do expect that I get information about the notification that should be shown as a parameter here. So here I'll expect to get my notification data, and then I'll set my active notification to an object where the title is notification data.title, where the message is notification data.message, and where the status is notification data.status. And since these objects are exactly equal, we can of course take a shortcut and just set the active notification to that notification data we're getting here. To get correct autocompletion, I'll then also update my show notification function up there, which we'll soon use, and expect notification data there as well. Again, we're not doing anything with it there, but this will help us with IDE autocompletion later. The actual function is defined here, and we'll connect it to the context soon. Now in hide notification handler, I want to set my active notification to null. I want to reset it and get rid of it. Now the goal is to bundle my notification data and pointers at these functions together into one object, which we can then distribute as context to the other components in the app. So I'll create a new constant here, my context, and that's our object, which now has the structure defined up here for this initial context. So here I then want to have a notification key and point at the active notification state here as a value. I'll add a show notification key, and we defined that this should hold a function. So here I will point at this show notification handler function, which is a function of the proper structure and signature. And I'll add my hide notification key and point at the hide notification handler function. So that's now my context object, and now we distribute this to all the components that are interested through the value prop on this provider component. We set that equal to context, and the cool thing is that whenever we change this state here, for example by calling show or hide notification handler in the end, this notification context provider component will re-render and will distribute the updated context object to interested components. And that's exactly what we need here. So now that the context is defined and we wrap our components here with our context provider, it's time to start using that context. Now, I mentioned that I want to show the notification here in this _app.js file. And I would actually have problems with that because that's also the file where we wrap with our notification context provider. So this component itself this MyApp component in which I use the notification is not wrapped by notification context provider, because it's this component's JSX code where we do the wrapping. Hence, we can't tap into our context here inside of this component function. But that's no problem. We can get rid of the notification here and cut it and remove its import, and instead just use the layout component, because that also is a wrapper around all our other content. And it's the perfect component for rendering a notification. Also, if we have a look at its name, layout, it is per definition a wrapper for visual content. And therefore, if I go to my layout component, I'll simply add the notification there, and then of course also add the import for the notification component from the UI folder like this. And now in the layout component, we can tap into our context. And for that, I'll import the useContext hook, which allows us to do that. We can call useContext and then pass the context to which we want to establish a connection as an argument to useContext. So to make that work, we should import the context to which we want to connect. And that's the notification context, not the notification context provider, but just the notification context, because I just want to connect to this context object here. So not the provider component, but this context object, this one, which is exported as a default. That's what I need for a use context. So in the layout component, that's what I'll import from my store folder. So for my store notification context file. So pass notification context as an argument to use context, and that gives us access to that context value. Now we can use that context to call a show or hide notification, or to get the current notification data. And that's what we need here in this layout component to conditionally show the notification. So here I'll then get access to the notification, and I'll name this active notification. So I'll store the notification managed by my context in a constant here in this component. And if that is not null, so if we have an active notification in our context, then I want to render this notification with the data stored in active notification. So we want to render notification conditionally, and we can do this as we always do it with this syntax here, and then just populate the props here with the active values from the active notification. So active notification title, and also set the message to active notification message. And for the status, I'll set this to active notification status. So now this notification component is rendered whenever we have an active notification in our store, in our context. At the moment, though, we never have an active notification because we have no place that would trigger the show notification handler by calling show notification on the context object. And that's what I want to change now. Now that all the context is set up, I want to dive into the components where we do send HTTP requests to then call show notification from inside those components to show and update that notification with the appropriate data. Now let's start with the newsletter registration. For this, we have the newsletter registration component in the input folder, and there we're sending this HTTP request. Now I want to show the pending notification whilst we are sending and waiting for the response. I want to show the success notification if sending succeeded, and I want to show the error notification if sending failed. Now to make all of that happen, in the newsletter registration component, we need to connect to context. And we do that with the useContext hook, as you learned. So here we then call useContext, and we simply import the notification context. So again, not the provider, but the context itself from our store, and there the notification context file. And then we establish this connection as we did it before a couple of minutes ago. So here we then have our notification context. But here I'm not interested in the notification. Here instead I want to call a function to show the notification. For example, here in the registration handler when we start sending this request. Right before we do send it, I want to show a notification that is in the pending status that says something like signing up. So for this, we can use the notification context object and call show notification and pass an object with the notification data. And here I'll set a title of signing up, a message of registering for newsletter, something like this, and set the status here to pending, because we are pending. Now, if we are successful, so in this last then block here, then I want to set the notification to success. So in here, I'll actually call show notification again, but then say success as a title. And as a text here, we can say successfully registered for newsletter, something like this. And the status is success instead of pending. Now, in case of an error, I also want to show the appropriate notification. And that's why I will add a catch method here, where we get a potential error. And here, I also want to show a notification, but the status will be error, the title will be error, and the message could be retrieved from the error. Here, we could check if we have a message property which we want to use, and alternatively just say something went wrong. So we show the error message if we have it, or we show this fallback if there is no message attached to the error. Now, one problem we'll have here is that the fetch function works such that error HTTP codes, so 400 and 500 status codes, will not cause this promise to fail. So we will not make it into this catch block if we have an error status code. And I would like to make it into this catch block if that's the case. So to make sure that this is how everything works, I will actually dive into this then block and check if response is okay. This is an extra field which this response object has. And if that's the case, I know that we have a success status code. Then I want to return response.json. If that's not okay though, if we make it past this if check, then I know that we have an error. In this case, I also want to get my response data, but I also want to throw an error. I want to reject that promise by throwing an error inside of the then block. And for that here, when using then catch instead of async await, we'll need a nested promise because I'll need to get access to the response object whilst getting access to the parsed data at the same time. So here I'll then call response.json as well, but I'll not return it, but instead here, in the then block, I know that we're already in the error case because we're past this if check. Here, I will then throw a new error with a message which I get from my data. Here, I'll check if I got a message in my response, which I got back from the server, and I'll use that as an error message if I have one. Otherwise, I'll set a fallback here as well. Something went wrong. And now here, I'll return this promise chain, this nested promise chain, which will throw an error if things go wrong. And this will then cause the outer promise chain, the main promise chain started by fetch, to reject as well with that error passed along so that we make it into this catch block if we do have an error. So with all that implemented, we can try if this works. If we save everything and I reload, if I sign up for my newsletter here and I click register, we see the signing up notification and it changes to success. It never disappears. We'll work on this later. For the moment, it's always there. Now let's test it with an error. And for this, I'll dive into my dbutil.js file and break my MongoDB credentials again, so that connecting to the database and inserting data will fail. If I do that and I try the same request again, we start with pending, but then we go to the error case and we see that error message at the bottom. Now, it's of course up to you if you want to show that error message here. I'm doing it and everything works the way it should work here. And with that, I'll change the credentials back to working credentials and we're good. Now, of course, it would also be good if the notification could be removed and if it would disappear eventually. Now, this notification is there and that's great, but it would be good if eventually it would disappear. And that's something which we can implement. And I want to make sure that it can be removed in two different ways. We can click it, and then it should be removed instantly. Alternatively, there should be a timer which removes it after 3 seconds if it's a success or error notification. Pending notifications should not be removed automatically, let's say. Now, to implement this, we can dive into the notification component and start with the click case, simply by adding on click and doing something when it is clicked. Now, the question is what we want to do if it's clicked. And I would say we want to call hide notification on our context. So I will just use context inside of this component. There's nothing that prevents us from doing that. Just because we show this component because of context does not mean that we can't use context in there. So I'll use the use context hook, which you should import from React. And I'll import the notification context from the store folder and there the notification context file to establish this connection here. And then here we have the notification context object, and now we can use that to hide the notification. Because in our context, there is this hide notification function, which we can call, which eventually will call this function here. Now, therefore, what we can do in the notification component is we can just bind onClick to notification CTX, so to this notification context object I'm getting from my context here, and then point at the hide notification function. Don't execute it here, so no parentheses, but instead let React execute it for you when that click occurs. That's what we do by pointing at it here. And then with that, if we save this, if I click the notification, it disappears. Shows up again, disappears. So that's working. Now it should also disappear automatically. And for this, we can go back into the notification context, and there we might want to set a timer whenever the notification starts showing up. And that is a perfect use case for a useEffect, because that allows us to listen to changes to the notification object and then act when it does change. So here I'll then import useEffect and add a new useEffect call here and add the useEffect function and the dependency array. Now in the useEffect function, I want to check if active notification is set and, important, if active notification status is equal to success, or if active notification status is equal to error. And I'll wrap that in parentheses so that the first condition must always be met and then either of the two other conditions. So if we have an active notification, then we also perform those checks to make it into this if block if we have an active notification with a status of success and error. If we have no active notification, or if the status is pending, we don't do anything. Now, if we do have this kind of notification though, then I want to set a timer that will eventually remove the notification though. So then here I'll set a timer with set timeout, which will eventually do something. And it should do that after 3 seconds roughly. And what it should do is that it should call set active notification and set this to null. Or to be precise, it should call hide notification handler. We could, of course, also call that function, but I'll just set the active notification to null here. Now I'll return that cleanup function, which useEffect accepts, to clear that timer. So that timer, which I store in this constant, if useEffect reruns before the timer went off, so that we don't have multiple ongoing timers at the same time. So here I'm utilizing this cleanup function of useEffect. All that code here is still in this if block though. If we're not making it in there, useEffect does nothing. Now, since we are relying on the active notification here, and since we want to rerun this effect whenever the active notification changes, I'll add active notification as a dependency here. And with this implemented, it should disappear automatically. If I do register, we see pending, and then success, and after 3 seconds, it disappears automatically. We also don't have any errors here, except for that 500 error from earlier. So that is working. And that is how we use this notification component with React context for app-wide state management and for giving the user some feedback about this sign-up process. Now I got a challenge for you. We also have this comments area where the user should get some feedback. And here I want you to work on that. When a new comment is added, so when we click submit here, I want you to make sure that we also show this notification with pending, error, and success. And as a bonus task, I want you to show some loading text whilst we're waiting for the comments to be loaded. So there you should not use the notification, but just some loading text whilst we're waiting for that. That's my challenge for you, a little exercise for you. In the next lecture, we're going to implement that together. Were you successful? Let's implement this together. For this, in the input folder, in the components folder, we got this new comment.js file where we have this form, and that talks to the comments.js file where we sent the request for adding a comment. And that's the part where I want to trigger my notification in basically the same way as I did it for the newsletter sign up. So therefore, what we need to do here is we need to use context by importing that from React, and then of course import the notification context from going up, store notification context, and tapping into that notification context with help of use context, so that we get our notification CTX here as well. And then I really want to do the same thing as I did for the newsletter registration. So I'll quickly copy the code from there actually. When we get started, right before we call fetch, I want to set the pending notification. So with that copied in comments.js, here in the add comment handler, right before fetch, I'll call notification context show notification, and I'll just change the text. Here I'll then say sending comment, and as a message maybe, your comment is currently being stored into a database or anything like this. And the status is pending. Now in this last then block, we know that things worked. So here, instead of console logging, I want to show another notification with a status of success, where we say success as a title, and as a text we can say your comment was saved, something like this. Now it would also again be good to have error handling, and there we can also utilize the same logic as for the newsletter registration. So this if response OK check and this nested promise for throwing an error. I'll copy that code from the newsletter registration and add that here as well. Now that means that we can now add a catch block here at the end, where we catch any potential errors thrown from inside this promise chain. And there we then want to say error. So we want to show a notification with a text of error, and then show that error message here or some fallback where we say something went wrong or anything like this. And the status, of course, should be error. And that's already it. That's the first part, and it's really the same as we did it in the newsletter registration. Of course, therefore, you could also refactor this code, look into using a custom hook, for example, things like that. But I will go with this more explicit code here, since I think that also hopefully makes it a bit easier to understand what each component does. So therefore, if we now give this a try, if I click Show Comments, let's test this. If I try to submit something invalid, I still got this front-end validation. And if I now do enter some data here, this is a test. If I click Submit, I seem to have a typo if I look at this, the way it's written. So yeah, let me fix this notification context instead of notification context. So let's get rid of that typo here. And I guess I have that typo in the newsletter too. Yes, I have. That should be the notification context here as well. And I also want to get rid of that typo in all those places. Since I had the typo there in all the places, it worked, but of course I don't want to have that typo anywhere. So I fixed it in both files so that this is notification CTX now. And with that, if we test this again, we see the pending state and the success state. And then after 3 seconds, it's removed. And if we send multiple comments, this also works. So now I added a couple of comments, and hence if we hide and show them, they are loaded again. And of course, we could also look into doing this differently so that we show an added comment right away, but that's just not the focus here. Instead, I now want to work on that loading state, because if I do show them, the comments may take a while to show up, and it would be great if we could show some loading text whilst that happens. Which means that I don't want to work with my notification context there, but really just show a little loading text in this component here. Now it's the comments.js file where we fetch comments here with useEffect, and that's where I want to manage my, well, loading state. Hence, I'll add a new local state here, because not everything has to be a global state. If a state really only affects a single component, there's no need to use a global state. And then here I'll set this to false initially, because that is my fetching comments state with the set is fetching comments updating function. And here in useEffect, if we are now showing comments, I'll set is fetching comments to true because we are now loading. And if we're done eventually here, I'll set is fetching to false. We could also add error handling here. Feel free to do this as a bonus task. I will just focus on showing a loading state for now. So now with that, we're managing this state. And we can now use this state to either show the comment list if we have our comments, or to show some loading backup text. So here I will tweak this, and I'll only show the comment list if we are in show comments mode and we're not fetching, so not is fetching comments, because else if we are in show comments mode, but we are fetching, then I want to show this loading fallback text here. That's how we could implement this. And if we do it like this, we see that if we click show comments, we see loading initially before the comments show up. And that's exactly the behavior we want here. Again, there is more you can do. You can tweak this however you want, but that was the task here. And most importantly, that was how you can use context in a Next.js application. Now that's it for this section. Now we learned how we can use React context in a Next.js application. And the simple truth is, there's nothing special to it. If you paid close attention, we just used React context as we would use it in any kind of React application. There was nothing Next.js specific. And that's the great thing. It just works. There's nothing specific we have to do, nothing we have to keep in mind. We can just get started using React context, and we can then use it to manage some application-wide state. Here I'm using the context API. We could have also used Redux in a similar way. That would have also worked. And that's the key takeaway from this section. You just use context as you're used to. In this case, we are using it to have that better user feedback when we are signing up for a newsletter or when we are submitting a comment. At this point in the course now, we learned about all the core features that make up Next.js, all the core benefits it has to offer, all the core features you need to know when you are working with Next.js in your own projects. And we did learn about all those concepts in theory with small demos and also with our events course project. In this course section, we're going to dive into yet another course project, a brand new project which we built from scratch, where we will again apply everything we learned from the ground up in one go, so in one complete project without any pauses or interruptions, and we're going to build a complete blog website. To be precise, this is what we're going to build. A blog website, which you could deploy like that, and we are going to deploy it in the next course section, by the way. And this website has a starting page with some featured blog posts. And of course, we as the owner of this blog will be able to decide which posts should be featured. We'll then have a page with all the blog posts. We can dive into an individual blog post, and there we also support features like inline images, so images inside of the article, and inline code snippets, which are rendered in a good-looking way. And we also will have a contact page with a form where visitors can contact us, and we'll use an API route to handle requests sent from that form to then store that contact data in a MongoDB database. Now, the blog posts will not be stored in that database. Instead, we'll use a language called Markdown for that to add Markdown files in a special folder of our project and write our blogs with Markdown to then render them out as HTML like we're doing it here. That is what we're going to build in this course section, a complete project, and by doing so, we will again practice all the things we learned, and we again will apply all the core features we had a look at throughout this course. Now, to get started with this complete blog, I have a brand new Next.js project where I just removed some of the initial pages, and you find this starting project attached again. It's a very simple project, not too complex, just has some starting code, some starting structure. And we're going to add our own code, our own components, our own pages, and our own styles step by step throughout this module. Now, the question is, how do we get started with this project though? And there are different ways. It's of course up to you which approach you prefer, but I personally like to get started with my pages. That gives the project a general structure, and I can then plan my other components around those pages which we need. So I'll start in this pages folder. And here for this blog, we need a couple of pages. We need the starting page, which shows the featured blog posts and our little welcome screen. We need the contact page, which shows that form users can fill out. We need the page for all the blog posts, and we need the individual blog post page. And therefore, in the pages folder, I'll start with the starting page by adding an index.js file in the pages folder. Now in there, we can create our homepage component function and export that as a default here, like this. Now I'll copy that basic code because I'll create functions in the same way in the other pages. For example, in the contact page, we also need that, and hence we can add a contact.js file here in the pages folder. Now you learned that the alternative would be to add a contact folder with an index.js file in there. It's up to you which approach you prefer. I will go for the contact.js file and just add my component in there, the contact page, like this. Then we also have our post-specific pages. And for that, I'll create a subfolder because there I'll also need a nested route with a dynamic segment. However, I'll start with a different page, a different route, and that's the all posts page. For this, we could add a posts folder and then an index.js file in there. And that page will then be loaded for requests targeting our domain /posts/nothing. So here we have the all posts page, like this. Then we have the page for a single post. So when we click on a post, the page that shows that single post, and that page is dynamic. It should have a dynamic parameter in the URL which identifies that post, something like the post ID. And therefore we could add a ID.js file with ID in square brackets because you learned that this sets up a dynamic page in Next.js, which is loaded for different requests with different IDs in the URL. And we can then extract the concrete value that was provided for a given request from inside that page. That would work, but I don't want to work with an ID here. Now, of course, the identifier name here is totally up to you, but you should name it such that it reflects which kind of value you'll extract. And I don't want an ID here, because if we had an ID, if we do that for a second, then we would load a single post for something like /posts/p1, p2, p3, and so on, if p1, p2, p3 are our IDs. And whilst this would work, it's not very human readable and also not search engine friendly. It would be better to have URLs like /posts/getting-started with Next.js if our URLs would look something like this. Now this thing here is called a slug. That's what we typically call a slug. It's also a unique identifier. We could call it a unique ID therefore, but it is called a slug, and it's basically a human readable sentence without white space, without special characters, simply with words separated by dashes. And hence here, I want to extract such a slug from my URL, and I expect that I do get these slug identifiers for the individual posts to have these human readable and search engine friendly URLs in the end. And that is then the single post page or the post detail page, however you want to call it. Now, these are the 4 main pages which this project needs. Of course, definitely feel free to add more pages. It's also your project after all, and you can enhance it however you want, but these are the 4 pages with which I want to get started in this project here. So now we added those 4 pages. It's now time to start filling them with some life, and it's of course up to you with which page you want to start. Now I'll start very classic with the starting page, with the home page here, and I'll start populating that page. And on this home page, I want to do 2 things. I want to output 2 things. The first thing that should be rendered is like a hero section. And that's just how we typically call that. It's this welcome section where we present our main product, or in the case of a blog, maybe ourselves. So that's this hero section where we present ourselves. And then the second part is the featured posts section. Now we have no posts yet, but we can still start working on that and just output some dummy content for the moment, and we'll then replace the dummy content with actual posts once we have some. So these are the 2 kinds of things I want to output here, and therefore in the component where we return JSX, I want to have 2 main sections that will be output here. Now I want to keep my page component relatively lean and not put too much markup in here. I also don't want to add a styling file for the page component. That is something you don't have to do, but something you will often see, that page components are relatively lean, focus on getting data with getStaticProps if they need to, something we will add later, and don't do too much regarding styling or HTML. Instead, we use separate React components for that, and we then just use those separate React components here. So in the homepage component, we could want to output a hero component side by side to a featured posts component. And of course, we would need to wrap this with a fragment. So with this fragment component provided by React, since we're not allowed to have adjacent JSX elements otherwise. Now, of course, such a hero and featured posts component doesn't exist yet, and hence it's now our job to create it. And therefore, I'll add a brand new components folder on the root project level, so side by side to the pages folder. And the goal of this folder is to store all the individual components that will be used in this project. And in here, I'll add a new folder, the home page folder, because I want to store the homepage specific components in there. You can, of course, name this folder however you want, though. But I'll create that homepage folder in the components folder. And inside of that homepage folder, I'll add two components, the hero component and this featured posts component. Now, both components will also need some styling. And since this is still no CSS course, and I don't want to bore you with writing CSS styles, you find styling files attached. Attached you find two CSS files, featuredposts.module.css and heromodule.css, and you should just download those two CSS files and add them in that homepage folder in the components folder side by side to these two JavaScript files, because we're going to use these styles. Now, of course, you are free to bring your own styles and tweak everything in the way you want. These are just some basic styles which we can use so that we don't have to write our own styles. Now, one important word about those styles, though, in those files, I'm using a feature called CSS variables. I'm extracting certain values like colors, but also sizes and dimensions from CSS variables. And these CSS variables are defined in the globals CSS file, which I gave you right from the start, so which was part of the starting project you found in the last lectures. And the interesting thing about CS modules is that we now have one place where we can define and manage our colors and our sizes. And when we change it here, it will affect the entire application. Now, this is totally independent from Next.js. This is a default CSS feature. I'm just using it here, and I want to make you aware of that in case you look into my CSS files and wonder what these strange things are. Now, that means that, of course, you can also easily tweak your dimensions and colors by simply changing the values in the globals CSS file. But with that out of the way, let's go to the hero.js file, and let's start working on that, and let's build that hero component. In that hero.js file, we want to build this hero component, so this welcome component on the starting page, where we present ourselves. And therefore, I'll, of course, create a functional component again and export that just as we always did it throughout this course. And now in this hero component, I want to return a section, so the standard section element. And in that section, I then want to have a couple of different elements. I want to have an image where I show myself. I want to have some text where I say, "Hi, I'm Max," and some text below that where I introduce myself and write a couple of words about what this blog is about. Now, I'll wrap the image in a div for styling purposes, and we're going to add the actual image in a second. Below that div, I then want to have a h1 tag where I say, "Hi, I'm Max," and of course, plug in your name here. And then below that, a paragraph where I say something like, "I blog about web development, especially front-end frameworks like Angular or React," something like this. Of course, feel free to fine-tune this with your own texts and later also with your own image. Now, we need some styling here, and for that we added this hero module CSS file, and therefore to apply it we should import our classes from that file. Since we are using a .module.css file, we are using CSS modules, which means that the classes defined in that file will be transformed behind the scenes such that the styles effectively are scoped to this component and don't spill over to other components, even if we use the same elements and class names there. That's a pretty nice feature, and that's why we're using it here. We have used it throughout this course already, though. Now, which classes should be applied? Well, on this section, you'd want to add a class of hero, which is simply one of the classes defined in the CSS file. On that image div, I'll add a class of image. And I don't have any classes on the h1 and paragraph elements because these will be styled with nested selectors inside of that CSS file. Okay, so now we got this. Now for the image, I want to use the next image component so that we get this automatically optimized image, which is automatically reduced in size and where different images are then loaded for different devices possibly, and which is also lazy loaded. And therefore we can import the image component from next image, and of course import should start with a lowercase I, and then we can use this image component here inside of this image div. Now this image component needs a couple of attributes, a couple of props. It needs to know its source, so a path to the image that should be loaded, a path to the base image, which is then automatically optimized and transformed by next, alt text, where I will simply say an image showing max, because I will soon add an image that shows myself, and then a width and a height. And here you should kind of calculate and estimate which width and height you will need for your image. Now, regarding the image file, you find an example image attached, which you can use. But of course, you can also bring your own image. You don't have to use the one you find attached. Attached, you, however, find a max PNG file, and you can drag and drop that into that public folder of your project, though there I will actually create a subfolder, images, and in there I'll create another subfolder, site, and I'll then drag this max PNG file into that site folder. Now I'll do that because soon I will have another folder inside of images, side by side to the site folder, with the images for the blog posts. That's why I have the separate site subfolder for images that belong to the site, but not to the blog posts. For the moment, of course, it's the only image we have though, and now we want to point at it with our image component. So therefore, source here should be a path to that image. Now you learned that the path you construct here is ignoring the fact that the image lives in the public folder, because content from the public folder is exposed on the root level of the running website in the end. So you don't need to dive into public here. You shouldn't dive into public here. Instead, this path can start on your root level and then just directly dive into images, and then into site, and then in my case point at max PNG, since that's the image file. Now, since we're using the next image component, we also should define the width and height we want here, since that is required by next image to produce the optimized images, because it will then automatically shrink the base image, which might be much bigger, to that width and height. And it will also reduce the quality and much more. And here, a width and height of roughly 300 pixels should work. We can then still override the actual size of the image with CSS, by targeting it with certain CSS rules and changing width and height. But of course, the width and height you use here should be close to the actual width and height you then render on the screen, since otherwise you just waste size. If you load a pretty big image here, and then you would use CSS code to render it with 100 pixels width and height, then you would just load a too big image, even though you don't need it. On the other hand, if you load a too small image and you then use CSS to render a large image, it would also be bad, because then you would lose quality. That's why you want to get close to the actual image you need. And the image component is pretty flexible, and in case your image can have different sizes depending on the screen size and so on, you can always dive into the next image article to learn about different ways of configuring the image. Specifically the layout prop, which also allows you to define an image which can scale up and down with the viewport, with the responsive layout. By default, the image will have a layout of intrinsic, and that will scale the image down to smaller viewports, but not up for bigger viewports. So it will not produce any bigger images than the width and height we set here. And that will make sense for this application for the way we use the image here. So long story short, with that we set up the image with a certain width and height. We got our other content, and now we want to use that hero component on the starting page. Now I am already rendering it here. Now we just need to import it. So we import hero from, and then let's go up one level, dive into components, homepage, hero, to import this component into the homepage. And I'll then get rid of the featured posts for the moment, since we haven't populated that component yet. With that, if we now run our development server with npm run dev, we can visit localhost 3000 and we should see this on the screen. This is this hero section with the styles I provided to you, with the image I provided to you, or with your own image if you brought your own image. And that's looking good, that's working. Now let's take the next steps and let's continue working on this website. So we got our hero component here, it's looking good, hopefully. And now we also need featured posts for this starting page. Now what we'll also need besides featured posts though is like a navigation bar at the top. Because at the moment we only have one working page with not too much content on it arguably, but later we will have other pages as well. The all posts page and the contact page. So therefore, to be able to reach that, we want to add some navigation. And hence that is something I'll do first before we then come back to the featured posts. I want to add a navigation bar, or to be precise, I want to add a general layout. Because the navigation bar, which should be shown at the top, will not only be needed on the home page. Instead, we will need it on all pages. And that can be solved with a layout, as you learned throughout the course. We can utilize this _app.js file here to wrap the component which is rendered there, which is actually just the page content that was loaded for the different URLs, with a general layout. That is what we can do and what we typically want to do in Next.js applications. And therefore, let's build such a layout component. For that, in the components folder, we can create a new subfolder called layout. And in there, I want to add a couple of components that help us create layouts. The first one will be the layout component itself, a layout.js file. But then I'll add two other files as well, since I want to split my layout into multiple subcomponents. For example, I want to have a separate component that holds the actual navigation bar. So I'll name this main navigation. This will be my navigation component. And that navigation component should also render some logo for my blog, and therefore I'll create a separate logo component. And of course, you can split and mix and match and compose your components just as you need to. This is just some example split which I came up with, which works for me. If it doesn't work for you, if you want to split it in a more granular way or have bigger components, so less splits, that's of course also fine. You just need to adjust the styles then. Now with that, let's start with the layout component. In there, we can again create a function and export that function layout. And in that function, we then return a fragment because I want to have two adjacent JSX elements. And the first one will be the main navigation, so this separate component, which will store in the main navigation file. The second JSX element will be the regular main HTML element in which I want to output props.children. And for this, of course, we need to make sure that we accept props here. Props children, because we will wrap this layout component around this component here in the _app.js file. We can actually already do that here. In this file, we can already import layout from, and then go up one level, dive into the components folder, into the layout folder and the layout file, and then just wrap component with layout. So create layout here and wrap it around this component. Now it's this component which will be used as children or as a child inside of the layout component, so here. So that's step number one. Now I'm using the main navigation here, and hence I also already want to import main navigation from that main navigation JavaScript file. That file, however, is completely empty right now, and that needs to change therefore. So if we go to the main navigation file here, we of course again want to create a main navigation function and then export that as a default, as we always do it. And now inside that main navigation component, I want to return a header element, and then there as a first element my logo, and side by side to that a nav bar with a list of nav items. So here I'll add an unordered list with my list items, where in the list items I have my links. Now for the links, we will not use the standard anchor tag, because that would be handled by the browser only, and when we click it, we would load a brand new page and send a brand new request. Instead, we want to use Next's link component to take advantage of automatic data prefetching, which it does for us, and to take advantage of the fact that we stay in a single page application once the page was loaded initially. So therefore, we want to import link from Next link like this, like we did it many times before in this course, and then just output link here. So create a link here. Now the link needs a ref attribute where we point at /posts, for example, and load the posts page. And it has to be /posts because of our page structure. We have the posts folder with the index.js file, which should be loaded when we want to load all posts. And you learned before in this course that this structure in the pages folder leads to a /posts route, which is inferred by Next.js. So we want a link to that route here. Now that's not the only link though. I also want to have a link to my contact page because we also have this contact.js file. And that file will be translated to a /contact route as you learned. So we also want to have a /contact route here. So now we got that. I actually also want to make the logo clickable so that when we click the logo, we're taken back to the starting page. That's a quite common pattern on websites. And therefore, we also wrap the logo with a link like this and give this a ref of just / to go back to the starting page. Now, you might remember that there was this special behavior of link when the child you passed to it was not plain text. If you pass your own component or any other HTML content to a link, link will not render an anchor tag by default. It only does that if you just pass plain text to it. If you pass anything else than plain text, the link will not render an anchor tag for you. So in order to get that, you should then bring your own anchor tag, like this. You don't need to add ref on that anchor tag. Link will do that for you. It will pass the ref set on link to the direct child of link, which is an anchor tag now. So it will do that for you, but you have to add the anchor tag element to tell link that it should render an anchor tag. This is not a bug or some inconsistency, but this feature exists to make sure that you can turn any element into a link, a div, a button, whatever you want. But here we want the anchor tag still, so I will add my own anchor tag wrapped around my logo. And speaking of the logo, that's of course still missing. I just added this dummy JSX code here, but we are not importing it, and the logo.js file is also empty. And therefore, as a next step, we'll work on that, and we're then also going to add some styling. So let's continue working on our layout, the navigation, the logo, and for that, let's add some styling. Again, for this, attached, you find a couple of CSS files. You find a logo.module.css file and a main navigation.module.css file. And you should download those and add them in your layout folder next to the logo.js and main navigation.js file. Again, there I define some CSS styles for you, which you can of course tweak and override. And in the main navigation.js file, we can now utilize these CSS files. We can import classes from main-navigation.module.css to take advantage of CSS modules and import the classes that belong to this component from the CSS file. And then we can add them. For example, on the header, we should add a class name of classes.header, which sets up the styling for this header. And that is actually the only class we have to add in the main navigation component, because all the other selectors are just nested selectors then, so to say. That then allows us to work on the logo. We can already import it, so let's add an import to of logo from the logo file, and then let's work on that logo file a little bit. Now the logo component will be a fairly trivial component, again created and exported as we always do. We will need some styles in here, so we should import classes from logo.module.css. So this CSS file we just added. And then the logo here for me is a simple text-based logo. I'll just set up a div with a text of max next blog. Of course, again, use your name here. And then I'll add a class name here of classes.logo using one of the CSS classes or the only CSS class defined in here. That will style that logo. Now we add that logo to main navigation and we use main navigation in the layout. And layout is then wrapped around our rendered component in underscore app.js. So that should be everything now. And if we now go back to our page, we should see this header here, which blends into the hero section here on purpose, where we have the logo, which is clickable and takes us to the starting page. And then our two links here, which are also clickable, but we haven't added any content for those pages yet. So at the moment, they won't do anything. But that is now the layout added and the navigation added. And with that, let's come back to the starting page and complete it by adding the featured posts below the hero section here. So let's continue working on the featured posts now that we added the navigation and so on. The goal of the featured posts component is to output some posts which we, as the owner of the blog, marked as featured. Now, we will add posts and mark them as featured in a later step, but we can already start with outputting some dummy posts here for the moment. And therefore, in featured posts, I'll again create a basic component, featured posts, and you guessed it, we will export it like we always did. Now we have a featured posts module CSS file, and we will need it, so we'll import classes from that featured posts module CSS file already. And then here in that featured posts component, I again want to create another section which will receive a class of latest, because that's one of the classes I predefined in the CSS file. Then a heading for this section where I say featured posts. And then below that, a list of posts or a grid of posts. And for this, I'll actually create a separate component. Why? Because we will then use that same list or grid as it will actually be on the all posts page. On both the starting page in the featured posts component, as well as on the all posts page, I want to output posts in the same way. I want to render a grid of post cards. So of post items. I want to render those as a grid, and these items then should be clickable and take us to the individual post. The only difference is the number of posts and the actual posts that are being rendered. But the way they are presented will always be the same. Hence, we can create a reusable component for that, and that is what I will do. In the components folder, I'll create a new subfolder, which I'll name posts, which should hold all the post-specific components. And we could argue that featured posts is also a post-specific component, but it's even more specific to the homepage because we only use it there, which is why I keep it in the homepage folder. Now in that posts folder, I'll add a posts-grid component file though, which will then render this grid of posts. And now for that posts grid, you already find a posts grid module CSS file attached, which we will need in a second. So you can download that and add it in the PostScript JavaScript file. Now you also find attached a post item module CSS file, and you can download and add that as well, also in the posts folder, because we will also create a post item JS file next to that, which will hold a single post item. The post grid will render a couple of post items, and I'll split the grid and the actual items into separate components to keep every component lean and maintainable. Let's start working on the post grid component though. In that post grid file, I'll add a function, posts grid, which is my default component function, which as always is then just exported. Of course, by the way, you could create a snippet for this in Visual Studio Code to save some time. But here I'll just write it manually all the time. And then in the posts grid component, we want to return the JSX code. That should be output here. Now, the JSX code is again very simple here. It will be an unordered list of post items. Now, the data for those posts should be received from outside though. I do expect that I get props here, and in my props, I want to get a special posts prop. Now, of course, the prop name is up to you since it's your component. You just need to make sure that you then later use that prop name for passing data into this component. So then I want to output my posts dynamically here by mapping every post into a post item. And we have yet to add this component. But that's my goal here. I want to output a list of posts where I map my post data into post item components. That's the goal here. Now we will need to import post item for that from the post item file we just added. And this file is empty right now, but we will work on that soon. And we'll also need some styling, so I will import classes from ./postgrid.module.css. And that is that PostGrid CSS file for this component, which has a class which should be added to the unordered list. There, I want to add the grid class, which is defined in PostGrid. And there we use the CSS grid feature to render some grid columns. Okay, so that's that. Now let's work on the post item, component, which outputs an individual item in that grid of posts. In this post item component, or in this file, we again create our component function, and as always, export that, of course. And then we define the structure, the markup of a single post item. And for me, a post item will be a list item, which should make sense because we're in an unordered list. So having a list item is a good choice typically. And then the entire item should be clickable. Therefore, I'll import link from next link, because of course I want to use this link to still stay in the single page application, use prefetching and all those things. And I'll then add a link here with an anchor tag inside, since I'll have a more complex HTML structure in that link. And as mentioned a couple of minutes ago, you then need to bring your own anchor tag to tell link that it should still render a anchor tag. And then regarding that more complex structure in here, I want to have a div which will hold a post image, which is at the top of this post card. And below that, another div which will hold the content, the title, the date, and a short excerpt which we want to show. Now inside that first div, I therefore output my image, and we will soon add the source and everything else. And in the second div here, there I'll add a h3 tag with the title of the post, then a time element which outputs the time, something like July 13th, 2022, something like that will be output here, and then a paragraph with the excerpt text of that post. And of course, at the moment, it's just dummy data. Soon it will be actual data. Now, before we continue on the data, let's continue with the styling actually. For this, I will again import classes from that post-item.module CSS file, which I provided to you in the last lecture. And then we add a class to the list item, the post class. We also add a class to the div which wraps the image. It's the image class. And we add a class to this div which wraps the content. It's the content class. Now let's work on the data. The data for a single post item, of course, is not hard-coded in the post item. We will also not fetch it from inside the post item with useEffect and fetch or anything like that. Instead, I expect that I get it through props. So that in the posts grid component, where we render the post items and where we have a list of posts, which probably is a list of JavaScript objects with the post data, where we then just forward that data we have here already into the post item through props. That's the goal. So in post item, we can expect a couple of props. And I will use object destructuring to pull those properties into separate constants. Now it is your component. It is up to you how you expect to get data, how you expect to pass data to this component. If you want to have one prop which carries the entire post data or multiple props. And I will go for one prop here, a post prop on props, and I'll destructure that. So I expect that I get a post prop, and that post prop holds a JavaScript object with multiple properties which describe the post. And I'm now pulling out those properties into separate constants with object destructuring here. And we could, for example, expect a title, an image, an excerpt, which is a short summary text basically for the post, the date, and also the slug of that post. So the path to the post, so to say, the unique identifier of the post. And that's the data with which we can work down there. For example, for the title, we can now output the title, which we extract here. Now for the date, we can also output this, but I want to format it first, make it more human readable. Because the date which we get here as a prop will be in a more machine readable format. Also human readable, but not nicely formatted. And I want to make sure that it is nicely formatted. Hence here, I will actually create a formatted date constant where I create a new date object and pass my date prop to it so that a new date JavaScript object is constructed based on that date value which I receive here. And hence, of course, we have to make sure that date holds a value which can be used with this constructor function. and we will make sure that this is the case. And then on that date object, we can call toLocaleDateString and pass enus as a first argument and a configuration object as a second argument to output a human readable date. And here I'll set day to numeric, I'll set month to long, so that if it's January, we don't output 0, 1 or just 1, but instead January as a text, and then year to numeric as well. Okay, so now we got that formatted date, and it's now this formatted date which I want to use down here. So here we output the formatted date. Now for the exert, we want to output the, well, exert, which we're getting as a prop. So output exert here, this exert. And now for the image. The image needs a source property. It needs an alt text. And then we need to specify the width and the height. Now let's start with alt. The alt text could just be our title here. So I'll just use title. Now for width and height, I also prepared some values which should work. And that's 300 and 200 pixels roughly. That should produce good looking images. We will also sometimes have images which are a bit wider than 300, because here the image will actually scale in size as defined in CSS. The CSS code is such that the image will differ in size, but still will always produce good looking images with these settings. And it always will be a bit of tweaking and trial and error to find good settings here to get images which are as small as possible and still look good. But I'll come back to the image later, because we will also need to add the layout property here later. But for the moment, let's keep it like this so that we then also see why we will need to add it. For the moment, let's focus on the source instead. What is the source? Well, we get an image here, but the image which we get will actually just be the image file name. So we need to construct a full image path first, because the file name is not enough. And I'll do this with a template literal, so with backticks. And we will start with a hard-coded string of /images/posts. Now that's important. At the moment, in the public images folder, we have no posts folder. I'll change this now and I'll add one. This folder is empty right now, but it will very soon contain some images. So it's this folder which will hold images for individual posts. And that's therefore the start of this image path. Then I want to have a subfolder in that posts folder for every post which we add, and that subfolder should have the unique identifier of that post as a name, so that's slug. Hence the next segment here is the slug. We'll dive into a subfolder of that slug, so with that slug as a name in that images posts folder. And then in there we look for the actual image file, like this. That's my image path, and therefore now that is what I'll set here as a source. Okay, so that is now this post item component here. For image to work, we, however, still need to import this image component from next image. But now we got this set up. Now we can connect this to our posts grid and then start adding some dummy data so that we do see some output. So let's now start wiring up our post item to the post grid, and let's add some dummy data. To wire it up, keep in mind that in the posts grid we get posts through props, and that will probably be an array full of objects that describe a post. So the assumption is that an individual post in that list has all the data post item needs. We can make that assumption because we are writing that code, so we'll just have to make sure that this is the case later. Now post item, this component, wants a post prop. Hence now in posts grid, we can add that post prop here and pass the post which we get here in this map method into post item through that post prop. Now we expose that data to post item. Now since we map, we should also add the key prop that's required by React.js to efficiently render and update that list. And we can set this to some unique identifier, and every post will have a slug property, which is the unique identifier of a given post, and therefore that is what we can use here. Now we got that, now we need some dummy data. For this, let's first of all go to featured posts in the homepage folder, because that is where we now want to use that posts grid. So in here, we want to output posts grid. And for this, you should make sure that you add the import to posts grid to that component. And now there, we need to set the posts prop on PostGrid. We need to set that because in the PostGrid component, we are extracting that posts prop here. So we want to set this, and in featured posts, I actually also expect that I get my posts data through props. Now that's a long chain of props, and we could therefore, of course, also kind of consider using context or Redux to avoid this prop drilling. But here I'm actually fine with it because it is a chain that makes a lot of sense. And PostGrid, for example, shouldn't be tied to one specific context anyways, because we will reuse that component in different places. So that should definitely receive its data through props instead of context. And hence I'll leave it like this. Therefore, in featured posts, I'll set the posts prop on PostGrid to props.posts. And yeah, that's a lot of posts, but that is what this application is about in the end. So now featured posts also has a posts prop that needs to be populated. And let's therefore now finally go to the place where the prop chain will end, and that is the index.js file in the pages folder. Here below hero, I want to output my featured posts, and therefore you need to make sure that you do add that import to import the featured posts component. And here we now set our posts prop. Now later, we will get posts with get static props when we have actual posts which we load. For the moment, we don't have that. For the moment, to just see something, I'll add a dummy posts array here, which I'll set as a value for the posts prop, and will then replace that later. Now, dummy posts will be an array full of dummy post data, so full of dummy post objects. And now every post object here should in the end have these properties, because that's what we rely on later. We want to have a title, image, excerpt, date, and slug. Hence here in index.js, we want to add that. We want to add a slug, a title, an image, an excerpt, and our date. So all those properties we are relying on here in post item. 5 props there, 5 properties here. Now, since it's dummy data, we can come up with any slug and any values in general we want. The slug should be a text with the words separated by dashes and no special characters. So here I'll have like a slug of getting started with Next.js, and then I'll add a title of getting started with Next.js. So that could be a blog post title. Then an image, which I'll name getting started Next.js, just like this. And then also .png. I will soon provide this file to you so that we have this image. Then add an excerpt where I say something like Next.js is the React framework for production. It makes building full stack React apps and sites a breeze and ships with built-in server-side rendering. Now you can come up with any text you want. It just shouldn't be too long because it's just a short preview text in the end. And then we'll add a date, which should be in the format of year-month-day. That will be a date which then later can be parsed and used by the date constructor. So that's some dummy data, and I'll add more than one post here. I'll repeat this 4 times, and I'll just edit the slug slightly. So getting started with Next.js 2 and 3 and 4, so that this is unique. And all the other data is duplicated for the moment, just because I don't want to waste time setting up dummy data here. We'll just need this to see if our grid works correctly. So that is what it is. That is the dummy posts I want to work with, and that's the dummy posts passed to featured posts. Now, in order to see anything on the screen, we now need that image, which we are relying on. And I do provide a dummy image for you. You can use that image, which you find attached, the getting started Next.js PNG file. You can download that and add it in your public images posts folder. There add this getting started Next.js PNG file, which is a little dummy file I created for you. Of course, you can also add your own files. And now double check that the value you set up for the image property here in the dummy posts data is equal to that image file name you just added, that you have no typo here. With that, we should have everything we need. If we now save that, I get an error if I reload because I forgot to set the ref property. Makes sense. In a post item, I'm wrapping the entire post in the end with a link, but I'm not linking anywhere. I forgot to set my ref. And of course, we want to set ref here. Now, what should be the link or the path this link leads to, though? It should in the end be the individual page for this selected post. So we want to load this slug page here in the end for that concrete post slug. Hence here, we want to derive that path dynamically, and I'll do that by adding a separate constant, link path, which again is a template literal, where we start with /posts, because that slug file is in the posts folder in the pages folder, and then slash, and then some dynamic value. Here we want to use the slug then, because that slug, that unique human and search engine friendly text, that should be part of the URL. And then it's this link path which we use here. So that is something we have to add. And once we do add this, we do render featured posts. Now the cards are showing up, the image is not though. And that makes sense if we take another look at post item and the image path we're constructing here. I point at images, posts, and then the slug of the post as an extra subfolder, and then the image file name. Now I have the image directly in the posts folder, so that extra slug folder in between is missing. We should add it. We should go back to index.js, and then add our slugs here, which we have in the dummy data as subfolders in posts. So I'll add a subfolder with a slug of getting started with next.js, and I'll drag the image in there. And I'll repeat that for my other dummy posts. Of course, it's always the same image, but still, to be able to render this, I'll add more subfolders in the posts folder. So not inside of the other slug folder, but in the post folder. There I will add more subfolders with those different slug names as folder names, because that is required to find the image correctly. And then we can drag and drop the image by copying it into those other slug subfolders, so that we have the same image 4 times in those different subfolders for those different slugs. Now the image should be fetched correctly. If we save this again and load localhost 3000, we see it. Now what we also see is that here on this big screen, it's a little bit too small. If I open up the DevTools and I resize this, you see it doesn't really fit my card that nicely. It doesn't really fit in there, and that's not the behavior I want. To fix this, we can go back to the post item where we render that image and add the special layout prop. Now I mentioned that we have a couple of values we can set there, and the default is intrinsic, which means the width and height we specify here is the width and height which is being used. Now we want to set this to responsive instead. By setting this, it will fill out the entire surrounding container, this div in this case, which has certain CSS styles that control its width and height, and then it will shrink and grow together with that container. So if we set layout to responsive, now it looks much better. Now we take the full available space as we move this around. Now, of course, it's up to you how exactly that should be styled. I just have some basic starting styles here. You can, of course, fine-tune this to change the size and fine-tune it to your exact requirements. I have some basic styling here, though, and as you see now, that doesn't look too bad. It is growing and shrinking, and we take advantage of this automatically optimized image. So with that, we have our featured posts being rendered here, and therefore the starting page of our blog is finished with that dummy data, but better than nothing. Now we can move on to the other pages and work on those. And I will move on to the posts page now, where I want to render all my posts. So let's continue working on that index.js file in the posts folder on the all posts page. Here the goal is simple. I want to output all my posts. So later, once we don't just have dummy posts, but an actual data source, we will fetch all posts for this page and then output them in some way here. Now for the actual JSX code, for the detailed HTML structure, I'll again create a separate component to keep my page component lean and focused on data fetching. And therefore in the posts folder, in the components folder, I'll add an allposts.js file. Now attached, you also find our allposts.module.css file, which you should download and add next to that allposts.js file. And then in this allposts.js file, we define our allposts functional component, as we always do, like this. And we can also already import the CSS styles. So import classes from all-posts.module.css. and then work on the JSX code that should be returned here. And I'll keep this all posts page fairly simple. I'll just add a section which gets some styling with classes.posts. And then I'll add a h1 tag for the main title of this page, where I just say all posts. And then I'll again use the posts grid. So we will reuse this component. And therefore, of course, you also need to add this import. Now, I do expect that I get posts through props here from the page, because the page component should be responsible for fetching and preparing the data. And hence, on posts grid, we need to set that posts prop, and I'll just point at props.posts for this. And that is already it. It is a real simple component in the end. Now back on the posts page, on the all posts page, I therefore now want to return the all posts component we just worked on. And for this, of course, also add that import. And now here we again need to prepare the posts that should be used. For the moment, we can again use the dummy posts. So copy that dummy posts array from the starting page, but soon we will add a real data source. For the moment, it's this though. So that's our dummy posts. And then here in all posts, I'll just pass in posts and point at my dummy posts. And then with that done, if we save this and click on posts here, we're taken to that page. We got the navigation bar there as well, because we wrapped the layout around all pages, and we got our post grid here. So that is working just as it should, and that's the all posts page finished. Now we got 2 pages left. We got the page for an individual post if we click on it, and we got this contact page. Now we could start with either of the two, but I would say let's start with the post detail page, so that when we click on a post, we load a page and we display the actual post content here. Because that will then also get us closer to setting up an actual data source and to setting up actual posts, which we can then fetch and pre-render and so on. So that's therefore what we'll do next. So let's continue with that post detail page now, with this slug page, which we load for a given slug. On this page, I in the end want to output the content of a selected post. So that includes a header with the title and maybe the image again, but then below that, the actual text that makes up a post. Of course, we don't have any text yet. We only have those excerpts, but in the actual post data, which we'll add in the next lectures, we will also have a rich content for every post with headings and then images and maybe code snippets, and of course, a lot of just plain text. Hence, in this Slug.js file, in this component, I again want to return another component which will actually take care about outputting that post content. And I'll do that here in the posts folder, in the components folder. I'll add a subfolder named post detail to make it clear that in there we have the components for a single post. And in there, I'll add a post-content.js file. I will also already add a post header.js file, which will be responsible for outputting the main header data, like the main title and the image of that selected post. Now for that, we'll also need some styles, and as always, you find those attached. Attached, you do find a post content module CSS and a post header module CSS file, and you can just download them and add them in your post detail folder. Now let's start with the post content.js file. This will become a quite complex file over time, but we will start simple. We'll again start by creating our component function and exporting that as a default, as we always do. And then in here, we want to return some markup, some JSX code that renders a post. Now later, we will actually get the post content as markdown, which is text with extra annotations. You'll see it in a couple of minutes. And we'll then translate that markdown to React JSX elements. That is something we'll do later. For the moment, I'll start by adding an article element here, a standard article element, and then rendering a post header here as a first element, and then below that, the actual content. And that is what will then later translate from markdown to actual JSX code. Now let's start with the post header though, with that post header component, for which we have this separate post header.js file. In there, again, we create our component function as we always did, And we export post header here. And then here we can return a header element, let's say, with a h1 element with the title of the post. And I do expect that I get data like the title from props. So here I do expect that I can pull data out of my props and that I get the title here and actually also the image. So then here I just output the title like that. And then below that, I want to render an image, and I'll again do that with the image component, which we therefore import from next image. So we import that component and render it just like that below the h1 tag. Actually, because of the styling, which we'll add soon, it will be rendered next to the h1 tag. So now we got that. Now the source of the image element here should be the image we're getting as an argument, and here I will expect that image is the full path to the image already. So I'll just set source equal to image, set alt equal to the title, and then we need values for width and height, and here a width of 200 and a height of 150 should work quite well. Now we will need some styles, so I'll import classes from /post-header.module.css, this CSS file which I provided to you, and with that on the header we can add a class name of header, like that. Now that is the post header component which we use in post content. Hence we need to set the title and the image here. Now speaking of that, our post content will need some content to work. And we'll soon get that content from a real data source. Since we don't have that data source yet, I'll create a dummy post here, and we will just assume that we loaded that post. So I'll create a dummy post here, which is a JavaScript object, which will contain some dummy data, like for example a slug. And here I want to use one of the slugs I used before. Actually, I'll grab one of my dummy posts here, so a single dummy post. I'll grab that post and use that now as a dummy post in post content. Here, like this. I will get rid of the exert though, we don't need that here, but instead I will add a content field which will contain the actual post content. And in here I will write Markdown code. Now in case you're not familiar with Markdown, you can of course Google it, look it up, and you'll see that there also is a cheat sheet. Markdown in the end is plain text with extra annotations. Markdown looks like this. You write text and you can, for example, add a hash symbol in front of it to turn it into a title. You can also create lists with dashes or with numbers to have ordered lists. You can add links by putting text in square brackets and adding the link destination in parentheses thereafter, things like that. If you ever worked with GitHub and you added a README for a GitHub repository, you wrote that in Markdown. And we use Markdown here because it's less code than if we would use HTML, and it can be translated into HTML or into JSX even with third-party packages which we'll add. So here I'll add a simple Markdown text of this is a first post. And the interesting thing is that this is plain text with this extra hash annotation, turning this into a title in Markdown's world. And the goal is now to translate this string from Markdown into JSX, which we'll do in the next lecture. Before we do that, let's set the title and image of the post header though. For this, here in post content, I will create an image path here, and again set up a template literal, where we dive into /images/posts, then use the slug, so dummypost.slug, and then use the actual image name, so inject dummypost.image. And it's this image path which I set as a value for the image prop on my post header, like this. And for the title, we can also set this dynamically to dummypost.title. Now for the content, we don't want to do dummypost.content because if we would see that content, but we would just output it as plain text, not translated from Markdown to JSX. And therefore, that's not what we want. Still, to get started, let's start with this. And let's then go to the slug.js file in the pages post folder and output post content here. And later, we'll pass in the data for the post content from inside this page. For the moment, I'll just render it like this, and I'll import post content from the proper path, therefore. And if we do all that, if you reload a single post, you see post header is not defined because in post content, I'm using post header, but I'm not importing it. That's something we should change. I'll import post header from /post header. add that import in the post content file, and now we see this. This is not the final look I want though. I want some extra styling, and for that I did add that post content module CSS file. So I will also import classes from there and import classes from post-content.module.css. And then on this article here, set a class name of classes.content. If we save that now, that looks better. But here we see that we have this untransformed raw text. And therefore, let's now become a bit more advanced by adding functionality to translate plain markdown text into renderable JSX code. So it's time to convert that markdown. And for that, we'll install a third-party package. So I'll quit my development server and npm install a new package which will help us with that. And that package is the React-Markdown package. This package takes Markdown and outputs it as JSX. So we need to install that package. And once that's done, we can restart the development server. And in the post-content.js file, import React Markdown with a capital R at the beginning, because this will act as a component from React Markdown. So we import the React Markdown component from that React Markdown package we just installed. Now, if we go down here, what we can do is, instead of outputting our content like this, we output React Markdown, this component here, and between the opening and closing tags, we pass our content, just like this. If we do that, you'll notice something interesting. If we reload, this now changed its style, the hash is gone, and if we inspect this, it's rendered as a h1 tag. So it was translated to a title. So this Markdown to JSX translation works simply by adding this component, which is of course awesome and really makes our life easier. Now we're going to come back to this component later when it comes to rendering inline images, so images as part of our posts, and when it comes to rendering code snippets, because there we'll then tweak it a little bit. But for the moment, it just works. And therefore, as a next step, before we tweak this anymore and before we dive deeper into that, let's now replace all that dummy content with some actual content. Because we got all the building blocks now, we got the core pages, we understand that we plan to use Markdown, and therefore we're now ready to take the next step, add a real data source, then load data from that source, and then render that data. So it's time to move away from those dummy posts. That of course brings up one question. Where do we want to store our actual posts? And one pretty obvious choice would be a database. Something like Firebase or MongoDB or a SQL database. And there is nothing wrong with that. We could do that. But for a blog like this, which is owned by us, where we write those blog posts, there also is another very nice solution. We could use our file system as a data source. Because we don't need to write to our blog posts. I mean, we have to write them at some point, but then once they're done, they are a data source from which we only fetch data. We only use them to load blog posts. Users on the website can't interact with them to change them. So once they exist, we might occasionally update, but whenever we do that, we as an owner dive directly into those blog posts, but the files themselves are then only fetched by our application. So if we use our local file system here, our project folder, we don't have to set up an extra database and pay for it. We don't have to do all that wire up work. And that can be pretty nice. And therefore, a quite common approach is to add a new folder in your project folder, which could be named content. But that name is totally up to you. It doesn't have to be named content. And in there, we could have a subfolder named posts if we would have different kinds of content. Or if we don't have that, we get rid of that folder. And instead of a content posts folder, we just directly add a posts folder in the project. Now, the idea is that in that posts folder, we store our posts. And what do I mean with store our posts? Well, keep in mind that we will write our posts with Markdown, so with that Markdown syntax. Hence, I'll add a new file in there, let's say the getting-started-with-next.js.md file. MD stands for Markdown. So this is a Markdown file which I added here. And in there, we can write Markdown code. You can also install extra extensions that help you with writing Markdown code. In Visual Studio Code, if you search for Markdown, there you can install extra support, but I don't even have that. I'm happy to write it like this. Now in here, we can write that Markdown code like this is a title, this is some regular text with a link. That is something we could write here as content. However, if you take a closer look at our pages and our different components, you might see that just content is not enough. We also rely on an excerpt and a date and a title and an image for outputting all our posts. So we need to add metadata to our posts. And the great thing about Markdown is that you can easily combine it with a concept called gray matter, which is just metadata you add to your Markdown file. You add that by adding 3 dashes, opening and closing, so to say, above your content. So here we have 3 dashes, and between those 3 dash separators, we can add our metadata for this Markdown file as key value pairs, basically, in YAML format, to be precise. And you can look up YAML format to see what's allowed in here. For example, we can set a title here to "This is the post title," or in this case, probably "Getting started with Next.js." We can add a date, which could be 2022-10-15. And we can also wrap that in quotes to make it clear that that's a string. It's technically not always required, but can be required sometimes if YAML is not able to find out which data type it is otherwise. Here you could also add an author if you need that. I don't have it in this blog, since it's only my blog and I'm the only author of all those posts, but you could add an author field here as well, and then fetch and render that later. Now what we'll need is an image though. We will definitely need that. And here I'll just have my getting-started next.js.png image file here. So this image file, which I added in the images posts folder before. And as a side note, to connect everything correctly and use the already existing structure in the public images folder, you should make sure that your posts Markdown file has a file name that matches one of the folder names in that posts folder in the images folder, because we'll then later connect all that data such that we fetch the image we specify here from an equally named folder in the public images posts folder. So you should make sure that this is equal. Then here, we can also add an excerpt, and I'll just quickly grab my dummy excerpt here, which I wrote down before from the index.js file, and add that as an excerpt here. I didn't add a line break here, that's just my IDE, which is kind of showing a line break. It's one long inline text. And I will now also add a isFeatured key here and set this to true. So Boolean values are also allowed here. We will then later use that for selecting just the featured posts for the starting page. So that's now extra metadata, and that's the actual post content. And we can write files like this, and we can also fetch data from such files and split it in metadata and content. All of that is possible with ease. And therefore that will be our data source here. So now with that, I'll save that Markdown file. And I will now also get rid of the other dummy post folders in the images folder and just keep one of those folders around for that Markdown file we just added. And now the goal is to kind of use our posts folder as a data source to generate all required single post files based on the number of post files in the posts folder, to load the featured posts from there, so to go through all the posts and select the featured posts for the starting page, and to load all the posts for the all posts page. And that's what we're going to do in the next lecture. So now we want to use our Markdown files in the posts folder as a data source. For example, for the starting page here, instead of using dummy posts, we want to fetch our posts from that post folder. For example, with help of getStaticProps. Now, before we do that, I'll first of all create a new folder in the project though, a lib folder, or helpers folder, whatever you want to call it. And in there, I'll add a posts-util.js file. This simply is a file which will have extra utility functionality for fetching my post data and for extracting metadata from those Markdown files. And speaking of that, for this we need to install another extra package. So quit your running development server and install an extra package with npm install and that would be the gray-matter package. That's a package which allows us to read a markdown file and split it into metadata and the actual markdown content. Once that's installed, we can start the development server again. And now in posts-util.js, I want to add a couple of functions that fetch us all posts, all featured posts, and then also a single post. Now let's maybe start with all posts. Let's add a getAllPosts function here. The idea here is that we take a look at this posts folder with the markdown files and simply check how many markdown files we have there, and then go through all those markdown files to get the metadata for all those files. Now for going through all those files here, I will work with the file system, and hence we should import fs from fs. So import this fs node module. And then here in getAllPosts, I'll start by reading all the content from a directory with the fs module and the readDir_sync method. readDir_sync will read all the content synchronously, so in a blocking way, which is fine here because I want to parse all posts anyways before I do anything else. So I'll read the entire content of a directory in one go here. Now we need to pass a path to the directory to readDir_sync, and I'll create this as a separate constant outside of all those functions here. I'll name it posts directory, though of course the name is up to you. And then here I'll import another thing from Node.js. I'll import the path module here. This allows me to construct an absolute path with the join method. And here I join process.currentWorking_directory, executed as a method, which will point at the overall project folder, as you learned, not at this lib folder, but at the overall project folder. So that is then an absolute path to the overall project folder. And then I'll add posts as an extra folder into which it should dive. So this posts folder here. That's then an absolute path to my posts directory, and that's the directory I want to read. So that's what I pass to readDir_sync. Now this will return an array of strings, as you see. In the end, it will be an array of file names. So here I have my post files, which I load with readDir_sync. As a next step, I now want to go through all those post files and dive into them to extract metadata and markdown content. I also want to derive a slug, which can be put in the URL from the file name. So basically, I want to use the file name without the extension, which still is part inside of post files at the moment. Now for this, I'll add an extra helper function, getPostData, sounds like a fitting name, and here I expect to get the file name as an argument. Now in getPostData, we want to read the content of a file. We can again do that with the fs module, and there we have that readFileSync method for reading the content of a file. Here we need the file name, but not just the file name, we still need the full path to that file. So I'll construct my file path here by again using path.join, and I'll join this posts directory path, which we already have, with that file name. So that constructs a full absolute path to that concrete file. Now we can use this file path for reading the content of that file. We can also add a second argument here and make it clear that the file encoding is UTF-8, so that we support all those Unicode characters. Then we got the file content here. That's what readFileSync produces. Now we're doing this for a single file here, so I'm not doing this in a loop or anything like this. I'm just doing this for one file. We're going to call getPostData in a loop for all files later though. But here we then have the content of a single file, and now we know that in a single file we have this metadata and the actual content. Now the overall content is what Node.js extracted for us. To split it up, we'll use this gray_matter package, which we installed. So for this, I'll import matter from gray-matter, like this. And matter is simply a function which we can call here, to which we pass a string. And our file content is just a string. It's the content of a file as text. So we pass the file content to matter, and matter will then return an object with two properties. With a data property for the metadata, so a data property which contains the metadata as a JavaScript object, and a content property which contains the actual content, the markdown text, as a string. So we can use object destructuring to pull these two properties out of the returned object and store them in separate constants, data and content. And these names are not up to you. These are the properties in that object created by matter, so by this matter function. Now that we got that, we can prepare our own post data object, which should contain all that metadata and that content, but also contain an extra slug field with the slug, so with the file name without the file extension. For this, I'll first of all create my post slug here, and we can easily create this by using our file name and simply replacing the file extension with nothing. We could use a regular expression here to select the markdown extension with this regular expression and replace it with an empty string. So this removes the file extension in the end. That leaves us with a slug, which is just the file name without the extension. And therefore, of course, you should make sure that your file names do have this slug format and do not contain any special characters or whitespace. And once that's done, we can prepare that post data which we return. Here, I want to add a slug field and store my created post slug. I will then also spread my data in there. So the data we extracted from the markdown file, and I'll add a content field and point at the content extracted from markdown. And of course, here we can use the shortcut. So that's now an object containing the data for a single post read from that markdown file. And that's what I want to return here in getPostData. Okay, so now we have that getPostData function. We have getAllPosts where we get all those files. Now we want to call getPostData for every post we got here in getAllPosts. So there we can, of course, just create a for loop to go through all the post files we have here, like this, for example. And for every file, we want to call getPostData and pass the post file, so the file name in the end, to getPostData. And since in there we use readFileSync, we will block the further loop execution until we parse that data. And that will be super fast, no worries. So that will not take long. It will be milliseconds. So then here we get our post data, like this, for a given post. And overall, we now want to create an array of post data pieces, so an array of such post objects. And therefore, we can actually also change this a little bit. In the end, what we want to do is we want to map our array of post files into an array of post data objects. So we could also just use post files and call map to execute some logic on every post file, and in the end, just return getPostData for the given post file. So then we would map our array of file names into an array of objects with the actual data for those different posts. And I think that makes more sense. Now map returns a new array. It does not change the existing array, so I will create a new allPosts array, which is an array full of post data. Now maybe we also want to sort that so that we have the latest posts first, and hence I'll call allPostsSort here to sort my posts. And I'll add my own sorting function here where we get post A and post B. And in the end, we want to now check if post A.date is greater than post B.date. And if that's the case, return -1, otherwise return 1. That's the default JavaScript sort method, which will make sure that posts with a greater date, so more recent posts, are actually sorted in front of older posts. That also returns a new array, the sorted posts array, and that's now what I'll return here inside of this getAllPosts function. Now that was a lot of work, but I hopefully could make it clear what happens. But with that, we have the getAllPosts function, which reads all the posts in the posts folder, no matter if that's one or multiple posts, and then gets all the data for those posts and also sorts them and then returns them. Now to finish up the work on this file, I now just want to add one other function, which is responsible for getting all the featured posts. So I'll name it getFeaturedPosts. And here, I'll first of all get all posts again by calling getAllPosts. So that's simple. And then I'll just find out what my featured posts are by taking all posts and filtering them by calling filter on them. So here I'll then look at every single post and simply check if post is featured, if that's true. If it's true, we'll keep it. If it's false, we'll drop it. So featured posts then only contains the posts where isFeatured is set to true. And then I'll return this here. That means that we still go through all posts first, but we'll have to do it anyways. We'll have to look into every file anyways to find out whether it's featured or not. If you don't want to do that, you would have to keep an extra data source around, something like a JSON file, which holds the slugs of all the featured posts, and then you would just read those and then just pull the specific markdown files which this extra JSON file points at. That could be an alternative for a bigger blog with hundreds or thousands of posts to increase the build performance a little bit, but for this blog, this approach is absolutely fine. So now we got all of this, and now as a last step, I'll export the get featured posts and the get all posts functions because we will need those to fetch that data. Now that we got the get all posts and get featured posts functions, let's use them. For example, on the starting page, so that there we can get rid of that dummy posts array, and instead we load posts from our own data source. And when it comes to fetching data for a page, we also learned how that works. We want to use get static props or get server-side props. In reality, of course, we don't need either of the two. We could also use effect inside of our component and send a HTTP request to some API. But that means that the pre-rendered page won't contain any content, which isn't great for search engines. And in this specific website here, we would also have a problem. We have no API. Our posts are fetched from the file system, and we can therefore do that in any code that runs on the server side and has access to that file system, but we can't do it from inside our components. Those don't have access to the file system, and there we also can't send a request to any API that grants that access because we have no such API here. We could build an API route, but why would we do that? Then we would be able to fetch data without having it pre-rendered, and we would still have the search engine disadvantage. Therefore, it definitely makes most sense here to add the separate get static props function here. In here, we want to get all the featured posts, and that's super simple because in that lib folder in which we just worked, in that file there, we export a get featured posts function, which does just that. So here in get static props, we can get our featured posts by calling get featured posts. And you just need to make sure that you add an import, importing get featured posts from that lib folder and the posts util file. If you do that, you got the featured posts here, and then you learned earlier in the course that in get static props, we should return an object with a props key where we then can pass any props of our choice to the component. Now here, I guess it makes sense to set a posts prop which holds those loaded featured posts. And that's already all we have to do in get static props here. Nothing else is required for this use case. Now we could also be using get server-side props to always fetch all the featured posts when a request reaches this page, but that doesn't make sense here, I would say. It will just slow down this page a lot because we have to go through all the files and go through all the posts for every request without gaining much. Our posts will probably not change every second. After all, we have to change a markdown file to update them. So they are fairly stable. Most posts will probably never change. So get static props makes sense. Now we could add the revalidate key here to make it clear that get static props should not just be executed once during the build process, as you learned, but also at least once every 100 seconds, or every 60 seconds, or whatever you want, for a new incoming request. This would ensure that if our data changed after deployment, we still regenerate our post, and we therefore reflect that latest data without rebuilding and redeploying. We could do that, but again, our posts will probably not change that much. So if you want to set revalidate to have that built-in rebuilding step, you want to definitely set it to a long duration, maybe 10 minutes or even longer, like half an hour. And here I will not set it at all, which means get static props will only be executed once outside of development. During development, it will be executed for every request. But outside of development, it will only be executed when we build the application for production and never thereafter. And I would say this is absolutely fine here for this scenario. Okay, so now with that, we have get static props. We set the posts prop, which holds the featured posts. And that means that in homepage, we should accept props and then pass props.posts as a value to the posts prop on featured posts. If we now save all of that, and we go back to the starting page, there we should see one featured post now. And now here, the data is actually coming from our markdown file. So if I change something there, like the date from 15th to 16th. Then, since we're in development and getStaticProps runs for every request, then we'll see that if I reload, this switched to 16th as well. So this data is coming from the Markdown file. And now we can do something similar in the All Posts page. Of course, feel free to try this on your own first. Here's your chance to pause the video and try it on your own first. After a short pause, we'll implement it together. Were you successful? Let's implement it together on that All Posts page. There, it's very similar to the starting page. So here in Posts Index.js, we don't want to use the dummy posts anymore. We want to get rid of that. Instead, we want to fetch posts from our actual data source. And again, for this, I'll use getStaticProps. So I'll export a function, getStaticProps, to fetch my posts here. Again, getServerSideProps makes no sense for me because we don't want to fetch all the posts for every request. That would not be that great for performance. Instead, doing it once during the build process should be enough. If we ever update our files thereafter and we want to reflect those changes, we just have to rebuild and redeploy. But we're probably not doing that multiple times every day. And if we ever add a new post, since it's part of the overall project folder, we will need to redeploy anyways. So that also won't be a problem. Hence here, again, I will just call getAllPosts and make sure to add that import to the getAllPosts function here. And this then gives us all the posts. And we then just return an object with the props key, which holds the props object, where we can set posts to all posts. Again, we could add revalidate, but for the reasons explained before, I'll not do it here, because if we add a new post, we'll have to redeploy anyways, since it's part of the overall project folder. And if we change an existing post, we can also redeploy. We're probably not doing that all the time. Hence now here in the All Posts page, we get our props now, and we now use props.posts, since I used posts here, as a value for posts on all posts. And yes, that is a lot of posts, I know. But now with that, if we save this and reload the All Posts page, we only got one post left here, and that is that one single post for which we added a Markdown file. Let's now work on the single post page, and let's fetch the actual post data from the Markdown file here as well, and let's make sure that everything is output correctly. So let's now fetch our actual post data for this single post here. Now the cool thing is that in the lib folder in the posts.util file, we already got this getPostData function, and we can basically utilize this. The only problem we'll have is that it expects a file name. It expects a file name, and when we load a single post here, we'll only have the slug, which is the file name without the file extension. So we either convert this slug to a file name by adding an extension here when reaching out to getPostData, or we make getPostData more flexible. We could, for example, name this post identifier to make it a bit more generic. Then we create the post slug right away as a first step by taking our post identifier and replacing the extension. And if it doesn't have that extension, that's no problem. So if we received just a slug, replace will just do nothing, which is also fine. And then here, when we need the file path, we don't just pass in the post identifier, but instead we create a string with a template literal, and we use post slug, which is guaranteed to not have an extension, and add .md here. So we always create a file path or a file name with extension here. And if we restructure our code like this, it should already work. Now we can call getPostData with a file name, with an extension, or with just a slug. Therefore, now we can export this to then use it in our single post page. Because here I want to get a single post for a given slug. Now for that, here in post detail page, I'll again export a function, the getStaticProps function. Again, for the same reasons as mentioned before, getServerSideProps could be used here, but isn't better. And then here we get this context object. We get this in all getStaticProps functions, but we haven't needed it before. Now we do need it because we can get our params out of context. That's what you also learned in the course. Context has a params key, and that simply is then an object with the concrete values of all the dynamic segments that might lead to this file. So in this case, we'll be able to extract the concrete slug value from params because we have that dynamic segment in this file name. So here we then have the slug, which we get from params. And now we can use that slug to get the data for a single post. With getPostData, so importing that function from the lib folder and the posts util file and passing the slug as an argument. That will then give us the data for that file. It will read that data for that file, and it's able to read that because getStaticProps executes during the build process or on the server, not in the client. And then, therefore, we get our post data here. And hence, we can then return our object, as we always have, where we set the props for our component. And here we can add the post prop, which holds that post data. And here we could make a case for adding revalidate. Here, we're not going through all the posts. We're fetching the data for a single post. So this will be very fast. And if we set revalidate to, let's say, 600 here, then we ensure that if we ever updated a markdown file without rebuilding the entire application, that then still we do get that latest data at least once every 10 minutes, so that we don't have to rebuild the entire application just because we fixed a typo in one of our markdown files. We could do this here because here rebuilding after deployment will be much faster than if we do it for the other pages where we have to go through all the post files, which takes a bit longer and therefore would slow down some of the requests. Here it would not slow down the requests at all, or not by much at least, and we only do it once every 10 minutes anyways. Of course, you can tweak this duration to a duration that fits your needs though. You can make it longer or shorter. But with that, we now have getStaticProps here. However, since this is a dynamic page, you learned that getStaticProps can't work on its own. We need to pair it with getStaticPaths to let Next know which concrete slug values it should pre-generate. And therefore, we need to export another function here. We need to export the getStaticPaths function. This returns an object with all the paths that should be prepared. So with all the concrete values for a slug that should be prepared. And that's an array full of objects where we set params to another nested object and then provide our concrete slug values. That's what you learned. Now we can not prepare anything and basically just set paths to an empty array and set fallback to true. Then the data will be prepared and fetched on demand when we visit this page. With fallback true, we should also render some fallback content though for the scenario that the post hasn't been loaded yet. Or we set fallback to blocking to wait until it has been generated. This could be fine, and it could be fine if you have a blog with thousands of posts where a lot of those posts are rarely read and rarely visited, and you don't want to pre-generate all those posts. Then using a pattern like this could make sense. Or you pre-generate some of your posts, your most popular posts, and not all of them. In this blog here, where we will only have a couple of posts, only a couple of dozens or hundreds of posts, pre-rendering all posts isn't too difficult and isn't too much work, and hence I'll set fallback to false and explicitly define all paths in advance. And for defining all paths in advance, I need to know which paths we have. Now we can get all those paths by using another function from the posts util folder. There in getAllPosts, we get all our post files. Then we also read all the data from there. Now that's a bit overkill here. I'm not interested in all the data here. I'm just interested in getting the post files in this case. Hence, I will actually refactor this and put this here, this code, where I read all the files from the posts directory into a separate function, maybe here at the very top, which I'll name getPosts files. And there I'll return fsReadDir_sync. And I'll export this function so that we can also use it outside of this file. And then down there in getAllPosts, I'll now call getPosts files so that this works again. So that allows me to just get all the post file names without doing all the sorting and mapping, which will slow down the process a bit, which is just not needed for pre-rendering the individual post files. So this gives me all the post file names with the file extensions included though. We should keep that in mind. And therefore, in Slug.js, I now can call getPostsFiles. So I'll import that function and call it from the lib folder and the posts util file. Now this will give me all the post file names. And here I'm actually just interested in the slugs, so the file names without the extensions. Hence, I'll create a slugs constant, and that just is post file names, where I map every file name such that I remove the extension. So I'll just again replace this regular expression, which we also used here. So I'll just copy that code in the end and replace that with an empty string. So that now maps all my file names into just slug strings. And now we can generate paths here by going through all the slugs and mapping every slug into an object, hence the parentheses around it, so that this is not treated as the function body, but as an immediately returned object, where we have the params key, which holds another nested object, where we set slug equal to slug here. And we could also do this in one step. I'm doing it in 2 steps here to make it a bit more readable. So this will now generate an array of path objects, and we are generating all our paths in advance. So we are pre-generating this single post page for all our posts in advance. Now this should work. In getStaticProps, we return our post prop. So now we can use this here in the post detail page and get props and set a post prop on post content and pass props.post into that. And then go to post content to use this post prop instead of the dummy post there. So in post content, I'll get rid of that dummy post and instead accept props here. And then here we can, first of all, extract our post from the props and then use post.slug here and post.image and here post.title and of course here also post.content. If we do all of this, if we save everything and reload this page, it should work. You should see the image, the title, and the actual content as we wrote it in the markdown file. Now, it is, of course, up to you to then add styling for the different content elements you might have. You can do this with the post content module CSS file. Here, by using the content class and then selecting different elements in your content, you can style them and change link colors, change the display of tables, whatever you might have. But with that, we are fetching our actual post data. And therefore now we can click on a post here, see it, click on it here, see it, and it just works.